Hello there. My name is Michael J. Shannon. Let me tell you a bit about myself. I have almost 30 years of IT, security, and information systems experience as I've worked as an employee, contractor, and consultant for companies like MCI, Platinum Technologies, Fujitsu, IBM, State Farm, MindSharp, O'Reilly, Skillsoft, and of course Pearson. This is a very exciting and special course in several ways. First, it will help you jumpstart your career in many aspects of cloud computing with one of the most popular cloud service providers in the world, Microsoft Azure. Second, this course will teach you everything you need to know to pass the exam. In addition, Azure Administrator Associate is the prerequisite for the Microsoft Certified Azure DevOps Engineer Expert Certification. And finally, this course will also be an excellent first step in preparing you for other cloud-related certifications, if you so choose. Cloud computing is considered one of the top IT fields for 2020 and beyond, and I'm very excited to get started on this journey. But first, let's see what we're going to cover in the live lessons series. Module 1, which has 4 lessons, is titled Manage Azure Subscriptions and Resources. In Lesson 1, we'll get started with managing Azure subscriptions. Analysis of resource utilization and consumption is covered in Lesson 2. Next, we'll manage resource groups. Then, in Lesson 4, we'll manage role-based access control, RBAC. Module 2, which also has 4 lessons, is called Implement and Manage Storage. In Lesson 5 of this module, we'll create and configure storage accounts. Next, we'll import and export data to Azure. Then, we'll configure Azure Files. And finally, we'll implement Azure Backup. Module 3 is called Deploy and Manage Virtual Machines. In the first lesson of this module, Lesson 9, I'll show you how to create and configure a VM for Windows and Linux. I'll follow that up with automating the deployment of VMs. After that, I'll teach you how to manage Azure VMs. And to finish up this module, I'll explore management of VM backups. Module 4 has 6 lessons, and it's all about the virtual networking infrastructure. In Lesson 13, we'll create connectivity between virtual networks. In Lesson 14, we'll implement and manage virtual networking. Lesson 15 covers creating and configuring network security groups, NSGs. Next, in Lesson 16, we'll implement Azure load balancers. Then, in Lesson 17, we'll monitor and troubleshoot virtual networking. In the last lesson of this module, we'll integrate on-premises networks with virtual networking. The final module, Module 5, is titled Manage Identities. The 4 lessons in this module cover managing Azure Active Directory AD, managing Azure AD objects, implementing and managing hybrid identities, and in the final lesson, implementing multi-factor authentication, MFA. Module 1, which has 4 lessons, is titled Manage Azure Subscriptions and Resources. In Lesson 1, we'll get started with managing Azure subscriptions. Analysis of resource utilization and consumption is covered in Lesson 2. Next, we'll manage resource groups. Then, in Lesson 4, we'll manage role-based access control, RBAC. Lesson 1, Manage Azure Subscriptions. In this lesson, we'll assign administrator permissions, we'll configure cost center quotas and tagging, and we'll configure Azure subscription policies at the subscription level. During sign-up to Microsoft Azure, users purchasing online subscriptions will create an organization ID, or an org ID, which is an account ID. The org ID is owned by the account administrator, also referred to as the AA, who can manage accounts and subscriptions, as well as perform tasks like deploying services for each subscription. Azure accounts have 3 roles: three core roles that are applicable to all resources: owner, contributor, and reader. Each role corresponds to its own permission level. You can grant access permissions by assigning a role to a specific range of management groups, subscriptions, resource groups, apps, and individual users. Keep in mind, for the exam, a maximum of 2,000 roles can be allocated to each subscription. Since this is our first lesson, let's go ahead and pop over to the whiteboard and see how Azure Active Directory and tenants work together. Well, at the top of the management chain, we have AAD, and that is Azure Active Directory, and that is tied directly to the tenant. Each tenant has its own directory. What's really cool is if you already have an account with Microsoft, let's say an Outlook.com account, you already have your own virtual Azure Active Directory just kind of waiting there for you to activate. So when you use that account and you go sign up, it's right there waiting for you. So that's kind of cool. Now it comes in 4 different tiers. Most of you, when you're getting started, you'll do the free tier, right? And that's what I did at first. And then you're going to go up and probably use the basic tier. And for the exam, you can actually get by with just using the basic tier throughout the entire preparation process and not worry about going up to, let's say, a premium 1 or a premium 2 tier, okay? Those are the 4 tiers. We'll talk more about those in upcoming sub-lessons. And of course, here we have our tenant, and our tenant is using the fictional tray research, which we can use from Microsoft. And again, by default, in a multi-tenancy model, each tenant would have its own directory. Now, under the tenant, kind of the next level of the hierarchy, we have our subscription. And you can have 1 or more subscriptions. In our training that we're going to go through, we're just going to deal with 1 tenant and 1 subscription. That's all you need to worry about for the exam. So we could have subscription A, which is, let's say, the R&D department, research and development. Maybe sub B could be, we could call that the production, right? So we do our R&D here in A, and our production, our results are going to be in sub B. Then at the subscription level, you're going to have what are called resource groups. And again, you can have 1 or more resource groups. So subscription A, R&D, they've got multiple resource groups, and they're going to divide up their resources. They're going to partition those resources logically for their research and for their development. So maybe RG1, resource group 1, let's say it's the research group or resource group. D, or development, maybe they're going to use RG2, and within those you have all of your different Azure resources. Let's say that subscription B over here, or production, they're just going to use 1 resource group that's going to have all of their resources in it. So when you're using the ARM model, the Azure Resource Model, this is kind of what it looks like. This is the model we're going to be using throughout this training, not the classic model, okay? Also, these resources, and we're going to learn about this as well, these resources can have quotas. Okay, I'll just put a Q here. Those quotas are also called limits. And each resource has its own kind of default quotas or limits. We'll take a look at some resources to give us some ideas about that. So when you're a user, okay, and you sign in, for example, to your directory or your AAD for whatever your tenant is, let's say you choose that, only the resources that are in the subscriptions and in the resource groups are available to that user who logs in. If you want to get access to different resources, okay, you have to log into a different directory. Now, at a high level, we have other mechanisms that we can use. For example, we'll learn about SAS later for users to actually get access to resources and other tenancies, okay? But for now, that's the way it works when you log into your directory. This is what you get access to. So keep that in mind. If you want to manage resources somewhere else, got to log in or change your directory. Well, for this training course, I went ahead and created a new billing account and a new directory through my Outlook.com email. I do have other Azure accounts. I actually have an MSDN subscription through an employer, and I could have used that account, but obviously I'm not going to. But as you can see, as I come in here for the very first time, notice that it reminds me that I have the free Azure Advisor. And so if you're new to Azure, maybe you're going to create your own account just for the sake of this course to learn the administrative aspects and pass the exam, you might want to go in here and just view the free recommendations where they go through and they give you some recommendations for high availability, security, performance, and cost, as well as tips and tricks. So you can always access this again later. Again, it's the Azure Advisor, something you might want to dip into and explore early on in your journey through using this product solution in the cloud. Well, in this first demonstration, we're going to talk about assigning administrator permissions. So let's go ahead and do just that. Let's go over to the menu. We want to choose Azure Active Directory. And in the Azure Active Directory area, we're looking for roles and administrators. So we'll click on that. Here we can designate certain administrators to manage identity tasks in a less privileged role, as well as administrative roles. For example, we might want to assign specific administrators for adding or changing users, resetting user passwords, maybe managing licenses, or managing domain names. Notice that my role in this newly created account is Global Administrator. That gives me access to all of the administrative features. So since I'm the person who signed up for this subscription, I get the Global Administrator role for this directory, which, by the way, as you can see in the upper right-hand corner, I'm using my default directory. Only global administrators and privileged role administrators can delegate administrator roles. So make sure you're very careful when you assign this role. We want to call that using the least privilege principle. You can see that we have some specific administrators here. We have Application Administrator, which can create and manage all aspects of app registrations and enterprise apps. There's an Authentication Administrator, which can view, set, and reset authentication method information for any non-admin user. Here's the Azure Information Protection Administrator, and again, several others. Cloud Application, Cloud Device, on and on down the list. You even have Search Administrator to create and manage all aspects of Microsoft search settings. Let's go back up here to Application Administrator, and we'll click on that. And then we can add an assignment, and then basically choose a user, or we can search in our directory. Here's a user called Tom Jones in my default directory. Click on that one, and we can select it and assign this user as Application Administrator. Now, to create the user, and we're going to talk about this later on, but you simply just go to the Azure Active Directory area, click on Users, and just add a new user. We'll be looking at these aspects later on in this training. Now, you might not want the user that's associated with the actual Microsoft account. As you can see here, my name and my email address associated. You may want to go in and create a new user and say, look, this user, which will say Global Admin, and then notice down here it says Directory Role. If I click that out, I can, obviously, it's going to assign a password to it automatically, and you can click on this and you could show the password. But notice you could also assign it as a user or a global administrator here. That might be an option instead of actually managing your Azure directory and cloud experience through that user that created the account. Or here you can see again, limited administrator. And again, it's going to give you this same list that we saw earlier when we were assigning the role. By the way, if you click on this link, learn more about directory roles, it'll bring you to this page, and you can see that it's going to give you more information about the available roles. Now, you don't have to memorize all of these for the exam, obviously, but it wouldn't hurt just to have a general idea of some of these different types of administrators, okay? Because that's the whole goal of this particular task that you're going to be tested on, and that is assigning administrative roles to users. All right, we'll see you in the next lesson. In this lesson, we're going to look at cost center and tagging. Now realize that Microsoft will commonly use the phrase limits instead of quotas. Also, there are service-specific limits or quotas, for example, Active Directory, App Service, etc., that are applied with ARM, Azure Resource Manager. That's what we'll be using throughout this entire training. Subscription limits can be applied when you use Azure Service Management or Azure Resource Manager. Let's define some terms. A resource is a manageable item that is available through Azure. A resource group is a container, a logical container that holds related resources for an Azure solution. A resource provider is a service that supplies Azure resources. A resource manager template is a JSON file that defines resources to deploy to a resource group or a subscription. Then we have what's called declarative syntax. This is syntax that lets you state, quote, "This is what I need to create," without having to write the sequence of programming commands in order to create it. Tags are metadata for organizing and categorizing cloud-based resources. You can use tags for resource management, automation, and accounting. And your tags can be IT aligned or they can be business aligned. Azure currently supports up to 15 tags per resource and resource group. Tags can be placed on a resource at the time of creation, or you can add them to an existing resource. Tags are supported for resources created via the Resource Manager deployment model only. Okay, now that we've defined some important terms, let's take an inventory of where we are. Remember in the previous lesson 1.1, we went in and we created at least one global administrator, some user who's not the original Microsoft account creator. So we did that, showed you how to do that, and this could be a user that's in the Azure default directory, which you can see up here. I'm using the default directory, or it could be some other Active Directory instance that you decided to use. Now, regardless of whether you're going to populate your Azure Active Directory or possibly use single sign-on from your own corporate Active Directory, really the next thing you have to do is consider upgrading from the free trial, which is exactly what I did. So if you're using the free trial, you want to go ahead and upgrade to a pay-as-you-go account so that you can get all the different features that you want to learn about to pass this exam as an administrator. So once those two things are done, the next thing to think about is, as an admin, what types of resources are going to be brought up to the cloud environment. Now this is a decision that's kind of an architectural decision. It kind of goes back beyond just an administrator. Typically, we're going to manage or administer the resources that some other team, an architectural team, a development team, an engineering team, is going to decide to bring up into the cloud. Regardless, on the exam, you need to be aware of cost management and the cost center. Okay, so in other words, you want to think about the cost-benefit aspect of taking resources that are either physical or virtual in your own data center, in your own server farm, in your own on-premise environment, and then either doing a physical to virtual migration up to the cloud, up to Azure, or a virtual to virtual migration up to Azure. Also, your solution may be a hybrid cloud where not all of the resources are going to be going up to the cloud solution. So those are decisions that have to be made, right away. As you can see here in my subscriptions, I've activated my pay-as-I-go, and I've disabled my free trial, which I said is after you create that one global administrator, this will be the next step, the pay-as-you-go option. So the next area to be aware of on the exam is the cost management link. We can click on that and we're going to see some wizards that we can go through. Visualizing and monitoring our costs and trends. Again, making sure that we're getting the best bang for our buck in using the cloud. So you can see a couple of wizards here. You can analyze cloud costs. You can open up cost analysis. You can monitor by creating budgets. And you can also optimize by viewing recommendations. And so most likely you're going to want to go and follow those links. But let me show you a document that I want you to get your hands on. Now, I'm not going to do a lot of this throughout this training, okay? I'm not going to go and find some docs.microsoft.com and just teach from the document. But here's the deal. This has a ton of information on Azure limits or quotas. Okay, those terms are kind of synonymous really in Azure. The problem is I could go and I could build slides about all of these different limits, but look at all the different service-specific limits you have to look at here. Okay, alphabetical, they're huge. And, you know, I could build slides, I could, create additional content to teach all this to you, but it's just much easier to go and look at this document. Like I said, I won't be doing this a lot in this training, but notice that, for example, subscription limits. This is the classic deployment model, but let's go down here with ARM, because this is the newer model, the Azure Resource Manager, okay? So subscription limits. So you can see VMs per subscription, 25,000 per region, or 25,000 maximum limit. Total cores prescription. And you can see some of these for maximums, you can contact support. So unless it gives you a maximum, you may be able to go to Azure and get them to raise the limit on a case-by-case basis. Now, you don't have to memorize this, but there's some things I want you to be aware of for the exam. That limits are often called quotas, okay? So keep that in mind. We are going to take a look at the pricing calculator, okay? That's a tool you need to be aware of for the exam. Another great document that you might want to add to your knowledge base is this Prevent Unexpected Costs with Azure Billing and Cost Management. So if I open that in a new tab, this would be an excellent kind of best practices. It's a pretty recent article. So this is the best approach, okay? You want to get estimated costs before you add any Azure services. Use the pricing calculator. And this is a best practice that they'll expect you to know for the exam. Now remember that free trial subscriptions aren't eligible for limit or quota increases. Remember that. If you aren't comfortable doing that and you want to just keep your free trial, that's fine. You can just learn from watching my videos and my demonstrations, and of course you don't have to worry about spending any money. We will be learning that you can combine multiple resources into a resource group. And so remember, when you use a resource group, the limits that were once global become managed at a regional level through ARM. And again, these quotas or limits in Azure resource groups are on a per region basis, accessible by your subscription. Okay, let's go ahead and take a look at the pricing calculator. I can follow this link right here. And notice, by the way, and I'm going to encourage you to come in and use this tool on your own. Notice that you have different categories of products over here. Compute, networking, storage, these are the main core services of Azure: compute, networking, storage, databases, analytics. So you can choose those if you want to right here. And you can, of course, just click on virtual machines. This is where we're going to begin, okay? So we're going to keep it simple, and we've added virtual machines now. So we can scroll down here, and you can see that they've went ahead and chosen one for us, right? So we're in the West US region. The Windows operating system, or I could choose Linux. I'm choosing operating system only, although I could also choose a BizTalk or SQL Server, and then I'm choosing the standard tier. And there are 3 tiers. We'll talk about these in greater detail later, but for the exam, remember, you've got the basic tier, the low priority tier, and the standard tier. And you can see that they've kind of chosen a instance for us from this list. The D2 version 3 with 2 virtual CPUs, 8 gigabytes of RAM, 50 gigabytes of temporary storage, and about 20 cents per hour. Notice down here are billing options. The default is to pay as you go, but you can reserve them for 1 year and save about 18%, or reserve them for 3 years and save about 32%. And you can learn more about these reservations by just right-clicking on this link and just opening this in a new tab, okay? If you go down here, you can choose your number of virtual machines, right? So we see here we've only got one. They're billed per second, and for 730 hours, you can see the cost would be about $152.57 per month. If I add another virtual machine to that by putting in 2, you can see it pretty much doubles the cost. Now, this is going to be for a standard hard disk, but most of us are probably going to want to use SSD, right, which is going to be our solid state drive. And you can see when we choose that option and we choose different disk sizes, well, we're going to have different costs. Okay, so if I add one disk there, or if I want to do 2 disks, which might be more practical, you can see I get up to $9.60 per month. And then, of course, down here for storage transactions, 100 transaction units, and a unit is 10,000 transactions. You know, a very small charge, but you can see here's my subtotal, and this is on a monthly basis. We can also add some additional support. The included is kind of like basic, right? So if you ever use Amazon Web Services, they have 4 different types of support plans: basic, developer, professional, and enterprise. So here they have kind of the included, which is basic, then developer, then standard, then professional direct. So this is a tool that you would want to use and be familiar with. We just went in and just did a simple virtual machine, but obviously we could go in and look at some other things, but we haven't yet talked about and learned about these other types of services yet. So this might be something we're going to come back to on a regular basis as we learn more and more about all these different and how to administer all these different types of Microsoft Azure services. Now, to wrap up, I did mention and I defined tags in the introduction. That's another objective of this lesson 1.2. We're actually going to configure tags later on as we start to spin up other resources up here in the cloud. So we made sure we defined what they are. It's just metadata that we use for a wide variety of reasons, and we'll actually add those as we go through our different services and resources in Microsoft Azure throughout this course. Subscription policies can use Azure Resource Manager, ARM, and Azure Resource Groups, or you can use the classic deployment model, Azure Service Management. We're not going to be doing that in this training. Now, in my next demo, I'm going to focus on the subscription level policies. Let's go to the demonstration. All right, like I said in the introduction, the first compliance tool or technique I want to use is tags. So I've got a test resource group here. I'm just going to click on that, and we're going to see that I've got a small machine, virtual machine of VM Ubuntu called dev VM1. I'm going to select that. And when I do, over here on the left-hand side, I'm going to see tags. So the tags are what we would call arbitrary key value pairs. Okay, so the name is the key and the value is the value. And we assign these to, here, for example, individual resources like a VM, or you could also assign them to a resource group, but they play a huge role in things like automation, in billing. You can use them for your cost center activities. You can use them to identify different environments like, dev, production, testing. You can do it for projects. You can do it for different ownership. You can also, let's say, have importance or criticality like low, medium, high, and critical, things like that. But let's say we're going to add a tag, and we're going to call this shutdown. And then the value we're going to use is going to be a value of 2000, because what we want to do is we want to shut down at 8:00 p.m. Okay, so we're going to create this, and then, as you can see here, we can use an automation script to basically target VMs. If we can just say, where the tag key is shut down and the tag value equals 2000, then we can force a shutdown at 8 p.m. And then we could even say, a little message that we would see if this happens, the VM host name, right-host, then VM name. In this example, dev-VM-1 has been shut down. That would be the message. And then again, another big usage of tagging is to tag your resources like your storage accounts, your VMs, your web apps that might belong to certain applications or workload and add other information. That way you can leverage that information in your billing report and in your cost center. All right, well, let's look at our second method for subscription compliance, and that's going to be the Azure policies. Also, as I mentioned, the third technique you want to remember for the exam is resource locking. We'll look at that in lesson 3. Okay, so to create a policy assignment from here, I'm going to go over here to where it says All Services, and I'm going to go ahead and just search All Services and just type in there P, and I'll see Policy, and I'll click on that. Over here on this sub-menu under Policy, you're going to see Authoring. And then under Authoring, we want to click on the Assignments link. An assignment is a policy that's been assigned to take place within a certain scope. My scope is my pay-as-you-go account. Up here I have Assign Policy, so I'm going to click on that. If I don't want to use my subscription pay-as-you-go, I could click on the ellipsis and I could also choose, let's say, a management group. Okay. Now again, the goal here for the exam is a subscription policy. You could also choose a resource group. You also have exclusions below that. So you could exclude a resource based on the scope. These are optional, so I'm going to leave that blank. Then you have the policy definition. Actually, if you click on the ellipsis, you'll see a list of available definitions. Some of these are pretty granular. Audit virtual machines without disaster recovery configured. Audit VMs that do not use managed disks. Disk encryption should be applied on virtual machines. Here's required tag and its value. I'm going to go back up and use this other one that's built in called Audit VMs that do not use managed disks, and choose Select. Notice the assignment name will automatically get populated with the policy name that I chose, but I can change this. I can also add an optional description down here if I wanted to. Notice it's assigned by me. We're going to leave Create a Managed Identity unchecked. You would have to check this box if the policy or the initiative includes a policy with the Deploy If Not Exists effect. So we'll just click on Assign. By the way, if you click on the name and you view definition up at the top, you can actually see the definition in JSON. Okay, so eventually, if you start to do more in JSON, this will be quite valuable for you. I can click on the X at the upper right-hand corner and then go back to Policy Assignments. Finally, I'm going to go up here to the Policy Assignments menu, and down here below, look at the link that says Compliance. When I click on that, I'm going to see my non-compliant policies is 1 out of 1. So I actually have a resource in a non-compliant state. If I click on it, I'll notice that I have a resource called devvm2. It's a virtual machine. It's in the test group resource group, and you can see the resource type here. And the bottom line is, before I actually created this definition, I went and spun up another VM, another dev VM, and I chose the option not to use managed disks, therefore making sure it would show up as a non-compliant resource. I'm going to go ahead and clean up my environment, so I'm going to delete the assignment, and I'll see you in the next lesson. Lesson 2, Analyze Resource Utilization and Consumption. In this lesson, we'll configure diagnostic settings and baselines on resources. We'll create alerts. We'll analyze alerts and metrics. We'll create action groups. We'll monitor for unused resources and utilize log query functions. Tenant logs are going to work on activities on services outside of the subscription, such as Azure Active Directory logs. Resource logs are going to work on activities from services within a subscription, like network security groups or storage accounts. Now take a look at this diagram. Tenant diagnostic logs are configured with a tenant diagnostic setting, and resource diagnostic logs are done using resource diagnostic settings. As we see here in the diagram, they can be configured in the Azure portal, in PowerShell, in CLI, or using the REST API. Now on the exam, keep in mind that the term log analytics will probably be called Azure Monitor Logs. All right, so keep that in mind. Now, if Azure Monitor is used, then the logs are written immediately without having to be written to a data storage first. That being said, the logs are often saved in a storage account for manual inspection or for auditing purposes. And then they can be streamed to event hubs or log analytics or, like I said, Azure storage. Keep in mind that I could use a storage account or event hub's namespace that's another subscription than the one that's actually sending the logs, as long as I have the appropriate RBAC on both subscriptions. Now, I've been an ITIL practitioner for years, and I'm all about continual improvement. And you know what? You should be too. But before we can actually improve our environment and get continuous integration, continuous improvement, we have to establish baselines. And once we establish the baselines, we can then optimize and improve our environments. So to determine some key performance indicators and metrics, we want to collect some data. And we can collect data directly from our virtual machines, as well as other resources, into a single repository, which will allow us to do detailed analysis and correlation, and again, continual improvement. The first thing we want to do is we want to create a workspace for Azure Log Analytics. I'm going to go on the main Azure menu up here on the top left and click on All Services. And I'll just start typing in log. Click on Log Analytics Workspaces. We'll click on Create. By the way, this used to be called the OMS workspace. I'll put in a workspace name, main BL baseline workspace. Pay as I go. Choose my test group, resource group, locate Central US, and the per gigabyte pricing tier is fine. And we'll catch up when it's finished. Okay, so that's completed. Notice that I'm under Home and then Log Analytics Workspaces. That's the path. Here I can see my main BL workspace. Now I already have a Windows and Linux VM deployed in Azure, so I need the Log Analytics agent on those instances to be able to get log information from them. I can install the Log Analytics agent with the Log Analytics VM extension, which makes the installation process easy, which also makes it easy to send data to my main BL workspace. The other good thing about the extension is that the agent will be upgraded automatically with the latest features and fixes. Let's click on the main BL workspace. I'm going to go to the Log Analytics menu here to the left and scroll down, and I'm looking for, under Workspace Data Sources, I'm looking for Virtual Machines. I'm going to click on that. And here's my two VMs. One's Ubuntu, one's a Windows server. Let's say I want to install the agent on the Windows server. Notice, by the way, under Log Analytics Connection, it says Not Connected. I'm going to click on the Connect button. Now the agent's going to be automatically installed and configured for my Log Analytics workspace. Takes a few minutes, so I'll catch you up when this process is finished. Alright, I'm successfully connected. Notice that the disconnect button is activated. I also got a little pop-up in the upper right hand corner. So let's go back to the main BL workspace. I'm going to scroll up here and go to Advanced Settings. Log Analytics can collect events from event logs in Windows or the Linux syslog, as well as performance counters that I designate. I might need that for long-term analysis and to generate reports. I may also want to take an action if some particular condition shows up. So let's go ahead and configure a collection of events from the Windows system log. I'll choose Data. Notice I have Windows event logs, Windows performance counters, as well as Linux performance counters, IIS logs, and syslog at the bottom, as well as custom fields and custom logs. I'm going to go down here and choose Windows Performance Counters. That's a great way to start building that baseline, right? I'll just type in here System with a plus sign, and it says Welcome. Add some counters by searching for them, and you can add some common counters below to get started quickly. I'm going to click on Add the Selected Performance Counters button. Notice they're added with a preset of 10-second collection sample intervals. That's fine. I went ahead and removed all of the disk-related counters, so I just have memory available megabytes, network interface, processor, percent processor time, and system processor queue length, and then go up here and click on Save. I'm going to go back up to my main BL workspace. Over at the workspace menu on the left, we want to go to Logs. Click on Logs. We're going to have an opportunity to do a simple log search. So I'm going to type in my query. I'll just put in PERF. So I typed in perf and I clicked on Run, and you can see down here I've got basically in a table format. I can do table, chart, change my columns, but you can see down here I've got 13 pages with 50 items per page. But I can expand this out and I can see tenant ID, the computer, the logical disk object, the resource ID. Of course, the value is what we're shooting for here. Now we can also automate this, and we haven't really talked about using PowerShell yet, and the exam will probably have about 10 to 15% of the questions using PowerShell, not really heavily tested on this exam. But if we wanted to use PowerShell to stream Azure diagnostic information using an Azure PowerShell commandlet, we could do it with these parameters. So we use the set AZ diagnostic setting commandlet. Notice that our resource ID is going to be your resource ID. We'll need the workspace ID, and that's the resource ID of the log analytics workspace. So notice I'm back here in the main BL workspace. This is the actual workspace ID. And this just reminds us that the workspace ID property is the full Azure Resource ID, not the workspace ID key that can be displayed. Then you could have categories, a list of log categories, and then enabled true to finish that off. I hope this demo was informative for you. See you in the next lesson. Alerts proactively notify you when significant conditions occur in your monitoring data. They can help you identify and tackle issues before the system users notice them. For example, metric values, log search queries, activity log events, health of the underlying Azure platform, and testing for website availability. Let's go to the Lightboard and see how alerts actually work. Let's talk about alert rules now. And one thing to remember about alert rules is that we separate the actual alert rule from the actions that we take and from the alert itself. Okay, so keep that in mind. They're totally separated from the action and what happens when the alert fires. Now, within the alert rule, which basically is going to capture the target and the criteria for alerting, we have what's called the target resource. Now, realize that the alert rule itself can be in an enabled state or a disabled state. So in other words, you can create the alert rule, set up all the criteria for it, and then just have it disabled. And when you want to bring it up, you can just enable it. So it's kind of an object in that regard that is enabled or disabled. And again, the alert itself is only going to fire. It's only going to take the action when it is enabled, and that makes sense. Now, the target resource basically defines the scope, and it defines the signals that are going to be available. Here's our little signal for alerting. So what are example targets? Okay, a virtual machine, right? A storage group, a scale set, a virtual machine scale set. It could even be a log analytics workspace. Remember that we set that up in the previous sublesson 2.1, right? So, we could also use an application insights. So don't forget about that. That could be one of our target resources as well. Now, for certain resources like virtual machines, we can specify multiple resources as the target of the rule. And of course, that rule is going to have different types of criteria, or it might have a logic test, right? An and or an or, that type of thing. Okay, so next we have signals. Let's talk about signals for a second here. These are emitted by the target resource, and you can have several different types of signals. It could be a metric, it could be an application insight, a signal could be a log, for example. Criteria, okay, our criteria and our logic test. The criteria is a combination of a signal and logic that's applied on a target resource. For example, we could say percentage CPU, right? Percentage CPU greater than 83%. Okay, that could be a criteria for taking some action or some alerting, right? That's a pretty high threshold. If we meet that threshold, we're going to take some type of action. You might even have something like server response time. Okay, I'll put SRP. Server response time greater than 8 milliseconds. That might be one of your criteria, okay? Or it could be the result count of a log query, like greater than 120, something like that. So that's our criteria and our log test. The alert is going to have a name, okay? So that's going to be a specific name that we assign to the alert. We configure that as the administrator. There'll be a description, which is optional, okay? So we can describe the alert, and usually adding that metadata to your alerts is going to be very beneficial in the long term. So we like to use descriptions. There's also a severity level, okay? The severity of the alert is specified in the alert rule set, and that's typically going to be a range from 0 to 4, okay? So we have 5 different levels of severity, right? 0 being the lowest, 4 being the highest. Of course, we have the action that we take. This is a specific action that we take when the alert is fired. And we're going to talk more moving forward when we do our configuration. We're going to talk more about action groups, okay? And the action group is a logical container that has one or more actions that we perform, okay? And we'll also talk about monitor conditions, which actually has various alert states. So when we get into the configuration of these alert rules and action groups, and we get into various activities, we'll also get into deeper explanation of these. But just understand, as an overall kind of comprehensive approach, what is an alert rule, and be able to define different things like target resource, signal, and criteria, and various aspects of the alert rule for the exam. I'm going to start out this demonstration in the All Resources area. So I'm up here, the path is Home, All Resources, and you can see I've grouped these by type, and so it makes it easy for me to see the different types of resources I have. And so far I've got these 2 virtual machines. The Ubuntu VM is not running, and the Windows Server is running. Now we're talking about metric alerts, and metric alerts in Azure Monitor give us an excellent way to get notification if we cross some threshold. Alerts work on a wide variety of different metrics, including custom metrics, application insights, standard and custom metrics as well. In this demonstration, I'm going to create, view, and manage metric alert rules through the portal. By the way, you could also create metric alert rules using the ARM templates, but those are coming up later on in this training. Now, the reason why I started out in the resources, I wanted to show you that we could go to an actual resource blade. Like if I click on Windows Server 19.1 here, I can actually go to the resource blade, and I can scroll down, and I can see alerts. Okay, so remember that under the monitoring area, you could also create alerts from there. That's not what we're going to do though. Okay, we're going to go back up to the Azure portal, which is the menu on the far left-hand side, and we're going to click on Monitor there. And of course, when you go there, you're going to get lots of different capabilities to walk through, monitor and visualize metrics, query and analyze logs, set up alert and actions. And you can see down here we've got a bunch of quick starts that you might want to do those just to reinforce your knowledge for the exam. So now on the Monitor menu, just to the left, I'll click on Alerts. I'm in my subscription. I'll use my test group. That's where that Windows Server VM is. And we'll just click on New Alert Rule. Under Resource, I'm going to select the target that I want to monitor. Took a while to load that. And if I had a lot of resources, which at this point I don't, and that's kind of a good thing actually to teach this, but I could filter by resource type, I could filter by location, or I could just type in some letters and start searching for it. I'll click on Done at the bottom. Once you choose your target resource, go below and click on Add Condition. What we see is our signal logic. And there's 124 signals. I don't have time, obviously, to go through those. You could search here in the search box. I could also go over here to Monitor Service and say, look, I just want to see the activity log security options. And that would narrow it down to 20 signals. I've also got Recommendation, Administrative, Policy, and Auto Scale. If I click on Administrative here, I'm going to see those. Obviously, if I created an alert on all administrative options, that's going to generate a lot of noise. But I might want to keep it simple. How about Start a Virtual Machine? Let me click on that one. My chart period, I've got over the last 6 hours, 12 hours, 24 hours of the last week. If I scroll down here to the alert logic, I can do all events, or I could just simply choose warning or informational or error. I'm going to leave it with all. Status, failed, started, succeeded. I'm going to choose started. And here's a preview. Whenever the administrative activity log started virtual machines has any level with started status, an event is initiated by any. All right, done. Notice it says we currently support configuring only 2 metric signals or 1 log search signal or 1 activity log signal per alert rule. An alert will be configured when the conditions for all of the above criteria are met. So obviously I could add additional conditions, and that would be a Boolean AND or a match all. Next I'll choose Add Actions. Okay, so I added an action group. It's called Test Action Group. I've got the short name of tag. It's my pay-as-you-go, and it's in my test group resource group. The action name is an email notification, and I'm going to send an email or SMS or push or voice. Notice other options, okay? So alerts can trigger Azure functions. They can trigger webhooks. They can do automation runbooks. So remember that for the exam. I'm going to say email here, and I'm going to fill this in off camera. Okay, so I'm going to give it a alert rule name. Save the alert to my resource group and go to the very bottom and choose Create Alert Rule. Now it can take 5 minutes for the activity log to become active, so I'm going to create the rule, wait 5 minutes for the alert rule to become active, and then I'm going to go ahead and bring up my Ubuntu VM, and hopefully I'll get an email. Okay, so there's my alert under Home, Monitor Alerts and Rules. That's the path. I can add a new alert rule. I can change my action groups. I can refresh, but here's my VM startup alert. And it's enabled. So in the background, I'm going to go ahead and start up my Ubuntu Dev VM. Okay, so I can see here in my Gmail account, I'm now in the tag action group, and here's my important notice. Azure Monitor Alert VM Startup Alert was activated. So there's my information, the log alert, the time, the category, the level, the resource ID, and then I can go right here and view this in the Azure portal and log on.
There's quite a few things we can do with alerts and metrics. We can analyze. You can use Metrics Explorer to analyze collected metrics on a chart and compare metrics from different resources. You can visualize. You can pin a chart from Metrics Explorer to an Azure dashboard. You can create a workbook to combine with multiple sets of data in an interactive report. You can do alerting. You can configure a metric alert rule that sends a notification or takes automated action when the metric value crosses a threshold. You can automate. You can use autoscale to increase or decrease resources based on a metric value crossing a threshold. You can export. You can route metrics to logs to analyze data in Azure Monitor Metrics together with data in Azure Monitor Logs and store metric values for longer than 93 days. You can stream metrics to an event hub to route them to external systems. You can retrieve. You can access metric values from a command line using PowerShell commandlets. You can access metric values from custom applications using REST API. And you can access metric values from a command line using CLI. And you can archive. You can archive the performance or health history of your resource for compliance, auditing, or offline reporting purposes. In this demonstration, I'll show you how to create and review metrics in Azure Monitor. Let's do it.
All right, let's get into metrics. And in the previous lesson, we saw this area. We went to Home and then Monitor on the far left menu. We were dealing with the alerts, but now we're going to go down below that and we can choose metrics. Now, before I do that, you do have some nice wizards over here to explore metrics, searching logs, creating alerts, which we saw. There's also some quick starts down there, but I'm going to click on metrics. I'm going to go ahead and name this chart CPU util win. If I don't like that, click on the pencil and rename it. Choose my resource. Using my subscription, going to choose basically all resource groups. How's that? And then types of resources, I'll go down here and we'll just turn that Windows Server and apply. Now, under metric here, I don't want to blow through this. Okay, I want you to understand for a Windows server, which could be, commonly an IIS server, for example, or it could be doing a lot of other productivity activities for you. I want you to have some type of general understanding of these metrics. Now, the cool thing is, unlike alerts that we saw in our previous lesson, we don't have to create any of these they're readily available for us. So notice we have CPU credits consumed and remaining. We have several data disk options, queue depth, disk read bytes per second, disk read ops per second. I'm skipping the deprecated ones, okay? Disk write bytes per second, disk write ops per second. And we've got disk read bytes. Those are data. We have some disk read and writes. We have some inbound flows. Network in billable, network in total, network out billable, network out total. We have also some OS disk queue. We also have percentage CPU. That's obviously one that I want to add. You can see that once we do that, we can determine how we're going to aggregate that. There we go. By default, it's going to be average, but according to the metric, you may want a count, you may want minimum or maximum or a sum. So let's go ahead and add another metric here, still on the Win server, and we'll go and let's say we're going to choose network in billable. That'll be a sum aggregate. So I've got a couple of metrics in there in my CPU util win. Notice we are seeing these in a line chart. I can also look at these as a grid. I can look at these as a scatter chart. May or may not be helpful with these metrics. A bar chart, an area chart. Also realize I can pin this to a dashboard, either to my default current dashboard. That way I don't have to keep coming back into this metrics area. It's right there on the dashboard. Or I could choose another dashboard, right? So I went ahead and pinned that to the dashboard. Now I'm looking at this over a 24-hour period, time range which can be changed, and the time granularity, kind of the refresh, and I can create a new alert rule. So if I choose the new alert rule, it's going to go ahead and already have that resource in there. I could add another Windows resource if I want to. Got a couple of conditions down here. I don't have any signal logic though, right? So let's go ahead and click on this first one and say percentage CPU, scroll on down. If it's greater than 80% on average, and aggregate every 5 minutes, evaluate every 1 minute, click on done. And then the network in billable, this is going to be a threshold in bytes. So I'm going to put 10 million in there, greater than total, and done. I wanted to show you one last thing here. I want to choose a different resource, and we'll just go quickly through here and just do my test group. And then if I just wanted to deselect everything and then just go down and say, I just want to see, let's say, storage accounts, choose those. And if I choose a storage account and apply, I want you to notice the different metrics here. So we have capacity, used capacity, transaction. Transaction is availability. Egress and ingress transactions. Success, E2E, that's end-to-end latency. And success, server latency and transactions. So going through and looking at different resources and getting a feel, for example, here's WinServer IP, and seeing the different metrics you have. So for example, here's some inbound bytes distributed denial of service. So for the public IP address, you can get metrics on inbound bytes, total bytes, bytes dropped, bytes forwarded of distributed denial of service attacks, also referred to often as a botnet. We also have inbound send packets to trigger DDoS mitigation. So some excellent denial of service metrics and key indicators here. And by the way, cloud providers, whether it's Azure, whether it's AWS, whether it's Google Cloud Platform, that is one of their major activities, and that is analyzing and monitoring and countermeasuring denial of service and distributed denial of service attacks towards their cloud and towards their customers. Okay, so I just wanted to show you that, make sure when you have some time on your own, look at different resources. And as we go through this course and we start getting into different Azure resources, okay, over there on the left-hand side, we see, load balancers, for example. That would be a prime resource to create metrics and alerts on, and we'll talk about that when we get to it. So hope you enjoyed this demo. We'll see you in the next lesson.
Action groups are sets of notification preferences defined by the Azure subscription owner. Azure Monitor and Service Health Alerts use action groups to notify users that an alert has been triggered. You can configure up to 2,000 action groups in a subscription. You configure an action to notify a person by email or SMS, and they receive a confirmation indicating that they've been added to the action group. Each action is made up of the following properties: the name, which is a unique identifier within the action group; the action type, the action performed. Examples would be a voice call, SMS, email, or triggering various types of automated actions. Another property is details, the corresponding details that vary by action type. Let's go to the demo and check out action groups.
Okay, this demonstration on action groups will be kind of short because remember, we already saw and created action groups. Let's go manage alert rules up here in an earlier lesson when we created this VM startup alert, remember? So this is another way that you can kind of get to that area. By coming into the monitor alerts area, you can go right to manage actions. Remember, various alerts can use the same action group or different action groups based on your needs. So we'll click on Manage Actions, choose your subscription, choose your resource group, and then just add an action group here. And so this will look a little bit different than if we did it through an alert, right? So I'm kind of showing you both. Maybe on the exam, you may have to do either or, so be prepared. So you can have an action group name. And by the way, for the exam, remember that you can also use ARM templates, Azure Resource Manager templates, to configure action groups. We're not going to do that, but realize you can do that. I'm going to call this AG12345, short name, pay as you go, resource group. I'm going to go ahead and choose my test group. And again, we give a unique name for the action. For example, if I'm going to use an email, my email, and then the action type, as we saw in the previous lesson, email, SMS, push, or voice. If I choose that one, realize that the email is going to be sent from these three email addresses. I might want to call it, my runbook, and choose automation runbook. There are limits to how many runbooks you can have in an action group. I need to go back and look at your service limits that we talked about in the first lesson. We mentioned also you could, I won't change the name, but we can use a webhook. You can see the URI. They're asking you for the URI. They're very simple. Or an Azure function, which is basically running code without a server. basically functions as a service or running code in the cloud. You can see here a link, by the way, how to create a function app if you want to do that on the fly. Okay, so again, a short demonstration here, but kind of a different way, a different approach to action groups as opposed to going through and creating your alerts and doing it that way. So be aware of both methods on the exam.
Azure Advisor offers personalized recommendations and guides you through the best practices to optimize your Azure resources. It provides guidance that helps you improve the availability, security, performance, and cost effectiveness of your Azure resources. Azure Resource Health assists you in diagnosing and getting support when an Azure issue impacts your resources. It informs you about the current and past health status of your resources and helps you mitigate issues. Resource Health delivers technical support when you need help with Azure service issues.
Okay, so as you can see, I've navigated over here on the menu down to the advisor area. Now, we've already talked about the monitor area. We've already seen that several times already throughout this training. We've looked at the alerts, we've looked at metrics, and we're going to look at some other things as well. But we're going to look at the advisor now because this is going to help us really to maximize our environment. So we've got 4 key areas, and it's refreshing right now, but 4 key areas of recommendations from Microsoft: high availability, security, performance, and cost. With high availability, you can see I've got 5 impacted resources, and they're telling me enable virtual machine backup, use availability sets, and we'll talk about both of those things coming up. The reason why I haven't done those yet is because we haven't yet covered them for the exam. Also, enable virtual machine replication to protect your application. So these are all important things that we're going to learn about later on. Under cost, it's telling me delete a public IP address not associated to a running Azure resource. Well, that's interesting. So let's click on that. What we're going to see is I've got an IP address that's associated with a dev VM1. If I go to resource groups, and this is an indicator, if I look at test group, that I actually deleted a dev VM number 1. But notice, and this is something to understand for the real world and for the exam, when you delete a virtual machine, you do not delete its IP address, you don't delete its network security group. In addition, you may have to run a script to actually delete the underlying VHD file in the storage account that the dev VM used, for example. So I'm going to have to go ahead and delete these resources. I could have chosen both of them, but doing them one at a time. An example of having unused resources can cost you money. Now, what I saw in the advisor was that having that public IP address for a VM that I deleted was only going to cost about $32 a year. But that's just me in an individual account with a couple of VMs. Can you imagine if you're an enterprise organization and you're running tons of resources? Those things can really add up. So the advisor is a tool that you're going to want to use, as well as some of the other tools that we learned about in lesson 1, the cost management and billing area, right? And I can see a list of security recommendations and performance recommendations. And if I wanted to, I could download those as a PDF file or a CSV file. So you will get a question on the exam about the advisor area, specifically as it relates to finding unused resources.
Let's talk about log queries. Queries can start with either a table name or the search command. Let's recommend starting with table names, since they define a clear scope for the query. Search queries are less structured and typically better suited for locating records that include a specific value in any of their columns. The Custo query language used by Azure Monitor is case sensitive. Language keywords are typically written in lowercase, so when using names of tables or columns in a query, be sure to use the correct case. Remember, Azure Log Analytics is the fully managed service.
Okay, so to do some basic queries in the Custo language, I call it Custo. You may hear it called Custo, but more likely than not, you're going to hear Microsoft folks calling it Custo. I'm going to use that Custo query language, and I'm going to use it in the log analytics area. Now, I could come in here and create a workspace again, like you saw me do earlier before, let's say with the alerts, but I'm going to show you this site, which may or may not be available. You can see it up here in my address bar. It may or may not be available. However, you will be able to find up at their site some way to take advantage of some demos. I'm going to use this demo site that's provided in this loganalytics.io because they have a lot more data that's already there. I can take advantage of it. So you can see the run button up here, and I'm going to type in my query. Now, let's say I have a subscription, and I want to create an Azure Log Analytics workspace, and in that workspace, I need to view the error events from a table that's named event. What is the Custo query I'm going to issue? Okay, well, I'm going to issue the command event. And by the way, as I start to type in here, say E, you can see, like any type of programming platform, I can scroll down and choose from a list, right? So a user-friendly programming environment. But I'm going to type in event, and then I'm going to do the pipe symbol, and I'm going to put in the word search, and I want to search a table called error. And I'm going to click on run. And I have to have my cursor in there somewhere inside the actual box, so make sure you do that. They're getting my data, hang in there. And there you go. You can see, and this, by the way, is data that's given to me on site. Notice the computer over here is Contoso and things like that. So this is provided for me. This is a bunch of data that allows me to go and run different queries. For the exam, I'd want you to know this command. But for the Custo on the exam, I'm going to recommend that you do search and then in and then the event and then error and then a run. All right, excellent. So same data, okay? And then we can see them down here. We can go click on one of these and get more metadata about that particular event. Notice the table is called event, and you can see tenant ID, source system, a date and time stamp, the event log, operations manager event log, the computer's Contoso, so it's a Microsoft object, right? You could have an event category, you could have a username if it was applicable to your IAM, and a type event. Notice, by the way, you've got these columns, time generated for tables, and the filter sign next to each one of those. You can filter on the table, filter on the source, the event log, the computer, the event level, so the metadata that we saw, each one of those actual events. And we can also filter certain columns, okay? If we don't want to see a certain column like MG, we can remove that, right? And we can also select all or select none of the columns. We can disable grouping if we want to. Some data might be applicable to be seen in a chart, not so much this type of data. We're seeing this in a table over the last 24 hours. We can also have the display time in UTC or local time, or choose some other time zone. And then obviously we have the ability to copy and export as well. If I want to create a new rule, I can click on the plus sign, create a new query, and I can go ahead and close that one out if I want to. I want to query a security event table for records that have the phrase cryptographic. And of those records, 10 of them will be returned and displayed. So I'm going to do search in, and the table is security event. I'm looking for cryptographic. The pipe character that we saw earlier comes next. This basically separates commands. So the output of the first command, search in security event cryptographic, is the input to the following command. And you could add in any number of piped elements. You can see here the commands they're offering me here. I'm going to use one called take. The take command is going to return a specific number of arbitrary records. So you can see it's already defaulting to 1, 10, 100, 1000. So let's say I want 10 records. So basically, I'm just getting 10 records. Now, if I didn't put the take 10 in there, it would still be a valid command, but it could return, 10,000 results, for example. If I omitted the in security event part and just searched for cryptographic, it would go over all of the tables, okay, and that would be obviously less efficient and obviously take longer. These search queries that we're talking about here are typically slower than table-based queries because they have to process more data. But the reason I'm using a search query as opposed to a table-based query is that's what they're going to expect you to know on the exam. Now, I don't think I'm going to have anything returned here in this particular sample database, but I'm going to try it anyway. Run. Yeah, no results found. However, this command is still valid. I'm not getting a syntax error. I'm just not finding that information in this particular security event table. Let's look at one last thing in this demo area. Notice down here you get started with some sample queries, okay? Some computer availability queries, some computer performance queries, some data usage queries. So for example, something practical would be unavailable computers. Okay, list all known computers that didn't send a heartbeat in the last 5 hours. Well, that'd be good to do. Click on Run. I'm not getting a return on the data, but what's more important is not so much the results found, but the actual query. The 2 forward slashes is basically going to make this a comment, right? The command heartbeat, which gets piped to summarize last heartbeat equals max, and then time generated by computer, where the last heartbeat is less than ago 5 hours. Pretty interesting, right? So if you go back to that area, or obviously you can find lots of documentation and more examples on the query language. But as I mentioned, for the exam, it's remembering that search in command, viewing the errors from that table named event.
Lesson 3, Manage Resource Groups. We'll use Azure policies for resource groups. We'll configure resource locks on resource policies, and we'll implement resource group tagging. A resource group is a container that can hold any or all of the resources needed for a solution. You'll typically add resources that share the same lifecycle to the same resource group, making deployment, updates, and deletions a whole lot easier. It also stores resource metadata. Knowing how to create and manage policies on resource groups is valuable for maintaining corporate compliance. For example, enforcing conditions when creating future resources, tracking compliance, resolving non-compliant or denied resources, and implementing new organizational policies. Let's go to the demo and look at Azure Resource Groups.
Okay, I'm in my default dashboard and I want to go to the policy area again, which you've seen, and look at one that may show up on the exam. So let's either go to all services and search for policy, or in the dashboard, I can just go up here and type in policy, and there's my policy object that shows up. So we're going to do our scope, which we know in my case is pay as you go. So make sure you have that scope. Then we're going to go down to authoring and go to assignments. And we're going to assign a policy. Click on that button. No exclusions, but under the policy definition, I'm going to hit the ellipsis button here. And notice under all types, I can look for the built-in ones, or you may have some custom ones. I don't, but if I had some custom ones, which could be cloned copies, for example, that I make modifications to, they'd show up there. I'm going to choose the built-in type, and I want to require something with this policy. So I'm going to search for require. So I type in require and hit a space, okay, because if I don't put a space after that, I'm not going to filter out these 7 definitions. So I can require tag and its value. I could require SQL Server version 12, which is actually one I'm going to choose. But also I could require automatic OS image patching on virtual machine scale sets, require specific tag, require tag and its value on resource groups, and require specific tag on resource groups, and require encryption on data lake store accounts. I want you to remember these require policy definitions for the exam. I'm going to choose Require SQL Server, click on Select. I can keep the assignment name or I can change it, and I can describe it, of course. And when I'm done, click on Assign. Let's do more. Let's create a new custom policy that we want to save costs by validating that VMs that we create in our environment cannot be in the G series. So every time a user in our enterprise tries to create a VM in that series, the request will be denied. So under authoring, let's go to definitions this time. Let's choose this plus policy definition link. Definition location. This is the management group or subscription. So for me, it's going to be pay as you go. I'm going to name this require VM SKUs smaller than G series. So it can't be a G thing. And we can put a description here and say something like, this policy is going to enforce that all VMs created in this scope have a SKU smaller than the G series in order to reduce costs. We could create a new category, or we could use an existing category. Let's create a new category called cost control. Then we could just come down here and we could copy this JSON into the clipboard. Then you would just paste the revised code into the Azure portal. So you may need to update this with obviously policy parameters. So for example, we can see that we have if all of field type equals Microsoft.compute/virtual machines. And then we have for the field SKU.name, if it's like standard_G*, then effect is deny. Once we're done, just go down the bottom and click on Save. Now if we go to Assignments and we assign a policy and we go to Basics and click on the asterisk, we can choose under All Types, Custom Policies, and there it is. Excellent.
Locking prevents other users in your organization from accidentally modifying or deleting a resource group. Locks also apply to other resources, such as Azure subscriptions and specific resources. Let's go to Azure and check out how to configure locks.
On the exam, they'll expect you to know that as an admin, you may have to lock either a subscription or a resource group, which is what we're going to do in this demonstration, or an individual resource in order to prevent users in your enterprise from accidentally deleting or modifying mission-critical resources. We're going to do this at the resource group level, which makes it the parent scope. So if we go to test group here and click on that, realize that everything within this particular scope or this resource group will inherit the same lock. And that even means if you add some other resource later on. So at this point, I basically have a Windows Server VM, an Ubuntu VM, and other assorted resources. Now, management locks are different than role-based access control because here we're applying these restrictions across all users and all roles. So, for example, if I go over here to the left, in the test group resource group menu, I see locks. Click on that, and it says this resource has no locks. We'll just add one. We'll give it a name. I'll just do rlock1. We have two types. Now, on the exam, this is an important thing to remember because when we get into the portal, we have two lock types, read-only and delete. But if we were doing this, let's say in the command line interface or in PowerShell, we have to understand what's really going on under the hood. So the first one we see is read-only. Read-only is basically mandating that authorized users can read a resource, but they can't delete it and they can't update it. If you apply this lock, it's a lot like restricting all authorized users to the permissions granted by the reader role. That's important for the exam. The second one is delete. It's delete in the portal, but under the hood in the CLI and the PowerShell, it's actually cannot delete. So a delete lock, what you're really saying is you cannot delete. Authorized users can still read or modify a resource, but they can't delete the resource. And so if I added this lock,
either read-only, which is basically read-only one word under the hood, or the delete lock, which is also cannot delete. We always want to make sure that we document that. If I click on OK, I'm applying that to this entire resource group. Finally, to be able to create locks or delete locks, you have to have access to particular actions. For example, Microsoft.authorization/* or Microsoft.authorization/locks/*, or if we're looking at the built-in roles, only the owner and the user access administrator roles are actually granted the action or the ability to create or delete locks. Hope this demo was informative for you. See you in the next lesson. Tags let you mark resources with name-value pairs to categorize and view them across resource groups and within the portal across subscriptions. The tag name can have a maximum of 512 characters and is case insensitive. In other words, it's not case sensitive. Tag names created by Azure have prefixes of Microsoft, Azure, or Windows, and you can't create tags with one of those prefixes. Well, the bottom line when it comes to tags is that going into the portal and creating tags is very easy. You just basically come in here and provide a name and then associated value to it. But understand that tags are way much bigger than that. You really want to think about this from a global standpoint, and really from the standpoint what we call a taxonomy. I'm going to give you some resources for that. I'm also going to do something that I'm rarely going to do in this series, which is actually go up to docs.microsoft.com. However, I want to make sure that you're able to answer any question on the exam when it comes to tags, because obviously this area is just so simple, but understanding how the commands you might need to know for the CLI or PowerShell, I want to show you some of those. Now, the first thing I want you to do is realize that the main reasons why we're going to use tags is for access controls, it's for compliance issues, it's for global governance, for example. It could be for cost controls or for automation purposes. There's also some questions you might want to ask yourself when you're forming your taxonomy. For example, how does your enterprise partition or compartmentalize its departments, its business units, its organizational units for chargeback purposes, or we could call it showback purposes? That's one of the main advantages of using Azure Cloud, is the ability to have that kind of partitioning of chargeback, that multi-tenancy environment. Are there any departmental specific or OU specific taxonomies to consider? And let me just give you some resources here real quick. I've already mentioned taxonomies twice, and for those of you who are familiar with things like open, fair, and other things like that, you're familiar with taxonomies. This is an article at uxbooth.com, an introduction to taxonomies. Now, I'm not trying to insult your intelligence. This may be something that's just basically fundamental to you, but it may not be, okay? And if you go through this, for example, they're going to give you using the cat family and the lion family, and just some examples of what a good taxonomy is and how you can apply this to your organization. So this is a good article for you, especially from a real-world standpoint. You're not going to get a question on the exam that actually involves the term or the phrase taxonomy. That being said, another question to ask is, what type of information does your C-suite or your executive management need to see in your reporting and in your visibility tools? And then finally, how does each department or OU hold its users responsible for the resources they consume, specifically here in Azure Cloud? So obviously, as we see here, we can come into the portal, create these name value pairs that allow us to categorize resources and to facilitate compliance, reporting, visibility, automation, cost controls. But what about working with tags in the Azure CLI or in PowerShell? In that case, you may want to go take a look at this document before you take the exam, okay? It's at docs.microsoft.com, and the actual
article is called Use Tags to Organize Your Azure Resources. The things I want to point out to you here, not so much using them in templates and in the portal, we've already seen that, but just in case, it's quite possible on the exam, you'll need to know commands like this. To see the existing tags for a resource group, you would use this PowerShell command, okay, get-az resource group -name, and then of course the name of your group, like test group. That's in parentheses .tags. And by the way, when you come to this article, you can copy this, you can go and try it in a simulated console environment, okay. They'll give you some examples of what it might look like. To see an existing tag for a resource that has a specific resource ID, then you would use this command. And really the things I really want you to focus on are the get-az resource, and that's in parentheses, those are your variables, followed by .tags. Okay, those are the things to focus on. Also in the CLI, if we kind of scroll down in the Azure CLI, to see existing tags for a resource group, we would use az group show -n, and then in my example, test group --query space tags. And again, you can also copy and paste this into the Azure console if you want to. It's going to return that obviously in JSON format. And then again, to see the existing tags for a resource with a specific name, type, and resource group, you see an example here of az resource show. And then you've got several flags there, -n, -g, resource type, and then --query, and then tags at the end. So here's the thing, on the exam, you're not going to have to go and type these out in some type of simulator. Most likely, come back here to this article and make sure that you can recognize what a valid Azure command for CLI and a valid PowerShell command. And if you look at these and spend a few minutes going through the syntax, it'll be very easy for you on the exam to get rid of the distractors and realize what the proper syntax is. Of course, going in and doing this in your own Azure environment is obviously going to get you even better experience and better knowledge of it. So that's always highly recommended as well. All right, see you in the next lesson. Lesson 4, Manage Role-Based Access Control. In this lesson, we'll implement Role-Based Access Control, RBAC. We'll assign RBAC roles and create a custom role. And finally, we'll troubleshoot RBAC. Role-Based Access Control, or RBAC, is an authorization system that lets you manage who has access to Azure resources, what they can do with the resources, and what areas they can access. RBAC is built on Azure Resource Manager to offer fine-grained access management of Azure resources. You can allow one user to manage the virtual networks while another administers virtual machines in a subscription, for example. You can permit a database admin group to manage SQL databases in a subscription. Or maybe you want to allow a user to manage all resources in a resource group, or allow an application to access all resources in a resource group. When you use role-based access control, you have the ability to partition or group up different duties or responsibilities with your personnel and give only the amount of access to users that they need to perform their jobs. We call this the least privilege principle. It's a very important principle in security. In other words, instead of giving everybody unrestricted access or permissions in your Azure subscription or resources, you can only allow certain specific actions at a particular scope. Now, when you're planning, the best practice is to grant users the least privilege to fulfill their job roles. So this table is kind of a recommended best practice from Microsoft. So first you look at the scope. Is it at the subscription level? Is it at the resource level? Is it at resource group level? And then different roles: reader, resource specific or custom role, contributor, or owner. Then you can see the actions that they take. For example, a reader is an observer of the subscription or an observer of the resource group, whereas a contributor
or a custom role is a user that manages resources at the subscription level or the resource group level. And the owner is an administrator. Typically, individual resources are going to be subject to automated processes. Now, role assignments are based on security principles. And there's 4 main principles. A user is an individual who has a profile in Azure AD. And you can also assign roles to users in other tenants. We call that Active Directory B2B, business to business. The second principle is the group. A group is a set of users created in Azure Active Directory. When you assign a role to a group, all of the users in that group have that role. Third is the service principle. This is a security identity that's used by applications or services to access certain Azure resources. It's basically a user identity for an application. Let's say a username and password or certificate. But it's only for an application or service. The fourth principle is the managed identity. This is an identity in AD that's automatically managed by Azure. You typically use these when you're developing cloud applications to manage the credentials for authenticating to Azure services. A role definition is a collection of permissions. For example, actions you can take, actions you can't take, data actions, assignable scopes. This is often called a role, and a role definition basically lists out the operations that can be performed. Read, write, delete. These can be high level, like owner, or they can be very specific, like a virtual machine reader. Azure has several built-in roles, and we saw those back in this table. Owner, contributor, reader, and a fourth one, User Access Administrator. So the owner has full access to all resources, including the right to delegate access to others. Those would be administrators or admins over a subscription or a resource group. The contributor can create and manage all types of Azure resources, but they cannot grant access to others. The reader can view existing Azure resources. For example, observing subscription resources or observing resource group resources. A fourth built-in role is called User Access Administrator, and this lets you manage user access to Azure resources. These are the 4 fundamental built-in roles. Realize there are other built-in roles as well, but those are all geared towards allowing control and management of specific Azure resources. For instance, there's a virtual machine contributor role that lets a user create and manage virtual machines. You should try to use the built-in roles whenever possible, but if they don't meet your needs, you can create your own custom role. Another thing to consider is scope. Scope is the set of resources that the access applies to. So when you assign a role, you can further limit the actions allowed by defining a scope. For example, if you want to make somebody a website contributor, but only for one resource group. In Azure, you can designate a scope at multiple levels. The management group is the highest level, then subscription, then resource group, and then resources. And these are in a parent-child relationship. So if you grant access, let's say at the subscription scope, these permissions are inherited by the resource group and the resources. So let's say you assign the owner role to a user at the top management group scope. That user can manage everything in all subscriptions in that management group. And then finally, role assignments is the actual process of attaching a role definition to a user, group, service principal, or managed identity at a particular scope with the goal of granting access. Basically, the role assignment starts with the security principle. We've determined it's a group called the HR group. Then, the HR group has a role definition. Those are the actions that HR group can take, as well as actions that they cannot take. And then the third step is the scope. In this example, the scope is the PII resource group. These role assignments can be assigned with the Azure portal. You can use the CLI, you can use Azure PowerShell, you can use the Azure SDKs, the software development kits, or you can use REST APIs. Remember, you can have up to 2,000 role assignments in each subscription. However, to create and remove role assignments, you must have the Microsoft.authorization/
role assignments / permission. By the way, this permission is granted through the owner or the user access administrator roles. Finally, what happens if you have overlapping role assignments? Well, RBAC is additive, so basically your effective permissions are all of the combinations of your role assignments. So for example, if you have the contributor role at the subscription scope and the reader role on the resource scope, it would be the accumulation of the contributor permissions and the reader permissions. In other words, you would have the contributor role for the resource group, let's say PIIRG, and the reader role would have no impact. Finally, RBAC also supports deny assignments. You want to be careful using those. A deny assignment attaches a set of deny actions to a user, group, service principal, or managed identity at a particular scope with the purpose of denying access. Deny assignments will block users from performing specific actions even if the role assignment grants them access. Deny assignments take precedence over role assignments.
In this demonstration, we'll explore RBAC roles and create a custom role. We'll first use the Azure portal to work with the access control or identity and access management IAM blade to manage access to Azure resources. We'll also use PowerShell and the Azure CLI. Well, as Jean-Luc Picard would say, make it so.
I want to start out this particular demonstration in my default directory, roles and administrators. In other words, a place we've been before, looking at Active Directory roles. So why am I doing this? Because we're going to be looking at Azure roles, okay? Azure roles are different from the administrative roles that we're looking at here in Azure AD and where we've been before. So for example, I create a user, let's say Tom, who's granted global administrator rights in Azure AD. Well, that doesn't give Tom permission to create resources in Azure. They have to be granted at a scope that's using the role that can create resources. For example, the contributor role. Remember that for the exam. The Azure contributor role can create resources. So what we're talking about here is RBAC, role-based access control. So let's go back home and get out of Azure AD. With RBAC, we have security principals, and a principal could be a user or an individual identity that's in Azure AD. It could be a group, it could be a service principal, an application that's registered with Azure AD, or it could be what's called a managed identity. And role definitions or roles, they can be built in or they can be custom, and there's quite a few built-in definitions in Azure. For the exam, however, I want you to be aware of 4 built-in roles that are core in Azure. There's the owner, which has full access to all resources, including the capabilities to alter security or access rights for the resources that they're managing. A contributor can create and manage resources, but they can't manage access rights to the resources. Readers, who can view resources, but they can't create, manage, or change access rights to resources. And then there's what's called the User Access Administrator. If you assign this to a principal, they can manage access rights to Azure resources. Let me show you a resource that will show you the remaining built-in roles. Notice the URL up here, okay, it's docs.microsoft.com, and the article is called Built-in Roles for Azure Resources. And it reminds us that these built-in roles are ever evolving and ever changing, but if a built-in role doesn't work, we can actually create our own custom roles for Azure resources. Now, for the exam, remember that custom roles cannot be created through the Azure portal, okay? Now, they can be assigned in the Azure portal after they're created, but we create custom roles using PowerShell, the CLI, and through the REST API. And we'll actually look at some code to do that for the exam. Also for the exam, I would like you to know this PowerShell command, okay? To get the latest roles in PowerShell, it's get AZ role definition, okay? Or in the CLI, it's AZ role definition list. Remember those two commands for the exam. Also, here's the built-in roles. I already mentioned owner, contributor, and reader, but then there's a lot more. And all of these, if you scroll down here, these are going to relate to different services in Azure. If I go way down to the bottom, we'll see that User Access Administrator that I mentioned, which lets you manage user access to resources. And then if we keep going down in the document, it starts breaking these down, okay? Remember for the exam, again, contributor lets you manage everything except access to resources, right? And then you can see what contributor cannot do. It cannot delete roles and role assignments. It cannot create role and role assignments. It cannot grant the caller user access administrator access to the tenant scope. It cannot create or update or delete any blueprint artifacts. Now, let's talk about scope for a second. One thing about the RBAC mechanisms is you have to realize what scope you're applying RBAC. So scope is basically a logical boundary, and there are 4 scopes where you can apply RBAC. And again, it's going to be in a parent-child relationship. The highest scope, or the topmost parent scope, is the management group. Then under the management group would be the subscription, and under the subscription would be the resource group, and under the resource group, we would have individual resources. Okay, so we're going to operate basically at the resource group level. But remember, the concept of inheritance is very important in the real world and for the exam. If you give a user access to the owner role at the highest management group scope, that gives them owner rights to all the subscriptions under the management group and all of the resource groups and resources that are inside of them. So I'm back at my dashboard. Notice over here on the left-hand side I see resource groups. So let's click on that. And I can see my test group here. Within the test group I see access control, or IAM, and then roles. And by the way, this list of roles is the same one we just saw in that document at docs.microsoft.com. Let's go back to check access here. Let's go up to add with the plus sign, add role assignment. And let's say I want to look for a role called virtual machine contributor. So I'm going to start typing in there VIR, and there's virtual machine contributor. Notice next to it, little information. It says lets you manage virtual machines, but not access to them, and not the virtual network or storage account they're connected to. Remember that for the exam. I'm going to choose that one. I'm assigning the access to an Azure AD user, but I could also do a group or a service principal. I could also click on the drop down and find other managed identities. If I had a ton of users, I could search them by name or email address. I've only got myself and Tom Jones here. So let's go ahead and give this to Tom Jones and click on Save. So Tom Jones is the virtual machine contributor for the resource group test group. Next, let's look at creating custom roles in PowerShell and the CLI. Well, so far in this training, I've basically just showed you certain PowerShell commands and CLI commands you need to know for the exam. But to actually follow through on some of these things, for example, creating this custom role, I want to install the Azure PowerShell module on my Windows 10 machine and then log into my Azure account and perform the tasks remotely. So you'll want to go ahead and get this, and you've probably already done this and you're already using this on your own, but just in case, you can get this document, install the Azure PowerShell module, and it just walks you through the steps of doing this, okay? So here's the JSON for this custom role. The name is Reader Support Tickets. It is custom, so is custom is true. The description of this role is to view everything in the subscription and also open support tickets. And you can see that my actions are to */read and Microsoft.support /*. I don't have any not actions, I don't have any data actions, I don't have any not data actions, and the assignable scope, I have to put in there my subscription. Notice I just put the get AZ subscription command in there, and you can see I've got my pay-as-you-go subscription ID, which is enabled, and that's the one I'm going to insert into my script. Right there. Then I'm going to save this as a JSON file. It's going to be called reader support role.json. Now to create my new custom role, I'm going to do new AZ role definition, and the input file is on my C drive in a folder called custom roles, and it's called reader support Okay, so that's what I want to see. I had to do some troubleshooting in the background. I forgot that I was also connected into the Azure portal on this same machine through a browser, so I had to get out of that. It kind of hung up on me. But this is what I want to see, the name. There's a unique ID. It's custom, it's true, and you can see the description and then the assignable scope. This is going to show up as a custom role in the Azure portal. Let's go take a look. Let's just go to the test group resource right here and take a look at access control IAM and then roles. And we'll just filter this out and say show me any custom roles. And there it is, reader support tickets custom role. Excellent. Now on the exam, I don't think you're going to have to create a custom role with the CLI, but realize that you're still going to create a JSON file just like I showed you. But in the CLI, this is the command to remember for the exam. AZ role definition create, and then dash dash role dash definition, and then in quotes, the location of your JSON file. In this demonstration, we'll go on a web safari to explore the Microsoft site for troubleshooting role-based access control. Okay, for this demonstration, I'm going to do a web safari to a great article on troubleshooting RBAC for Azure resources. Everything you need is right here in this short article, especially for the exam. So let's take a look at some of these key areas. If you're unable to add a role assignment in the portal on IAM because the add role assignment option is disabled, or because you get the permissions error, the client with object ID does not have authorization to perform action, make sure you're currently signed in with the user that's assigned a role that has the Microsoft.authorization/roles assignment /right permission, such as owner or the aforementioned User Access Administrator. Remember that one from the previous lesson? Also, Azure supports up to 2,000 role assignments per subscription, so you may get an error for that. Remember that for the exam. In the previous lesson, we created some custom roles, specifically using PowerShell. If you're unable to update an existing custom role, make sure you're currently signed in with a user that has that same permission we saw earlier, and again, is owner or User Access Administrator. Let's say you try to delete a custom role. Chances are there are role assignments still using the custom role. So remove those role assignments and then try the deletion. Down here, they give you the steps to transfer a subscription to a different Azure AD tenant. That's above the pay grade of this exam, so don't worry about that. Let's go down here and look at access denied or permission errors. If you get the permissions error, the client with object ID does not have authorization to perform action over scope, code authorization failed. When you try to create a resource, make sure you're currently signed in with a user that's assigned a role that has right permission to the resource at the selected scope. Remember, there's 4 scopes in Azure RBAC: management group, subscription, then resource group, and then resources within the resource group. If you get the permissions error, you don't have permission to create a support request. When you try to create or update a support ticket, make sure you're currently signed in as a user that's assigned a role that has Microsoft.support/support tickets /right permission, such as support request contributor. All right, so let's make sure that we go up and add this document to our database at docs.microsoft.com and use this as our troubleshooting guide and be prepared for an exam question, a simple one, on troubleshooting RBAC for Azure resources. Module 2, which also has 4 lessons, is called Implement and Manage Storage. In Lesson 5 of this module, we'll create and configure storage accounts. Next, we'll import and export data to Azure. Then, we'll configure Azure files. And finally, we'll implement Azure Backup. Lesson 5, Create and Configure Storage Accounts. In this lesson, we'll configure network access to the storage account. We'll create and configure storage accounts and generate a shared access signature, a SAS. We'll manage access keys. We'll monitor activity logs using log analytics and implement Azure Storage Replication. An Azure storage account holds all of your Azure storage data objects, like blobs, files, queues, tables, and disks. A storage account represents a unique namespace for your Azure storage data, accessible over HTTP or HTTPS from anywhere. Data in the Azure storage account is durable, highly available, secure, and vastly scalable. There are several different types of accounts, but the main account types are General Purpose v2, General Purpose v1, Block Blob storage accounts, File storage accounts, and Blob storage accounts. What we're actually going to do first is secure our access to our storage. Now that might seem like we're going to get the cart before the horse, but I'm going to show you how to configure and manage storage in the next lesson. I've already created another storage account. It's called MJS Songs 2019, and of course, I'm going to store some MP3 files in here. Once we come into this area, we have our new menu here under MJS Songs 2019. I'm going to scroll down to Firewalls and Virtual Networks. Notice that the default is to allow access from all networks, including the internet. What we might want to do is configure our storage accounts to deny access to traffic from all networks, and then grant access to traffic from specific VNets, choosing this radio button, Selected Networks. So we're building a secure network boundary for our applications. Realize that network rules are enforced on all protocols to Azure storage. That includes REST and SMB, Server Message Block. And if you want to access the data with tools like Azure Portal, or if you download the Storage Explorer, as you can see here, I've downloaded the Microsoft Azure Storage Explorer, and you can see I've created a file share in MS Songs 2019 called Song Archive, and I've uploaded several MP3 files. This is from my album that I produced a few years ago called Lovesick Manifesto, and I've got my MP3 files up there. And so you might want to download this and run this from your local machine. And you can apply network rules to existing storage accounts, like I'm doing right here, or I could have done this when I created the new storage account, and of course, we'll look at that in the next lesson. Once these network rules are applied, they're going to be enforced for every request. And if you're using shared access signatures, SAS, which we're going to look at in an upcoming lesson, SAS tokens, these will grant access to specific IP addresses, limiting access of the token holder. And they don't grant any new access beyond this configured network rule here. So if I wanted to add an existing virtual network, I could click on this plus here. I could go over to my subscription and choose, for example, my test group VNet or some other VNet if I had it, or get out of here. I could add a new virtual network right here on the fly. I can also go down here and add IP ranges to allow access from the internet or the on-premises network. As you can see below, it actually has my client IP address here, which I've got grayed out. I could also put in an IP address, or I could put in a CIDR prefix, like 57.224.240.0/24. Now, when I'm only allowing access from particular VNets, what I'm actually doing is I'm enabling a service endpoint, and this gives traffic an optimal route to the storage service. Each storage account supports up to 100 virtual network rules, and these can actually be combined with IP network rules.
Now notice down here in this same area, realize you may have to go to your network administrator to actually get the internet-facing IP addresses that are used by your branch office, your regional office, or your headquarters. So you have to contact your network admin. If you're using Express Route from your premises, you'll have to identify the NAT network address translation IP addresses that are being used. Notice down here it says exceptions. So you could allow trusted Microsoft services to access the storage account. That would be things like Azure Backup, Azure Databox, Azure Event Grid, Azure Event Hubs, Azure Monitor, Azure Networking, Azure Site Recovery, and SQL Data Warehouse. You can also allow read access to storage logging from any network, or allow read access to storage metrics from any network if you wanted to, and just click on those checkboxes. When you're done, just click on Save. Before we leave, let's look at some basic PowerShell commands, just in case they ask you on the exam. Okay, notice the first command is get AZ storage account network rule set, followed by my resource group name, which is test group, then the account name, which is MJS Songs 2019, and we're finding out what is the default action. Issued that command, it said to deny. Okay, well let's change that to allow. So we use the command update AZ storage account network rule set, same thing, test group, MJS Songs 2019, and we said let's change the default action to allow, and you can see that we have allow, and again our IP rules here is showing my host machine. Also, based on the settings I showed you, we're allowing logging, we're allowing metrics, we're allowing Azure services. Okay, what if I want to set the default rule back to deny? We'll just go up, backspace over, and issue deny. Now, if I was in the CLI, the commands would be AZ storage account show, then AZ storage account update to set the default rule to either deny or allow. Okay, so remember these commands for the exam. I want to wrap up this demonstration looking at some of the comparisons of the 5 main storage account types. The first thing I want to show you, first of all, is that the general purpose version 1, if you notice to the far right, is the only one that supports the classic deployment model. All of the other 4 are going to use the ARM model, the Azure Resource Manager. Also realize that all of these are going to be encrypted with server-side encryption for data at rest. Notice that the general purpose v2, which is very popular, supports all the services. Blob, file, queue, table, and disk. It supports the standard and the premium performance tier. It supports the hot, cool, and archive tiers, and all the replication options, LRS, ZRS, GRS, and RAGRS. I'm not going to go through all of these elements, but make sure that you're familiar with this for the exam. Notice, for example, that block blob storage only supports block blobs, and append blobs only. It supports the premium tier, doesn't support any of the access tiers, and you only have LRS replication. File storage is also similar, files only, premium performance tier, access tiers aren't applicable, and it only supports LRS replication. So again, make sure you're familiar with these different storage account types and their different attributes for the exam.
In this demonstration, you'll learn to create and perform basic configuration of a storage account. We'll use the Azure portal, Azure PowerShell, Azure CLI, and an Azure Resource Manager template.
Okay, let's go ahead and create and manage a storage account. And in the previous lesson, we actually controlled the network access to this storage account called MJS Songs 2019. So if you want to add a storage account, click on the Add button, and it says Create a Storage Account. Now remember, this is going to contain all of your data objects, and we're going to look at blobs in greater detail in the next lesson. Okay, so I don't want to get too deep into what blobs are all about because we're going to cover that later, but we know what files are. Okay, files, queues, tables, and disks.
The storage account basically provides a unique namespace for your storage data accessible from anywhere in the world over HTTP or preferably HTTPS, and you have the choice. The data is durable, okay, high durability, high availability, it's secure, and it's massively scalable. So when you come down here, you're going to choose your project details. I'm going to choose my pay-as-you-go subscription and an existing resource group. How about test group? If I want to create a new resource group on the fly, just click on the Create New link. Let's go down to the instance details. I need to give it a storage account name, and it's all lowercase letters and numbers, no dashes, no dots. So I'm going to say Shan Test Storage 9. That's not taken. Choose your location. You can see obviously tons of different locations. Based on where I am though, I'm going to go ahead and stick with US East, US. We could spend a lot of time here, and I don't want you to rely just on me doing a show and tell. I really encourage you to come into this area and get familiar with it, as well as some of the PowerShell commands and the Azure CLI, which we'll look at as well. So performance, you have standard or premium. If you're curious, move your mouse over the little information and it just tells you. The standard accounts are backed by magnetic drives and provide the lowest cost per gigabyte. They're good for bulk storage where data is accessed infrequently. Premium storage are backed by SSDs, solid state drives, giving you consistency and low latency performance. They can only be used with Azure Virtual Machine disks and are best for I/O intensive applications like databases. Okay, so I'm going to stick with standard, which means I'm using the magnetic hard disks as opposed to the SSDs. Now, for the account kind, it is defaulting to Storage V2, General Purpose V2, which is basically access to all types of services, blobs, files, queues, tables, and disks. You can click on the drop-down and you can choose Storage General Purpose 1 or Blob Storage. Again, we'll look at Blob Storage in the next lesson, not sub-lesson, but lesson 6. For the exam, I think you'll be fine using Storage V2. It's very popular. We're also going to talk more about replication later on in this course, but just notice it's defaulting to read access, geo-redundant storage. The other choices are LRS, locally redundant storage, ZRS, zone redundant storage, and GRS, geo-redundant storage. Okay, I'm going to stick with the default. For my access tier, I'm going to choose hot as opposed to cool. I would choose cool if this was going to be, very infrequently accessed data. If I didn't want any advanced configuration, I could just click on Review and Create, or Review plus Create at the bottom. But let's click on Advanced. Notice that Secure Transfer Required is enabled by default. Basically, that means using HTTPS or, to be even more specific, Transport Layer Security. For virtual networks, I can allow access from all networks, or I can choose selected networks. And this is what we saw in the previous lesson. As I mentioned, you can configure this on the fly, or I could come back afterwards and I could go ahead and I could configure this like we saw in the previous lesson. We'll talk about blobs and data lakes a little bit later, but those features are disabled. Next, you can apply your tags, your name value pairs, for categorization, for compartmentalization, for change and control management, for inventory purposes, for consolidated billing, and other visibility and metrics. Once I'm done, click on Review and Create. The validation passed and we can go through. Notice, by the way, based on this configuration, I could download a template to automate this process again. Okay, let's go ahead and take a look at configuring this with other methods like PowerShell, the CLI, and ARM templates. Okay, the first thing I'm going to do is I'm going to issue this command, get AZ location, so I can get a list of locations. I'm going to need that. And I think I'm using, if I scroll up here, Central US, so you can see all those. I'm going to create a couple of variables here. Let's do one for resource group. That way I don't have to keep typing it in there. Test group.
Let's do one for location. And it was Central US. Okay, so here's the PowerShell to create a general purpose V2 storage account with the read access geo-redundant storage, RAGRS. So we're using the new AZ storage account command and then dash resource group name followed by that variable I created, resource group, which we know is going to be replaced with test group. Then I have to have a unique name, so I called this shanstore99. The location, again, is a variable being replaced by Central US. SKU name, that's the read access geo-redundant storage, RAGRS. That was the default that we chose when we did this before. And the kind of storage is storage v2. So you can see the result, shanstore99, test group, Central US, and the creation time and the provision state was succeeded. Okay, I'm not going to create one in the CLI. I'm just going to show you the commands here. I'm just going to copy and paste them in here. In the Azure CLI, I would do AZ storage account create, and then the name would be whatever the account name is, shanstore98. The resource group, they're just putting in a new one here, but I would go ahead and designate test group, then my location, West US, Central US, to use the previous example, there is the same SKU and the same storage kind, storage v2. So that's the command for the Azure CLI. Now, as far as the ARM templates go, I'd recommend going up to this website right here and scroll down about halfway, and you can see that we've got templates. First, the ARM template for the Azure PowerShell. You're going to create a couple of variables, and then you're going to use those in the new AZ resource group command. And then the new AZ resource group deployment is the command we use, and we're going to access that template. And here's the template URI at raw.githubuser.content.com. And you can just, you can copy this PowerShell, and you can click on try it, and you can go play around with it, sign in with your account, and play with it here. Also down here we see AZ group deployment create, and you can see it's still the same location and the same thing. You can try this in the Azure CLI. All right, I hope this was informative for you. I'll see you in the next lesson where we're going to look at the shared access signatures, or SAS implementation. A shared access signature, SAS, lets you grant limited access to objects in your storage account to other clients without exposing and possibly compromising your account key. A SAS token gives you granular control over the type of access you grant to clients who have the SAS, including the SAS validity interval, SAS permissions, an IP address or addresses, and you can restrict them to HTTPS as opposed to HTTP. As you can see, I'm in the Microsoft Azure Storage Explorer. This is the best place to actually create SAS tokens. Now, before we actually do that, let me just tell you that the easiest and the most powerful way to control access to our storage account is using access keys. And we're going to be looking at access keys here in an upcoming sub-lesson. But the reason why we're looking at this one first is because access keys in the wrong hands are much more dangerous. So really only certain roles or certain users should actually use the access keys to access these storage accounts and the contents of the storage account. As a matter of fact, we need to carefully protect those keys using either Azure Key Vault, which we'll look at, or by using hardware security modules, HSMs. Now you can see we're looking at my pay-as-you-go subscription, and also notice, by the way, if we look under storage accounts, here's the actual shanstore99. That's the one I created using PowerShell in the previous sub-lesson, remember? But I didn't actually go and take a look at it in the portal, but we can see it right here. So let's say I want to generate a temporary SAS token for shanstore99. If I click on it, notice down below where it says Actions, I can get a shared access signature. Let's click on that link,
And here we can see our shared access signature. Now, I want you to notice the metadata or the actual settings here, because if you decide to do this programmatically, let's say in a command line tool, or using an Azure PowerShell commandlet, the variables will be things like start time, expiry time, account name, account key, the name of the object like a container, for example. But notice that we're going to choose our start time, and we can just stick with the defaults. It's 24 hours, okay? So it's basically 7:15 at 6:28 p.m. to 7:16 6:28 p.m. And of course I can modify this as I want to. I'm going to base it on my local time zone, which is Central Standard Time. I can then apply what type of permissions do I want in this token. Notice the options: read, write, delete, list, add, create, update, and process. By default, only read and list are selected. If I was applying this, by the way, to the entire storage account, which I could do that, notice that I'm going to have a choice of different services: blobs or not, files or not, queues or not, tables or not. And then we have 3 different resource types. When I'm done, I'll just click on Create. So here's my account name, and I can just copy the connection string and the query string and give that to my user. Now, an extra exam tip to remember is if you want to generate SaaS tokens using Azure PowerShell commandlets, I want you to remember, obviously, the different metadata we saw earlier, like account name, start time, and those things. But what you really need to know are the different commandlets that you have available to you. So notice we have the new AZ Storage Account SaaS token, Storage Container SaaS token, Storage Blob token, Table, File, Share, and Queue SaaS token. These are the commandlets that you can use to generate SaaS tokens for a variety of storage services. All right, I hope you learned some stuff in this lesson. Also, don't forget to download that Microsoft Azure Storage Explorer and familiarize yourself with that tool for the exam.
Let's talk about storage access keys. Each Access storage account has 2 keys, a primary key and a secondary key. We use those 2 keys so that you can have a rotation scheme. These 2 keys are used to authenticate application requests to your storage accounts. Whoever has access to these keys has unlimited access to the entire storage account. So it's highly recommended that you store the access keys in a secure location like Azure Key Vault. Also, never share the keys. Whenever possible, let's use shared access signatures or SAS. And finally, regenerate your keys on a regular basis.
Okay, in this sub-lesson on managing access keys, we're going to look at the Storage Explorer again. And on the exam, you need to be aware of how to install and use the Azure Storage Explorer. So hopefully you can download the tool. It's a standalone application, as we saw in the previous sub-lesson, that lets us effortlessly work with Azure storage data on Windows, Mac OS, and Linux system. Now, as far as Windows goes, Windows 10 is recommended. That's what I'm running it on, but it also is supported on Windows 8 and Windows 7. For all versions of Windows, the .NET Framework 4.62 or higher is required. There's several ways to interact. You can connect to storage accounts associated with your Azure subscriptions. We saw that in the previous sub-lesson. You can connect to storage accounts and services that are shared from other Azure subscriptions. And you can connect to and manage local storage by using the Azure Storage Emulator. Also, you can work with storage accounts in global and national Azure by connecting to an Azure subscription, managing storage resources that belong to your Azure subscription. Working with local development storage, managing local storage by using the Azure Storage Emulator. You can attach to external storage, managing storage resources that belong to another Azure subscription or that are under national Azure clouds by using the storage account's name, key, and endpoints. You can attach to a storage account or service using SAS, shared access signatures. And you can connect to an Azure Cosmos DB account. Now that being said, I want to begin looking at the access keys from the perspective of the Microsoft Azure portal. So if I go to my home and then go to storage accounts, let's go ahead and choose MJ Songs 2019. And notice that brings up a new menu for me. I can go down here and under Settings, click on Access Keys. So basically this is a combination of the storage account name, MJ Songs 2019, and an access key, which by the way, with this key, I have full access to all the data and all the services within the storage account. So I can create, I can read, I can update, I can delete everything, okay? File shares as we see here, or containers, blobs, tables, and queues. I also have full admin access to everything other than the storage account itself, even though with the keys I can't delete the storage account, nor can I change the settings like its type, for example. Now applications will use the storage account name and key for access to storage. Sometimes that key is actually used to generate a shared access signature token, a SAS token, or sometimes it's used for direct access. Notice that each storage account, as we see here, has 2 access keys. This lets us modify applications to use the second key instead of the first key and then regenerate the first key. This is known as key rolling, so it lets us reset the primary key without any downtime for applications that actually access storage directly using the access key. By the way, storage account access keys can be regenerated using the Azure portal with these 2 commands. In PowerShell, it's the new AZ storage account key commandlet, and for Azure CLI, it's this command, AZ storage account keys renew. And again, I can't emphasize how important it is to protect the storage account access keys because of the access that they provide. So Azure Key Vault helps safeguard cryptographic keys and secrets that are used by applications and services. So obviously I can move up here and copy to the clipboard key 1 or the connection string, or key 2 or the connection string, or I can click on the regenerate symbol to regenerate key 1 and key 2. For the exam, remember, if I have applications using this second key and then regenerate the first key, that's called key rolling. Okay, so I was talking the talk about Key Vault. Let's go ahead and walk the walk. I'm going to go up here to All Services, and I'm just going to go up here and start typing in Key Vaults, and hopefully I'll see Key Vaults, and there it is. I have an existing Key Vault called Chalubi Vault 0. If I wanted to add one, I would click on Add, and I would name it, let's say Chalubi Vault 1, Pay As You Go, choose my resource group, choose my location, go with the standard pricing. The principal selected is me, okay, and then we have all networks can access and then create it, okay. That's what I did when I created Chalubi Vault 0. So let's go ahead and select that one. And we could do keys, and we'll talk about that, for example, if you want to do key pairs. But let's do secrets, because that's what relates to what we're doing right now. We want to import a secret, so we're going to do it manually, and we're going to call this ShanStore 99 primary. Now to get the value, hey, let's go back and use that Explorer. So here's the Explorer. Click on ShanStore 99, copy the primary key, go back and enter the value, just paste it in there. You can also look at it, it's a little eyeball there, doink, in case you're curious. You can put in some content type, set an activation date, set an expiration date. It's enabled, click on Create. And now we've got that primary storage key in the Key Vault. Okay, so back over in the Microsoft Azure Storage Explorer, notice that when I choose my storage account, MJS Songs 2019, down here you can see Copy Primary Key or Copy Secondary Key. All right, well this is something, by the way, that you might want to monitor. So in the next sub-lesson, we'll revisit the concept of monitoring the activity log using log analytics. Azure Monitor log data is still stored in the Log Analytics workspace and is still collected and analyzed by the same Log Analytics service. But Microsoft is changing the term Log Analytics in many places to Azure Monitor Logs. All data collected by Azure Monitor fits into one of two fundamental types, either metrics or logs. Data collected by Azure Monitor Logs is stored in a Log Analytics workspace. The Azure Activity Log provides insight into subscription-level events that have happened in your Azure subscription. Connecting the Activity Log to a Log Analytics workspace provides several advantages. It consolidates the activity log from multiple Azure subscriptions into a single location for analysis. You can store activity log entries for more than 90 days. You can correlate activity log data with other monitoring data collected by Azure Monitor. And it uses log queries to perform complex analysis and gain deep insights on activity log entries.
Okay, let's follow up on our previous lesson by looking at some monitoring of our storage groups. So I'm going to go over here to the monitor area on the far left, click on monitor, and a couple of things. I'm going to start out by first going to the activity log, and I'm going to look at my pay-as-you-go subscription. I'm going to do a time span of the last 24 hours. Event severity, I can do, let's see, critical, error, warning, informational. I'm going to do all. Let's add a filter, and let's look for the resource type. Notice you can go through this whole long list. Let's just do storage accounts. Last 24 hours. Let's apply that. Excellent. So you can see the activities here. Listing of storage account keys, updating the storage account create. I can download these as a CSV file. Open that up. And I can see my results in a CSV file. This can of course be exported, or a ton of different business analysis tools can be used. Excellent. Let's go back over here to logs and create a workspace. From the test group, locate this in Central US, the per gigabyte pricing tier, OK. And we've seen this in earlier lessons. Now that the process is done, notice you can see in all resources here, I could filter this out, but I can see it right here. Log Analytics Workspace, Storage WS01, where it says Configure Monitoring Solutions. I can click on View Solutions. Over the last 24 hours, I can click on Logs. And I can run a query, as we saw earlier. Here's some sample queries for data usage, for example. If I go back here, I can add some solutions from the marketplace to run against my data in storage. Again, we'll be returning to monitoring our activity logs and using log analytics on and on throughout this entire course.
Data in your storage account is always replicated to guarantee durability and high availability. Azure Storage copies your data so that it's protected from planned and unplanned events, including transient hardware failures, network outages, power outages, or substantial natural disasters. You can choose to replicate your data within the same data center, across zonal data centers within the same region, or across geographically separated regions. We have 4 options. They include locally redundant storage, LRS, zone redundant storage, ZRS, geo-redundant storage, GRS, and read access geo-redundant storage, RAGRS. Let's go take a look at a table that shows the differences here. So we've got 4 scenarios here. The first scenario is basically storage account types supported, right? So what storage account types are supported by RAGRS? Well, GPv1, General Purpose v2, and Blob. Those 3 are also supported by LRS. Notice that ZRS
only supports GP version 2. So remember that for the exam. Zone redundant storage only supports general purpose version 2. GRS also supports GPv1, GPv2, and Blob storage. All of the different replication options are going to give us service or other failure in the data center. That's available. Notice, however, that for a failure impacting the entire data center, for example, a fire, okay, only LRS is not available. The other three types are available. For failure impacting all the data centers in a region, for example, some huge superstorm, with RAGRS, you get read access only until failed over. With LRS, it's not available. With ZRS, it's not available. And with GRS, it's Microsoft controlled failover. What about durability? With RAGRS, we get at least 16 nines. That's basically 9 point and then 14 nines after that. With LRS, you get at least 11 nines. With ZRS, you get at least 12 nines. And with GRS, you get at least 16 nines. By the way, don't forget durability is not the same thing as availability. Okay? Durability is actually maintaining the existence of the object. Okay? Availability is your ability to access that object. Okay? Notice that with all the options, we have server or other failure in the data center protection. Also, the availability SLA, service level agreement for read requests on RAGRS is at least 99.99. Okay, so that's 4 nines. Now, what does the asterisk mean here, by the way? That means that the availability SLA is only 99% if you're using the cool access tier. So keep that in mind. So notice that RAGRS is the highest availability SLA for read requests. Okay, the LRS, ZRS, and GRS all have 99.9 or 3 nines availability for read requests. Finally, the availability SLA for write requests across all replication options is going to be 3 nines, at least 99.9%. Realize, however, that if you're using the cool access tier, the availability SLA for write requests is only 99% or 2 nines. Again, however, the asterisk tells us that the write request availability is only 99% when you're using the cool access tier. Remember this information for the exam.
Okay, as you can see, I'm in my storage accounts area. Don't forget the data in my storage accounts is always replicated for extremely high durability, at least 11 nines, and high availability, either 3 nines or 4 nines. Unless it's in a cool access tier, then I'm going to get 99% or 2 nines. Let's take a look at ShanStore here real quick. If you remember, it has the default replication of read access geo-redundant storage, RAGRS, which we know supports storage v2 or general purpose v2. It also supports general purpose v1 and Blob. Why am I reminding you of that? Because of the exam. RAGRS is the default, so it's very likely it'll be on the exam. Remember, I'm protected if a server or other failure happens in the data center, or if there's a fire in the data center, or if it impacts all the data centers in a region, I'm going to get read access only until it fails over. For example, if there's an earthquake or something like that. With RAGRS, remember, I'm going to get at least 16 nines of durability. My availability SLA for read request is 4 nines, and my availability SLA for write requests is 3 nines, reminding you because of the exam. Now I can move my storage comfortably between the LRS, GRS, and RAGRS replication modes. So for example, if I click on configuration down here under settings, notice I can change my replication to LRS or GRS. Now migrating to the ZRS mode or from the ZRS mode is going to be quite a bit different. And for the exam, remember this. The recommendation would be to copy the data in this ShanStore 99 to some new storage account that has the desired replication mode, and I could use a tool like AZ Copy. This could lead to some downtime with the applications, or I could go to Azure Support if this is, an enterprise solution, and ask for a live data migration. All right, what if I want to do this in the Azure PowerShell? Well, the commandlets would be new-az storage account at the creation, or after creation, I can use the commandlet set-az storage account. Remember, if my data set is pretty large, or if I don't have good connectivity to or from my data on the internet, I may want to physically ship the data and import it into Microsoft Azure instead of uploading it. One way is to use the Azure Import and Export service, or I could use Azure Data Box, which is a device that Microsoft sends us that lets us copy our data to the box, and then we ship the box back to Microsoft for uploading to Azure. In this lesson, we're going to configure Azure Active Directory authentication for a storage account. With Azure AD, you can implement RBAC, role-based access control, to give permissions to users, groups, or application service principals. Azure AD authorizes access rights to secured resources through RBAC. Azure Storage defines a set of built-in RBAC roles made up of common permission sets that we use to access Blob and queue data. Principals are authenticated by Active Directory to return an OAuth 2.0 security token, which then authorizes a request against Blob or queue storage. You can also define custom roles for access to Blob and queue data. This is an improvement over shared key authorization, which has intrinsic security vulnerabilities. Only storage accounts created with the ARM deployment model support Azure AD authorization. Azure Files supports authorization with Azure AD over Server Message Block SMB for domain-joined VMs only. Let's go check out the configuration in the Azure portal. Now, even though we can do RBAC roles for blobs and queues on the exam, you need to be aware of how to do this for blobs. So I'm in a storage account, and I'm going to go ahead and go over here to the storage account menu on the left-hand side and go to containers. And I've got a container here called Music Files 2020. Open that up, and I'll see some music files that I've uploaded, some MP3s. And so over here on the left-hand side, we see the access control IAM. We'll click on that. You can see some user-friendly prompts over here, add a role assignment, view role assignments, view deny assignments, or you can go up here to these links. Now, one thing I want to mention before we get into this is that before you start assigning RBAC roles to these principals, you have to determine the scope of that security principal. So typically a best practice is to do the narrowest possible scope, so a least privilege approach. So there are 5 levels that you can scope the access for blob and queue resources. So the narrowest scope would be an individual container. So the role would apply to all the blobs in the container. That includes the container properties and metadata. Then there's an individual queue. And then above that you have the storage account. I could do resource scope on the entire ShanCan 2020 storage account. And then of course above that would be the resource group, and then the highest level would be the subscription. So your role assignment would apply to all the containers or queues in all of the storage accounts in all of the resource groups in that particular subscription. So we'll click on this little role assignments here. And here I am down here. You can see my owner role. Now, as the owner of your storage account, you're not automatically assigned permissions to access data. So you have to explicitly assign yourself an RBAC role for Azure Storage. And again, we know the different levels you can scope that at. Let's go over here to roles real quick. You can obviously see, these are ones we've already looked at before. We've already seen owner and contributor and reader, but some of these are specific to blob storage and queue storage. So if I scroll down here, You can see storage blob data contributor, storage blob data owner, storage blob data reader, and storage blob delegator. And by the way, if you move your mouse over here to the little eye, it'll tell you what you can do. Okay, so the storage blob delegator allows for the generation of a user delegation key, which can be used to sign SAS tokens. Now, if I go up here to add, I can add a role assignment, and you can see I've got another user here I created, Sam. Sam can too. Okay, so I could choose the role, let's say reader, and I'm going to assign that to Azure AD user, but you can also see all these other options here. And we'll choose Sam can too, and we'll save it. And now we go back to role assignments, and we'll see not only myself, the owner, but Sam can too, the reader. Lesson 6, import and export data to Azure. We'll create imports and exports with Azure Jobs. We'll learn about Azure Data Box. We'll configure and use Azure Blob Storage and configure Azure CDN endpoints. Azure Import-Export Service will import large amounts of data to Azure Blob Storage and Azure Files by shipping disk drives to the Azure Data Center. The service can also be used to transfer data from Azure Blob Storage to disk drives and ship to your on-premises sites. Data from one or more disk drives can be imported either to Azure Blob Storage or Azure Files. You can supply your own disk drives and transfer data with the Azure Import-Export service. You can also use disk drives supplied by Microsoft. You can use this for migration. Move large amounts of data to Azure quickly and cost-effectively. You can use it for content distribution to quickly send data to your customer sites. You can use it for backup. Take backups of your on-premises data to store in Azure Storage. Or data recovery. Recover large amounts of data in storage and have it delivered to your on-premises location. Well, for the exam, you need to understand the process of the import job flow and the export job flow, not so much having to demonstrate the capability of doing this yourself. So I'm going to go up to docs.microsoft.com and use this excellent diagram. Here's what happens. You're the customer, so you're going to prepare the hard drives using the import-export client tool. So here's what it is. You're going to download this tool, WA Import Export V2. V2 is better for files. V1 is better for blobs. And if you notice this is it's a command line tool. Okay, so you would run this from the command line, and you just follow the instructions to prepare your drive. Then encrypt the drive with BitLocker, and then you're going to create an import job using the Azure portal. So if you go to Home, Import Export Jobs, you can always search for it up here. You just simply come in here and you create an import export job. So basically you're going to import to Azure, you're going to export from Azure, you're going to name it, choose your subscription and your resource group, and then you'll fill in some job details, the return shipping information, and then there'll be a configure return shipping details. Okay, this is the tool you would use to create the import job in Microsoft Azure. Then you'll ship the hard drive or drives to the data center. The carrier will deliver the hard drives to the data center. They'll get processed at the data center, and the data is copied from the hard drives to the storage account. In step 7, the hard drives are packaged for return shipping, and then they're shipped back to you, the customer. So the job state of this life cycle is creating, shipping, transferring, packaging, and complete or completion. Remember that for the exam. To export, you'll create an export job like I just showed you in the Azure portal. Just choose the export option. Ship the drives to the data center. The carrier delivers the hard drives to the data center. Then the hard drives are processed at the data center. the data is copied from the storage account to the hard drives, and the hard drives are encrypted with BitLocker by Microsoft. In step 7, the hard drives are packaged for return shipping, and step 8, the hard drives are shipped back to the customer. So with export job flow, it's creating, shipping, transferring, packaging, and complete. On the exam, remember the job flow for import and export and the tools that are used.
DataBox lets you move stored or in-flight data to Azure quickly and cost-effectively. It offers online appliances to transfer data to and from Azure over the network, or they offer offline data transfer products to move large amounts of data to Azure. Let's go take a look at a diagram that explains the different options with Azure DataBox.
To use Azure DataBox, obviously, you're going to begin with your data, all different types of data, and typically large amounts of data. You might try DataBox for an online solution at the top. You can use DataBox Gateway or DataBox Edge. If you go with DataBox Gateway, you're going to use a virtual appliance to transfer data to and from Azure. If you use DataBox Edge, this is an on-premises physical network appliance that transfers data to and from Azure. You can analyze, process, and transform your on-premises data before you upload it to the cloud, and you can leverage artificial intelligence, AI-enabled edge compute capabilities. You can also use DataBox for offline scenarios. If you need to move large amounts of data to Azure and you're limited by time, network availability, or cost, you could move your data using a common copy tool like RoboCopy. With an offline solution, you can use DataBox Disk, which is Azure's 8 terabyte SSD with a USB SATA interface. Has 128-bit AES encryption. It comes in packs of up to 5 for a total of 40 terabytes. Or you could use the DataBox. This is a ruggedized device with 100 terabytes of capacity. It uses standard NAS protocols and common copy tools. It uses AES 256-bit encryption. And then there's DataBox Heavy. This is huge, it's ruggedized, and it's a self-contained device that's designed to lift 1 petabyte of data up to the cloud. With the offline solution, all the data is AES encrypted, and the devices are wiped clean after the upload in accordance with NIST SP 800-88 Revision 1 standards.
Blob storage is scalable, cost-effective cloud storage for all unstructured data. There's 4 storage tiers: Premium, Hot, Cool, and Archive. Premium is for performance-sensitive data. Hot is for frequently accessed data. Cool is for infrequently accessed data. And Archive is for data that's rarely accessed. The storage service offers 3 types of blobs. Block blobs give you up to 100 megabytes per block times 50,000, or 4.75 terabytes. Page blobs are 512 byte pages optimized for random read and write ops. And append blobs, which are blocks added to the end of a blob.
All right, I'm in my resource group, test group. I'm going to go find a storage account. How about Shan Store? And we'll select that one. We can see blobs under services right here. Also, if we go over here to the left, we can see blob service, and we can choose blobs there. As I mentioned in the introduction, blob storage is for large-scale storage of what I would consider arbitrary types of objects, like media files, log files, text files. Each storage account can have 1 or more blob containers. You have to have a container to store blobs, like AVI files, MPEG files, WAV files, and the like. I'm going to go ahead and use a text file. If I create a container, I'll click on the plus sign, plus container. I'm going to call mine Shan Blobs 99. Notice the public access level is either private, no anonymous access, blob, anonymous read access for blobs only, or container. Click on OK. Click on the new container sham-blobs99. Now the blobs can be placed here at the root of this container, or I could create a folder hierarchy. Let me go and upload a blob. Find this on my desktop. There it is, my text blob, and we'll upload that. I could choose to overwrite the files if they already existed. Now each blob is going to have a unique URL. Let me close this out. You can see it right there. https://shanstore99.blob.core.windows.net shanblobs99 /mytextblob.txt. I can click on this right here and copy that into my clipboard. If you want to get more granular about the blob types, you can go to docs.microsoft.com and just simply search for understanding block blobs, append blobs, and page blobs. Let me make it real simple for you. Page blobs are optimized for random access read and write operations, typically used to store virtual disk files, VHD files. Block blobs are optimized for efficient uploads and downloads, like my music files, my videos that I have, other general purpose file storage. The maximum page blob is 8 terabytes. The maximum block blob is a little bit over 4.75 terabytes. Then you have append blobs. Those are optimized for append operations. They don't support modification of existing blob contents. If you're wondering what type of blob would be used most often for log files, it would be the page blob. Remember that for the exam. Now for the exam, I want you to remember this. The type of blob is set when you create it, and I can't go and change this after the fact. Something that might show up on the exam is, let's say you have a .vhd file, a virtual hard disk file, that gets accidentally uploaded as a block blob instead of a page blob. Well, that block has to be deleted first and then re-uploaded as a page blob. And as you can see here, this is a block blob. What about PowerShell? Okay, to create a container, you would use the commandlet new-az storage container. To create a blob within an existing container, you would use set-az storage blob content. And by the way, I can create snapshots, I can edit blob, and I could generate SAS, a shared access signature, specifically for this blob. Fill out the metadata and go down here and choose a signing key, and then generate blob SAS token and URL. Then I can give that to an end user.
Azure Content Delivery Network, or CDN, lets you reduce load times, save bandwidth, and speed responsiveness. It's used for websites, mobile apps, encoding and distributing streaming media, gaming software, firmware updates, and IoT endpoints. CDN gives you global coverage and immense scalability. It integrates into your other Azure services, allowing for scaling in minutes. You get easy setup and no commitment, and of course, pay-as-you-go pricing. CDN endpoints allow you to deliver content to your customers. Basically, you'll just first create a CDN profile, which is the logical container for the endpoints. Then, you can create the endpoint in the Azure portal, or you can do it programmatically.
Okay, before we dive into the configuration of CDN, I want to kind of look at how CDN caching operates at a high level. So here you can see I've stored a logo.png file in blob storage in shanblobs99. I've got a user in Paris who wants to access this file, and we know that I have a URL for that because we saw it earlier when I created my blob that you have a URL you can copy into the clipboard. Now when they access this, because of the physical distance, they're going to have high latency, and it's probably going to slow down the end user browser experience. So we use CDN. We use the blob storage account as the origin. The logo.png file gets cached at a CDN endpoint in Europe, and now the URL for the file is changed
to shancdn99.azureedge.net images logo PNG. And Azure CDN gives us a worldwide network of these caching servers. So basically, any user that accesses this is going to be automatically routed to the closest available server cluster. When the CDN server receives this request, it'll look to see if the file is in its local cache. If not, we call that a cache miss. So the CDN will retrieve the file from the origin blob storage in West US. Future requests for that same file will be a cache hit, and the cached file will be returned to the client, let's say in London, avoiding that trip to West US. All right, let's go into the Azure portal and configure CDN endpoints. There's a couple of ways to create a CDN endpoint through the Azure portal. Let me show you the first way that we're not going to use, okay? But if you go to storage accounts, you can actually go to the blob itself. So if we come in here to Shan Store, to the storage account, and we scroll down, under blob service, we can see Azure CDN. So this is one way to do it, okay? I'm going to show you another way to do it. So we'll go back home and click on Create a Resource. And I'm just going to type in here CDN. And again, it just describes here, it's designed for audio, video, images, and other files to get faster and more reliable delivery to customers using the closest server that's available. So let's click on Create. So I'm going to name this Shan CDN 99. We're going to choose the test group. It's not giving me a choice here, so this doesn't match up to the diagram. The diagram said West US, but this is using East US, which is fine. Pricing tier, that's interesting. Okay, you got 4 options: standard Microsoft, standard Verizon, standard Akamai, and premium Verizon. If you notice up here, I have another web page in the background, and this is compare Azure CDN product features. Okay, so here's the 4 options. I would want you to know those 4 options for the exam, but in the real world, you can come in here and you can go down through here and see all the different performance features and optimizations with these types and kind of what's offered. For example, it says for general web delivery optimization, select this optimization type if your average file size is smaller than 10 megabytes. That might be applicable to me with these PNG files. So standard Akamai might be the best way to go. And of course, you can just go down here and see more of the security features, analytics and reporting features. I think one of the takeaways is you can see that with premium Verizon, you're going to get all the security features. You're going to get much more analytics and reporting, okay? Also, when we go back up here to the performance features and optimizations, obviously with premium Verizon, you're going to get all of these advanced options. So a couple of takeaways. There's a document for you. It's at docs.microsoft.com, en-us, Azure, CDN, and then CDN-features. If I click on this hyperlink, it's going to give me the pricing tier. So the premium Verizon is about twice as much as the other options, okay? So I'm just going to choose standard Microsoft. And then I can create a new CDN endpoint now. So I just filled this in so you wouldn't have to watch me type, which I do excruciatingly slowly. So here's the CDN endpoint name, and again, .azureedge.net. The origin type is storage. My other options were cloud service, web app, or custom origin, and then I chose for the origin host name shanstore99.blob.core.windows.net, and click on Create. All right, so my container's been created and my endpoint has been created. If I want to add another endpoint, I can go back to Shanstore99, scroll down under its menu, and under Blob Service, go to Azure CDN. And you can see here's my existing endpoint, and it's running. You see the protocols, and I can just simply go back in here and add a new endpoint. Notice I have the ability also to migrate my custom domains to CDN as well. Finally, if you want to remove content from the CDN permanently, it needs to be first removed from the origin server or servers. If the content's in storage,
You could set the container to private. We saw that when we created it. Or you could delete the content from the container, or you could even delete the container altogether. In this lesson, we're going to look at Azure Blob storage tiers. Azure provides different tiers for storing Blob object data. You can optimize storage costs by choosing from 3 available access tiers. First is the hot access tier. This is for data that's frequently accessed. It has a higher storage cost than the others, but the lowest access cost. This would be good for data that's actively used or expected to be accessed. In other words, high read and write frequently. It's also for data that's staged for processing and eventual migration to the cool access tier. Cool is for data that's accessed less frequently and stored for at least 30 days. It has lower storage costs and higher access costs compared to hot storage. This could be used for short-term backup and disaster recovery data, maybe older media content, and large data sets that need to be stored in a cost-effective manner. Then we have the archive tier. Use this for rarely accessed data and stored for at least 180 days. If the data doesn't remain for at least 180 days, it'll be subject to an early deletion charge. If your blob is an archive storage, the blob data is offline and it can't be read, you can't overwrite it, it can't be changed. So to read or download a blob in archive, you have to rehydrate it to an online tier. Also, the archive access tier is not set at the account level, only hot and cool access. All access tiers can be set at the blob level during or after upload. And object storage data tiering is only supported in blob storage and general purpose v2, GPv2 accounts. Let's go up to docs.microsoft.com and look at a resource you want to add to your favorites. I want to recommend getting this article. It's basically in the Azure Storage Blobs directory, and it's storage blob storage tiers. About halfway down in this article, this is a table that compares the block blob storage and the hot, cool, and archive access tiers. So the availability numbers are here, for example, usage charges, the minimum storage duration, as I mentioned, 30 days for the cool tier, 180 days for the archive tier, and then you can see down here the latency. We also see this premium performance, but that's not going to be covered on the exam. All I want you to know about is the hot tier, the cool tier, and the archive tier. So in my resource group, my RG1, I've got a storage account here. And if I go in there and scroll down under settings where it says configuration, this is where you would come and change it from cool to hot or hot to cool. If I go down to containers under blob service, here's a container. Notice if I select one of these files, it says access tier is hot, inferred, but you can go up here and click on change tier. And when you do, you'll see hot, cool, and archive. Notice if you choose archive, it says setting the access tier to archive will make your blob inaccessible until it's rehydrated back to hot or cool, and it says it could take several hours. Make sure you remember that for the exam. Also, if I cancel out of here, I can go deeper. Like on this particular file, if I click on it, it's going to bring up, the overview of this MP3 file. And you've also got, information here, access tier, for example. And you can also go to the change tier here in the properties of the actual file itself, okay? All right. Lesson 7, Configure Azure Files. In this lesson, we'll create Azure File Share and Azure File Sync services. We'll also troubleshoot Azure File Sync. Azure provides fully managed cloud file shares that are available using the server message block SMB protocol. Azure file shares can be mounted concurrently by cloud or on-premise deployments of Windows, Linux, and Mac OS. Also, Azure file shares can be cached on Windows servers with Azure File Sync for fast access near where the data is being used. We will explore file sync in the next lesson, but first, we need to learn to create a file share. Now, file shares can replace or append to on-premise file servers. They can support lift and shift applications. They can make cloud development easier. For example, sharing application settings, sharing diagnostics and logs, or for development, testing, and debugging. Okay, we're talking about Azure File Storage, and the important thing to remember for the exam, it's key, is that everything that happens in Azure File Storage basically is through the Azure Storage account. Okay, so that's the key thing. And we can kind of see the hierarchy here. The Azure Storage account, that's the context in which the Azure File Storage Service works. And then beneath that, we have our shares. So in this Azure File Storage Service, I have two shares. We'll say File Share 1 and File Share 2, FS1, FS2. By the way, those are pretty good sports channels too in my area, FS1. So we have these two shares, and then optionally within the share we can have directories. That's kind of how you kind of create your hierarchy if you want to. So we've decided under File Share 1 that we're going to have two directories. We're going to have a tools directory, and we're going to have a logs directory. So a way to logically, divide up our files. This is file system stuff, no biggie, right? So within the tools directory, we have a file, util.exe, and of course in the logs directory, we have our logs files, for example, mylog.txt, and then under File Share 2, okay, still under the same service in the same storage account, but a different share, File Share 2, we have our media directory, and of course we're going to store in the media directory things like MPEGs, AVI files, media files that we're going to use maybe for, content delivery networking, CDN, something like that. And then what we have here at the bottom is just basically the URL format, a way to make requests to our Azure file shares. And we're going to be doing this with the REST protocol or the REST API. And so our files are addressable using this format. Notice, of course, we're using TLS. So you see HTTPS, you want to think TLS 1.2 or higher. So we've got HTTPS:// your storage account, okay, the name of the storage account. Remember, I think mine that we're using so much in this training is called test group or something like that. And then you have .file, .core, .windows.net, okay, so that's the main URL, / the share, / the directory, which by the way is optional, / and then the actual file itself, let's say mv1.avi. There it is. Let's first create an Azure file share in the Azure portal. I'm going to open a standard Azure storage account. Go to my storage accounts. Let's choose MJS Songs 2019. On the menu for the storage account, I'm going to scroll down and we see files under file service. We click on that. I've already got one. Let's add another one. File share. MJS Videos 2019. Quota, which can be up to 5,120 gigabytes. These are video files, so I'm going to say 100 gigabytes. Click on Create. And now I have my video file share. And of course I could upload my video files. Notice, by the way, if I did upload my video here, you can see we've got a connect option connecting to that particular file. Obviously an upload option. We could add a directory or another folder in there to create kind of a file structure. I can refresh my view, I can delete the share, I can modify the quota, I can create and view snapshots. Next, let's create an Azure file share in PowerShell and then see the command line interface commands to create an Azure file share. Okay, let's create some variables first. Let's do one for the storage account. It was MJS Songs 2019. Need my quotes. Need a variable for resource group. So RG name, test group. Let's create a name for the share. Has to be all lowercase, so I'm going to call this New Song Ideas. We need to get a storage key. So we will get AZ storage account key. The resource group name is the variable RG name, and the name is the storage account. Now I need to create a context for my storage account and my key. The context basically encapsulates the storage account name and account key. So CTX, we'll use the commandlet new AZ storage context, and it wants the storage account name. We have a variable for that. That's going to resolve to MJS Songs 2019. The storage account key, we're going to say storage key dot value, the first one. Now we'll use the new AZ storage share commandlet. Remember that one for the exam. The name is the share name variable, which will resolve to new song ideas, and the context is the variable CTX. And there we go. New song ideas. Let's go to MJ Songs 2019. Go down here to File Service Files, and there's our new song ideas. Notice the default quota, by the way, is 5 terabytes. Okay, so to create an Azure file share using the CLI, I'm not going to type all this out for you. What I'm going to do is make sure that you open up a bash shell, which I did in Cloud Shell, and here is the actual code that you want to use. We're going to get a resource group name, we're going to get a storage account name, we're going to create a share name. Then we have to retrieve a connection string, so we're going to use the AZ storage account show connection string command, and then the CLI command to create the share is AZ storage share create, and then the name is going to be the variable that we created. Set our quota, and our connection string is going to invoke the variable con string. All right, I hope this was an informative demonstration for you. We'll see you in the next lesson.
Azure Files provides 2 data access methods that you can use separately or in combination with each other to access your data. You can do direct cloud access, or you can use Azure File Sync. With Azure File Sync, shares can be replicated to Windows servers on premises or in Azure. Users can access the file share using an SMB or an NFS share. And data can be replicated between multiple Windows Server endpoints. Data can be tiered to Azure Files so that all of the data is still reachable through the server, but the server doesn't have to have a full copy. Instead, the data is seamlessly recalled when opened by the user.
Okay, in this demonstration, what I'm going to do is I'm going to set up the file sync between a Windows Server 2016 data center VM that I'm going to spin up and some files I want to sync to. So I'm going to go to the MJ Songs 2019 here, and we'll go take a look at a file share and we've got a song archive here. So I've already got some songs in here, so this is a pretty good candidate. Let's go to the Azure portal, go up here and create a resource, and in the Azure Marketplace, notice it's right here at the top of the list, Windows Server 2016 Data Center. Let's choose that. Pay as you go, the test group, resource group. Call this file sync test VM. I'll go ahead and leave it in the US East region. No redundancy required. The image is the Windows Server 2016 Data Center. Okay, username MJ Shannon, got a password, confirmed it. On the inbound port rules, we're going to allow selected ports. We want RDP 3389 for a Windows server and HTTP. Let's click on disks. Let's create and attach a new disk. 1 gig is fine, and click on OK. We'll review and create. This will take a while. Let's click on Go to Resource, and there's my File Sync Test VM. Let's click on Connect. We'll go ahead and connect using this IP address over port 3389. By the time you're watching this, this server will be vaporized. Let's download the RDP file. Go to the bottom here and click on Open. Connect. Let's do more choices here. Use a different account. And it was MJ Shannon. And the password, yes, through the certificate warning. All right, in Server 2016 Data Center, I need to disable the Internet Explorer Enhanced Security Configuration. I need to do this for the initial server registration, but then we can enable it after it's been registered. So I'm going to go over here to Local Server, where it says IE Enhanced Security Configuration. Turn it off. Go back to the dashboard. Go to File and Storage Services. Under Volumes, we'll choose Disks, so we can add a data disk. I'm going to right-click on this third disk here. I'm going to choose New Volume. I'm just going to use the default settings. Kind of walk through this. Okay, we'll click on Close. So we brought our disk online, we've created a volume. Open up the File Explorer and make sure that we actually have the F drive. There it is, new volume. Open up the drive, right click, create a new folder. We'll say this is going to be Files to Sync. Open up this folder, create a new text document. My test file. And we'll close this, go back to the dashboard. Now before I go over to the Azure portal and deploy the Azure File Sync service, I just want to show you that I went ahead in PowerShell on this 2016 server. I downloaded the Azure PowerShell module. So you'll need to do this too if you're going to follow along with me. It's install-module, name AZ, and just say yes to everything. Now to deploy Azure File Sync, I need to first place a storage sync service resource into a resource group for my subscription. I'm going to choose Create a Resource, and we'll just search for Azure File Sync, and we'll click on Create, and we should see a Deploy Azure File Sync. There we go. So we'll choose the subscription, we'll choose the resource group. I'm going to call this AF Sync SRV 99 in the East region. Click on Review plus Create, and Create. Okay, while that's cooking in the background, I'm going to go up to the Microsoft Download Center, and I want to scroll down and find this. Maybe I have to search for it. I want to find the Azure File Sync agent. So I'm going to go ahead and download this. I'm going to choose the Storage Sync Agent, WS 2016 MSI, and click on Next. Allow once. Run. Security scan. Installing. All right, so I can see my deployment is complete. My sync service. So click on Go to Resource. Just what I wanted to see. All right, so it's installed, it's updated. We have the agent on the Windows Server 2016 Data Center VM. Let's register Windows Server. By doing this, we're going to have a trust relationship between this server, or it could be a cluster, and the storage sync service. A server can only be registered to one storage sync service. It can sync with other servers and Azure file shares that are associated with this storage sync service. We'll select sign in. Okay, so I went for Azure subscription, resource group, and my storage sync service that I created, and register. While that's going on, let's go back to the portal to create a sync group. Click on plus sync group. So I'll just do AFSYNC GRP99. Choose my storage account and my Azure file share, song archive, and create. Okay, let's click on our sync group and add a server endpoint. There's my registered server, file sync test VM. So the path would be F / I think it was file to sync. We'll leave cloud tiering disabled, offline data transfer disabled, and click on create. Okay, the server endpoint creation succeeded. So now my files are in sync across my Azure file share and Windows Server. Go to Files, to the Song Archive, and I can see there's the System Share Information directory. If I go back over to the data center server and go to the F drive, I'll see under Files to Sync, there's my music files. Excellent. You may have to watch this one again, but I hope you enjoyed it. See you in the next lesson.
There are a variety of scenarios that can challenge your Azure file sync implementation. Fortunately, Microsoft offers a great web resource covering several common situations. Let's go take a look.
Okay, in this demonstration on troubleshooting the file sync service, I'm actually going to look at something I did in the previous sublesson. Now, I actually made an error in the previous lesson that I kind of alluded to, but I decided not to fix it, and I decided not to go back and redo the demonstration because I knew that I was going to do a troubleshooting video, so I want to use this example. So here's what happened. Remember when I created my new volume F on the server and then created a folder called capital F files, capital T2, capital S sync? I created that folder and I put my test file.txt in there. Okay. But then when I went over to add my server endpoint, and I even kind of gave you a little call-up window, when I put in the path, instead of putting in the path to the actual existing folder, I put in file to sync all lowercase letters. So what happened was it created a new folder over on the server with all lowercase letters. So that immediately caused a problem. I'm only going to have one-way replication, or I'm only going to sync the files in my file share over to the Windows server, not the other way around. So that's the problem I had. So when I went to my song archive file share, I saw the directory system share information that I wanted to see, but what I didn't see was that text file, because these files were replicated over to the Windows server, these music files, these MP3 files. But what didn't happen was the text file from the Windows server over to the Azure file share. So how did I fix it? Well, it wasn't that big of a deal, okay? I'm back over on the server. I just basically took the text file out of the old folder, which was capital F, and copied it over into the file to sync folder right there. Okay, and again, we can see the other files came across, right? But I put that text file in there, and within a very short period of time, a matter of seconds, the text file was now replicated back over to the song archive file share, the way it should have been. And it would have happened if I would have put in the right path, which I didn't. So that's something that could happen. Let's talk about some other things that can happen, and we're going to get a source from docs.microsoft.com. So if you want to search for Troubleshoot Azure File Sync at docs.microsoft.com, this would be a great thing to add to your knowledge base. Now, if we keep this exam relevant, this is a pretty long article, and it talks about, agent installation and server registration, things that can go wrong there, issues with sync group management. But what I want to focus on is just this general troubleshooting, okay? So if you encounter issues, this is what I would think you would see on the exam. So for example, you might want to verify the Azure file sync services running on the server, right? So open the MMC snap-in and verify that storage sync agent service or file sync service is running. Also, you could verify that you have the right drivers, okay? So in an elevated command prompt, run fltmc and verify that this device driver and this device driver are listed. You could also use the AFS diag tool. Okay, so those are some things that I would expect you to have to know on the exam for general troubleshooting of the Azure File Sync service. All right, we'll see you in the next lesson. Lesson 8, Implement Azure Backup. We're going to create recovery services vaults. We're going to back up and restore data, configure and review backup reports, and create and configure a backup policy. A recovery services vault is a storage entity that typically holds copies of data or configuration information for VMs, workloads, servers, and workstations. It supports various services like IaaS VMs and Azure SQL databases. As we'll see in the demonstration, it makes it easy to organize your backup data. Okay, our first goal in implementing Azure Backup is to create a recovery services vault. So I'm going to click on Create a Resource, and here in the search, I'm just going to type in backup, and you can see I get backup and site recovery. It's going to describe it here for you, but this is the thing for the exam to remember. What you can back up: Windows servers, Windows clients, Hyper-V VMs, Microsoft workloads, Azure VMs, Windows and Linux, and you get built-in resilience and high service level agreements. And that's for durability and availability. One of the links down here says backup pricing details. If you click on that, it'll bring you to this page, okay? Remember, there's no upfront costs, there's no termination fees, and like most cloud models, you only pay for what you need or what you use. So you can come down here and pick your region, right? So I went ahead and picked Central US, your currency, and you have a couple of options here to look at: backup for Azure VMs and on-premises servers, or backup for SQL Server on Azure VMs. This is more expensive, so you can see, for example, an instance that is less than or equal to 500 gigabytes is $30 plus the storage consumed. So they give you an example. If you have 1.2 terabytes of data in one instance, then the cost would be $90 plus the storage consumed. You'd be charged $30 for two 500 gigabyte increments and $30 for the remaining 200 gigabyte data. If you go back up here, you can choose backup for Azure VMs and on-premise services, and you can come down here and you can see the pricing on that, and they give you another example. All right, so let's go back to the backup and site recovery place, and we're going to click on Create. Choose my resource group. I want to give it a vault name. Going to stick with the 99 thing, so Shannon Vault 99. Pick the region. I'll do Central US, that's closest to me. You can add some tags, some metadata, which by the way would be a great idea. We've talked earlier in this training about the importance of tags, especially for change and control management, for asset management, for risk management, for lifecycle and workflow management. So in a real world environment, you want to go ahead and do that. I'll go to the bottom here and click on Review plus Create. I could download a template for automation for this vault, or just click on Create. I'm going to pause while this initializes. Okay, that took a few minutes, but the deployment is complete. I can go to the resource by clicking on the Go to Resource button, and there's my storage vault, which of course, from here, we'll start to back up and replicate. But we're going to cover that in the next lesson. Let's go and do this same thing, but we're going to do it in PowerShell. The first thing I want to do is I'm going to create a new resource group for this backup storage vault. So remember this command for the exam, new AZ resource group. I'm going to name this group my BU backup, capital RG, resource group 99. The location All right, so I had to make sure and fix my syntax there. So I created my resource group. Now we'll create a vault. So new services vault. The name of the vault, I apologize for my typing skills, but anyway, I went ahead and fixed what I did before with my quotes and my spelling. So there you go. I've got my new backup vault, the identifier, the type, the location, the resource group that it's in. I've got a subscription ID and properties. We can now go over, if we want to, and go back to the portal, and we could verify the creation of these objects. There's my backup resource group 99, and you can see in there we have a new backup vault, a recovery services vault. We also, if you go back to resource group, remember that in the test group I also created a vault, Shannon Vault 99. So now I have a couple of vaults. So before I leave, let me show you the CLI just in case you get this for the exam. On the exam, remember, if you want to create a recovery services vault in the CLI, the command is AZ backup vault create. Then you would name it my Shan command line vault 99, the resource group name. Say we'll put that in test group, and then the location, we'll say that'll be in West US. Don't want to really create another one, but that's the command in the CLI for the exam. Remember, AZ backup vault create. You want the name, you want the resource group it's in, and you want the location. All right, in the next sub-lesson, we'll actually back up and restore data.
Azure Backup protects and restores data in the Microsoft Cloud. It replaces your existing on-premises or off-site backup solution with a dependable, secure, and cost-effective cloud-based solution. There are several downloadable agents you can deploy on the associated computer, server, or the cloud. The component will depend upon what you want to protect. All agents can back up data to a recovery services vault in Azure. Azure Backup advantages include automatic storage management, unlimited scaling, multiple storage choices, unlimited data transfer, data encryption, application consistent backup, and long-term retention. Remember, your backup strategy is only as solid as your ability to restore. Restore operations should be performed for testing and real-world scenarios.
Okay, in the previous sub-lesson 8.1, we saw how to create a recovery services vault, both in the Azure portal and using PowerShell. Now let's go ahead and back up and restore data using a vault. Realize that we need some type of agent software, a backup agent, and we have several we can use with Azure Backup. The one we're going to be looking at is the Microsoft Azure Recovery Services, or MARS agent. It's a standalone client that we use to get redundancy of our files and folders. There's also the DPM protection agent. The deployment of the DPM protection agent can be automated using either the System Center Data Protection Manager or the Azure Backup Server. And we have the VM Snapshot extension. This will be installed on Azure VMs to allow snapshots to be taken for full VM backups. The VM Snapshot or the VM Snapshot Linux extensions are also automatically deployed by the Azure Fabric controller. Now the Mars agent is available for install right here in the Vault. Let's click on the plus backup. It says, where is our workload running? Is it in Azure, Azure Stack, or is it on premises? Under what do you want to backup, let's choose files and folders. Notice the other options though for the exam. Hyper-V VMs, VMware VMs, Microsoft SQL Server, Microsoft SharePoint, Microsoft Exchange, System State, and bare metal recovery for the Type 1 hypervisor. Next, we'll click on Prepare Infrastructure. Next, we're going to install Recovery Services Agent. Notice there's only one agent, Download Agent for Windows Server or Windows Client. We'll click on that one. I'm not going to run it. I'm just going to save it because before I initiate the installation of the Mars agent, I need to download the Vault credentials file. So I'm just going to go ahead and save that. So we'll click there and we'll download that. The Vault credentials are valid only for 48 hours from this time that I'm downloading. So only get them when you're ready to install the Mars agent. I need to notice a couple of things here. Here's my Mars agent installer, and here's my Shannon Vault 99 Vault credentials. So let's go ahead and double click on the Mars agent installer. Okay, the first phase is installation settings. During the installation, a cache location must be specified. So we can see it right down here. It tells us that the agent uses this to keep track of files being backed up from your computer. The location specified must have free space, which is at least 5% of the backup data. I'll just keep this default and click on Next. Next. I do not want to use Microsoft Update. I need that software. It's both available. Click on Install. Once this is done, I need to complete the registration. Okay, the Mars agent installation is completed successfully. Let's proceed to registration. Go grab those Vault credentials. Click on Next. I can put in a passphrase here of 16 characters. I'll just go ahead and generate one. And then a location to save the passphrase. I'm just going to browse. Go to this PC. I think I'll stick it in Custom Roles. I used this folder earlier in Microsoft Azure. Why not? Now it tells us that saving the passphrase locally doesn't protect it from corruption or disaster. Microsoft cannot recover data if the passphrase is lost or forgotten, so they're going to advise us to put it in the Azure Key Vault, which we could do. We know how to do that. We saw that earlier in this training. Or I could use a steganography tool to hide it, or I could move it off to some external drive. I'm going to click on Finish. All right, Microsoft Azure Backup's now available. Here's the location of the passphrase and the TXT file. Again, reminding us to save a copy in the Azure Key Vault. We'll go ahead and close out of here and launch the Microsoft Azure Recovery Services agent. Now, by the way, if I didn't go through the process of registering the server, I could come back in here and I could do it again, right, by clicking on Register Server. But let's go ahead and schedule a backup. So it's telling us, before you begin, make sure you know what files and folders to include, what files and folders to exclude, what days of the week should the backup occur, when during the day should it occur, and how long do you want to retain the backup. That's good information to remember for the exam. I'm going to add items. I drilled way down here into the file system to find the slides that I'm using, the PowerPoint slides that are actually the introductions that I used in my videos for all of these sub-lessons. That's a good candidate. Let's go ahead and back that up. Click on OK. And I could have excluded some things, but I'm going to go ahead and get all of those slides. Click on Next. I want to schedule a backup every day at 10 p.m. The maximum is allowed 3 times a day. So I'll just do one time at 10 p.m. and click on Next. Here's the retention policy. The weekly retention policy default. The default is 180 days. The weekly retention policy 104 weeks. The monthly retention policy 60 months. And the yearly retention policy 10 years. If I was storing data that was subject to compliance, like GDPR or HIPAA or some other governance or mandate that required me to store this for several years, I would probably go with the yearly retention policy. So I'm going to say the weekly retention policy, and let's do this for 100 weeks, and click on Next. Do I want to automatically back up over the network, or do I want to use the offline backup option? And that's Azure Data Box, for example. Now I want to mention one thing here for the exam. Let's say you're protecting your infrastructure as a service VMs, right? And you're using Azure Backup. Because right now I'm backing up on premises, correct? But what if I was going to go ahead and back up my VMs in the cloud? Only VMs in the same region as the vault will be available for backup. So because of that, it's a best practice to select geo-redundant storage or read access geo-redundant storage to be associated with the vault. That way you're making sure that if there's a regional outage that affects the access to your VMs, you'll have a replicated copy of backups in another region that you can restore from. Remember that for the exam. Click on Next. Confirm everything. Click on Finish. Creating the backup schedule. And close. Now I could say Backup Now. If I click on that, Backup Now will back up this server. I'm going to let this backup happen. Okay, so the backup is successfully completed. Click on Close. I'm going to minimize the Mars agent. Okay, I'm on one of my Windows servers. And remember I talked about the Azure Backup Server as one of the options? Well, the Azure Backup Server is a standalone service, and I would install it on this Windows server, and it'll store the backed up data in a Microsoft Azure Recovery Vault. The backup server has a lot of the workload backup functionality of DPM, Data Protection Manager, but it does not back up to tape, and it doesn't integrate with System Center. So keep that in mind. I could install Azure Backup Server on this Windows server. I could also use it on a Windows client. It can be used on Linux servers, VMware VMs, Exchange, SharePoint, SQL Server as well. Okay, I'm back in Microsoft Azure Backup. If something happened to those files locally, okay, so for example, if I had them deleted, or maybe there was a ransomware event, I can go up here to Action, and I can recover the data on this server. Click on Next, individual files and folders, not an entire volume. I'm going to select the volume, which was C, and go ahead and mount it. Okay, so it found the folder. I'll just go down in here and find, and there's the slides, and I can recover them using the Mars client. All right.
Azure Backup Reports are supported for Azure Virtual Machine Backup and file and folder backup to the cloud by using the Azure Recovery Services agent. You can view reports across vaults and across subscriptions. The frequency of scheduled refresh for the reports is 24 hours in Power BI. You can also perform an ad hoc refresh of the reports in Power BI where the latest data in the customer storage account is used to render reports. The prerequisites are that you create an Azure storage account to configure it for reports, that you create a Power BI account, and then register the resource provider Microsoft.Insights if it's not registered already.
Now in Mars itself, your reporting capabilities are really pretty limited. You can go look at the status of the last backup. You can see the job details, for example. You can see available recovery points, and you can look at that information. You can also see the last recovery or the last restore that was done, and you can see 16.86 megabytes was transferred. We also have alerts up here we could look at. There's no alerts generated during the last backup run, but you can also configure notifications from the alerts blade to receive emails for backup failures, and you can click on this and learn more about that. And this is under the Monitor and Manage Recovery Services Vaults article at docs.microsoft.com. Another document I want to show you is to configure Azure Backup Reports. Now I'm not going to do this. It involves installing a bunch of different software, but this just shows you the steps. You're going to access reports using the Power BI, Power Business Intelligence. Gives you some different scenarios here. The reports are supported for Azure Virtual Machine Backup and File and Folder Backup to the cloud using Mars like we just did, but they have other scenarios as well. There are some prerequisites, okay? So you create a storage account to configure it for reports. You know how to do that. You also create a Power BI account to view, customize, and create your own reports by using the Power BI portal. So if you click on that, you would create your Power BI account. Then you register the resource provider Microsoft.Insights if it's not registered already. Use the subscriptions for the storage account and the Recovery Services Vault so the reporting data can flow to the storage account. And so to do this, remember on the exam, go to the Azure portal, select subscription, and choose resource providers and register that Microsoft.Insights resource provider. And if you go and get this article, but you can walk down and you can look at this for configuring storage accounts for reports and viewing your reports in the Power BI. This is not a heavily tested area on the exam. You might get one question about it. However, I might want to recommend that as a homework assignment that you come up and get this article and walk through this process. Hopefully you've already gone through the process of configuring Azure Backup in the previous 2 sub-lessons and you're doing that yourself. So take a little homework assignment, go up and view some reports in Power BI.
Every Azure Backup component supports incremental backup regardless of the target storage. Incremental backups only transfer the changes made since the last backup. This is very storage and time efficient. With a full backup, each backup copy contains the entire data source. Full backups consume a large amount of network bandwidth and storage each time a backup copy is transferred. With a differential backup, you're going to store only the blocks that changed since the last initial full backup. This results in a smaller amount of network and storage consumption. Differential backups, however, are inefficient. An incremental backup offers high storage and network efficiency by only storing data blocks that changed since the previous backup. There's no need for regular full backups. It moves less data and it saves storage and network resources, thereby lowering the total cost of ownership, TCO.
As you can see, I'm in my Shannon Vault 99, my recovery services vault, where I can come in and create a new backup, a new site recovery. If you scroll down though, over the left-hand side of the menu, under monitoring, I can see backup jobs, and here I'll see the ad hoc backup jobs that I did with Mars. I haven't had a scheduled backup occur yet, but if you go up to manage, you've got backup policies up here. I can view the default policy. I can go back and create or add a backup policy for my virtual machines or SQL Server in Azure VM or an Azure file share. And again, just name the policy, create your schedule, daily, the time, either go with UTC or I could choose where I'm at, Central Time, and I can retain for however many days and click on OK. For the exam, I really want you to remember that you can create 3 different policy types in the backup policy. The Azure Virtual Machine lets you specify the backup frequency, retention period, and the backup point on a weekly, monthly, or yearly schedule. We just saw the Azure file share, but you can see what we can do here with our daily backup. Or if you do SQL Server in Azure VM, you can use the SQL Server specific backup technology. That's where we get back to the full and the differential that we talked about in the introduction. There's also log backup with an associated schedule for each option. If I click on that, notice down here, I can also designate that SQL backup compression is enabled on the backups. Be prepared for a backup policy question on the exam. Module 3 is called Deploy and Manage Virtual Machines. In the first lesson of this module, Lesson 9, I'll show you how to create and configure a VM for Windows and Linux. I'll follow that up with automating the deployment of VMs. After that, I'll teach you how to manage Azure VMs, and to finish up this module, I'll explore management of VM backups. Lesson 9, Create and Configure a VM for Windows and Linux. In this lesson, we'll configure high availability, we'll configure virtual machine attributes, and we'll deploy and configure scale sets. One of the best advantages of using a cloud provider like Microsoft Azure is the affordable high availability. Now remember, high availability is not the same thing as durability. Let's go to a demonstration and look at how we can configure high availability. I want to begin this demonstration with a diagram. And when we talk about high availability, what we're really talking about is resiliency. So in this graphic here, you can see the outer box is an Azure region. To ensure resiliency, Azure is going to have a minimum of 3 separate zones in all of the enabled regions. And that means that each one of these zones has their own independent network, their independent HVAC system, their independent power source. Here we see a classic 3-tier application deployed with a virtual machine of each tier. So the W is for the web tier, the M is the middle or the business logic tier, and the D is the data tier or the database tier. So we have a virtual machine from all 3 tiers deployed in each of the 3 zones for enhanced availability. Now you also want to know what services are supported with different availability zones. That will go into the choice that you make. So you might want to check out this document. What are availability zones in Azure? Here's why. If we go down, we're going to see the different services that are supported by region. If I'm interested in the excellent Azure Cache for Redis service, well, then I want to make sure that's available in the central US or maybe West US. So let's go down here. Let's find that Azure Cache for Redis. And lo and behold, it's actually available in all of the regions. But as you can see here, not all services are available in all the regions. So for example, Azure Cosmos DB, not available in all the regions. Neither is VPN Gateway, Express Route Gateway, Application Gateway. So that's an important factor in making decisions. Now to get resiliency at a more granular level, we can use availability sets. This allows us to control availability for 2 or more virtual machines in the same application tier. So you have at least 2 virtual machines per availability set. That way, at least 1 VM is available in the event of a host update or some issue with the physical hardware that it's hosted on. And having at least 2 VMs in the availability set is a requirement for the service level agreement for VMs that are 99.95% available. So here we see availability set for the front end web, and then the middle tier mid avail set, and then the back end data avail set. Virtual machines should be deployed into these availability sets based on their application tier, as we see here, or it could be based on their workload. Now the availability zone decision is made when you actually spin up the VMs. Also, when you spin up the VM, you have the ability to create an availability set or specify availability set within a resource group. Let's go check this out in the Azure portal. On the exam, realize that in the portal there's a couple of ways to create an availability set. So for example, if I go to the plus create a resource up here, and I just start to type in avail, I'll see availability set, and I can create one here. I can give it a unique name. And by the way, the name can't be used by any other availability sets within the resource group, which I'm going to choose test group. And of course, you're going to choose your fault domains and update domains. So the fault domain, which is defaulting to 2, basically VMs in the same fault domain will share a common power source and physical network switch. In the update domains, which by the way we have 5 by default, if VMs are in the same update domain, they get restarted together during planned maintenance. Azure never restarts more than one update domain at a time. Well, I could do this here, but I could also just go over here to virtual machines, discard these changes, go directly to virtual machines, and spin up a VM in my test group, name the VM. We'll call this my middle tier VM 99. Choose my region. I'm going to go with US Central US. Availability options. Well, the default says no infrastructure redundancy required, but the whole reason we're here is it's all about availability. So let's click on the down arrow. Notice that this instance, I can choose to put it into an availability zone. And if I choose that option, it's going to ask me what availability zone, 1, 2, or 3, okay? Remember, by default, there's at least 3 availability zones per region. So in Central US, I'm choosing between 1, 2, or 3, right? And so if we went back to my diagram and talked about the middle tier, if we have a diagram, we want to kind of follow our topology or follow our design. So that's one option. Or I could choose to put it into an availability set. Now, if I would have created one a second ago, it would be available. I could click on the drop down. By the way, before I started this demonstration, I actually created my load balancing avail set 99. I created that so that you would see that it would show up there. I can also create a new one right here. So if I click on create new, I would give it a name, choose my fault domains, and choose my update domains. By the way, when I come through this option, by default, I'm going to be using manage disks. But let's say I want to go ahead and choose the availability set that I've already created. Scroll down here, my image. You can see my different options there. It's very important to have a good feel for the different options on the exam. I'll just go ahead and stick with the middle tier being an Ubuntu server. I can change the size. Definitely going to stay in the general purpose family. I'm a cheapskate, so I'm going to go choose B1LS standard general purpose for $464 a month. No use spending extra money if you don't have to. I can authenticate with a password or secure shell public key. This is a middle tier server, so I'm not going to have any public inbound ports. And I could go, of course, right to the next step, and we can see the next step would be, disks, then networking, then management, then advanced settings, and then tags. But the goal of this was to show you how to either place an instance into an availability zone, one of the 3 in this region, or to go ahead and put it into availability sets. By the way, on the exam, just in case, the commandlet to create a new availability set is new-az availability set. And then you would choose the resource group. Okay, so it would be followed by resource group name, and then the name of the resource group, which could be a variable. Other settings would be things like the name, the location, platform update domain count, platform fault domain count. Those are the 2 things we saw earlier. Remember, the fault domain was 2, the update domain was 5. If you're using the CLI, you're going to use the command azvm availability-set and then create.
In this demonstration, we're going to configure attributes like monitoring, networking, storage, and virtual machine sizing.
Well, we're back in the virtual machines area, and as you can see, I've already created a couple of Linux virtual machines. You watched me create this WinServer 19-1 in a previous sub-lesson. Let's go back in and add another one, and this time we're going to take a little bit more time to look at the different attributes and options we have. Let's go ahead and choose our test group again. Going to go with Shan VM 001, Central US. We looked at availability in the previous sub-lesson. When we did, we chose availability set. Let's choose availability zone 1 this time in the central region. For our images, I've already had a couple of Ubuntu servers. I've already brought up a Windows Server data center. How about a Red Hat Enterprise Linux server this time? The size they're giving me is standard D2 V3 with 2 virtual CPUs and 8 gigs of memory. If I want to change the sizing there, I obviously have tons of options. Now this is actually a really important decision and not one to just blow by. There's a lot of scenarios where the amount of compute processing that we need will differ from day to day. Maybe, Tuesday, Wednesday, and Thursdays are the really big days. It could be hour to hour. For instance, in a lot of enterprises, LOB or line of business applications are used heavily during the work week, but on weekends, they see little usage. Your workloads might need more processing time because of scheduled events like maintenance windows or backups. And the good news is Azure Resource Manager based VMs make it pretty easy to change the size of a virtual machine after you've deployed it. Okay, let me step away real quick and show you how to resize a VM in PowerShell. And this is going to be something you'll want to know for the exam. First thing I'm going to do is make my location Central US. Then I'm going to use the get-az-vm-size commandlet to pass the name of the region to the location parameter to see all the available sizes in our region. We have to make sure it's available. I could also specify the resource group in the VM name to get the available sizes in the current cluster. After I do this, I'm going to use the following code to modify the VM to our new size. So I'll create some variables. Resource group name is test group. VM name is going to be shan VM001. The size, I'm going to change it to standard A2 V2. The variable for VM is basically using the get-az-vm commandlet, followed by the switch, which is being passed the variable RG name or test group, then the VM name switch, which is being passed the vname variable, which is shan VM001. After that, the VM hardware profile.vm size variable is going to be the size, which I'm designating as standard A2 V2. And finally, I use the update-az-vm commandlet. The VM switch is basically the VM variable. I had to put the dash in there, followed by the resource group name, which of course is being passed the variable test group. In the command line, the command is az-vm resize, followed by the resource group. You could use the same variable, RG name, then the name, then the size, which in my case would be standard _A2 _V2. Also remember for the exam, you want to be generally cognizant of the different families, general purpose versus memory optimized versus compute optimized, and so on. I'm going to click on select. Let's go on down. Do I want public inbound ports? I'll click on allow selected ports, HTTP, and secure shell. Next we'll go to disks. Basically we're here at the storage subsystem for our VMs. There's a lot of options and features to think about when you configure disks. What are your disk types going to be? For example, premium SSD, standard SSD, standard HDD. And in some situations, I'll also have ultimate SSD available. I don't have it right now for this VM size and location, but it is a fourth option. Premium SSD would be best for I/O-intensive enterprise workloads. It delivers a consistent performance with low latency. Standard SSD provides consistent performance for low IOPS workloads. And standard HDD is optimized for low-cost mass storage where the access is infrequent. Remember, Ultra SSD and Standard SSD can only be created as managed disks. I'm going to expand out this advanced area down here. Realize that each VM can have 3 different types of disks. You can have an operating system disk or an OS disk. That would be the C drive on our Windows, and in this case on Red Hat, it would be the /dev/SDA. It'll be persistent. It'll be stored in Azure storage. You can also have a temporary disk, which would be a D drive in Windows, or dev SDB on Linux, used for short-term storage. And the third is a data disk, which is a registered SCSI drive. These can be attached to a VM, and it depends on the VM instance as to how many you can attach. Data disks have a maximum capacity of 4,095 gigabytes at this point in time. Down here we see managed disks. These handle storage for you automatically. They integrate with Azure availability sets, and they make it easy to change between standard HDD to premium SSD storage. Unmanaged disks basically make you responsible for distributing your VM disks in your storage accounts and for capacity planning and availability. Remember, an ephemeral OS disk is one that lives or dies with the instance. It's not supported for this particular instance size. If you want to create and attach a new disk, you can click on this link here, create a new disk, choose your disk type, name it, size it. It could be a snapshot or a storage blob or an empty disk. If I change my mind, I can go back. If I have an existing disk, I can click on this link and I can attach that one. Now we have a much more elaborate networking discussion coming up in this training. So let's just hit the simple things. First is our VNet. They're going to create a new VNet, test group VNet 623. The default subnet is 10.0.1/24. I'm also going to have a new public IP address. I can have a basic NIC network security group, or none, or advanced. If I choose advanced, I'll ultimately have to configure the network security group. We've already seen the public inbound ports. We're choosing HTTP and secure shell. Here's accelerated networking, which is turned off. And what this does is it basically allows single root I/O virtualization, or SRIOV, to the virtual machine. It improves the networking performance, bottom line. This can be enabled now or after I create the virtual machine. It has to be a supported size for accelerated networking, and all VMs in an availability set must be stopped or deallocated before enabling accelerated networking on any NIC. Under load balancing, it says you can place this virtual machine in the back-end pool of any load balancing solution. Next, we go to management. Basically, here you're going to configure monitoring. There's several tools and services available to help us monitor different aspects of an application or our infrastructure. You can also add monitoring solutions like System Center Operations Manager or third-party solutions. Here we have boot diagnostics. We have operating system guest diagnostics, all of which is going to go to my ShanStore99 storage account, or I could choose a different one. Notice several features are off automatically. System assigned managed identity allows you to authenticate, typically using something in Azure Key Vault without having to store any credentials in code. Also, you can say, I want to use Azure Active Directory. I can log in with my AAD credentials. Auto shutdown basically allows me to shut this down daily. You see the shutdown time and the time zone and a notification before shutdown. I can also go down here and enable backup right here as well. And I could use a existing recovery services vault. As we saw earlier, my Shannon Vault 99, I can use the default policy, or I can go and create a new policy, and you already know how to do those things. I'm going to bypass the advanced area and tags area, and I'm actually not going to follow through all the way on creating this virtual machine. But again, this is something that you're going to have to make sure that you do in your own account and walk through, not necessarily going all the way to the create phase, but really making sure that you understand the different options.
A virtual machine scale set enables the deployment and management of a collection of identical auto-scaling virtual machines. An Azure load balancer will distribute traffic to the VM instances in the scale set. You can scale the number of VMs in the scale set manually or define rules to auto-scale based on resource usage like CPU, memory demand, and network traffic. Let's go configure a scale set now.
As you can see, I've navigated to the virtual machine scale set area. The fastest way to get here is just go to Create a Resource and just search for virtual machine scale set. Type that in there and you'll see this page. As mentioned, you want to consider using a VM scale set or a VMSS if you have a workload that needs to dynamically add or delete instances to deal with your elasticity, your provisioning and deprovisioning, your increased and decreased demand. Now by default, VMSS supports up to 100 instances, but you could scale up to 1,000 instances if they're deployed with this property, single placement group set to false. A placement group is kind of like an availability set. It has its own fault domains and upgrade domains. So by default, a scale set consists of a single placement group with a maximum size of 100 VMs. But if you set that property to false on the scale set, it can then have multiple placement groups and then give you a range of 0 to 1,000 VMs. By the way, on the exam, remember that using multiple placement groups is often called a large-scale set. This property is often set using ARM templates that we're going to look at, by the way, in the next lesson. So let's just go ahead and click on the Create button here. I'm not going to deploy this and use this in production. I'm going to conserve my costs, but let's take a look at the blade here. Obviously, we're going to name the virtual machine scale set the VMSS. What is the OS disk image? At this point in time, as far as Windows is concerned, we can go to 2016 data center. Ubuntu is going up to 18.04 LTS. Choose your subscription, choose your resource group, choose your location, choose your availability zone or multiple availability zones in your region, configure a username and password, and then select down here your instance count. So we can choose our number of instances, say 6 instances, choose our instance size. If you deploy as low priority, you can save over 80% on your deployment. Obviously, we're typically going to use managed disks, which is the default. I'm going to click on Show Advanced Settings. This was the feature I was talking about, enable scaling beyond 100 instances. Basically, by saying yes, you're going to change that single placement group property to false. If you click on Enable for auto scale, it's going to present you with a bunch of options here. The minimum number of VMs, the maximum number of VMs, at what percentage CPU threshold should you scale out, the number of VMs to increase by, the scale in threshold, 25% is the default, and the number of VMs to decrease by. Below that you have your networking settings. Creating a scale set in the CLI or in PowerShell is a quite elaborate process. It's quite a bit of code, so don't be too concerned with having to know that for the exam. But if you're curious for the real world, you can always go and just search for that at Azure. In this lesson, we're going to explore the Azure Kubernetes Service, AKS. Kubernetes is container-based application management for the networking and storage component of containers. Kubernetes focuses on application container workloads and not the underlying infrastructure by providing a robust set of APIs. It allows you to build and run portable microservice applications in both stateful and stateless environments. It's an open platform, so you can build your applications using the programming language that you want, operating system, libraries, or messaging bus. You can also leverage your existing CI/CD, continuous integration, and continuous delivery tools to schedule and deploy your releases. AKS offers a managed service to lower complexity and management while coordinating upgrades. Now, since this course is not focused on developers or programmers, we're going to go ahead and look at the Kubernetes cluster architecture, and then I'll give you a little bit of homework. I'll give you a quick start walkthrough to go through on your own to prepare for the exam. Let's take a look at the Azure Kubernetes Service architecture and realize that the control plane on the right-hand side is the part that's managed by Azure, and you only pay for the AKS nodes that are running your applications. So here we see two main components. The control plane on the right side, the Azure managed portion, provides the core Kubernetes services and orchestration tools of your application workloads. On the left-hand side are your application workloads, the nodes. Let's talk first about the control plane components. When you spin up an AKS cluster, a control plane will be configured and created automatically for you. It's basically a managed Azure resource, and it's abstracted from you, the user. There's no cost for the control plane. All you pay for are the nodes that are part of the AKS cluster. Here we see 4 components of the control plane. First is the scheduler. When you create and scale up applications, it's the scheduler that decides what nodes can run the workload and then starts them. The API server is how your underlying APIs are exposed. This component offers the interaction for management tools such as Kube Control or the Kubernetes dashboard. Below that is a database that maintains the state of your Kubernetes cluster and configuration. It's a highly available key value store within Kubernetes. And then finally, we have the controller manager. This is what manages a number of smaller controllers that basically act as replicating pods and handle node operations. Kubernetes uses pods to run an instance of your application. So basically a pod represents a single instance of your app, and they typically have a one-to-one mapping with a container. Over on the left-hand side are your applications and supporting services. This is all contained within a node. So an AKS cluster has one or more nodes, which is basically an Azure VM that's running the Kubernetes node components and the container runtime. First, we have a kubelet. This is the Kubernetes engine that processes the orchestration requests from the control plane and the scheduling of running requested containers. Below that is the kube proxy. That's where the virtual networking is handled for each node. The proxy will route network traffic and manage IP addressing for services and pods. The container runtime is the component that allows containerized applications to run and interact with virtual resources such as storage or the virtual network. And then of course we have the container itself. Alright, so let's jump over to an excellent quick start walkthrough. I'm going to give you this as a homework assignment where I want you to go and do this yourself in your own Azure environment to help prepare you for the exam. Alright, your assignment is to go up to docs.microsoft.com. I'm in the EN-US, so go to whatever language you're using, into the Azure directory, AKS, and then it's the Kubernetes walkthrough portal. So to prepare for the exam, I want you to create this very simple voting app where you basically say, I vote for cats and I vote for dogs, okay? And you go through the process of creating an AKS cluster in the portal, connect to it, run this application, test it. You'll do a little monitoring of health and some logs, and then finally make sure you delete the cluster so you don't pay for it. If you don't have an Azure subscription by now, I really want you to go get one, but if not, go ahead and just create a free account and go do this in your own time, and it'll cover all the things you need to know for the exam. In this brief lesson, we're going to look at Azure Container Instances, or ACI. With Azure Container Instances, you can rapidly develop apps without managing virtual machines or having to introduce any new tools. You can focus on designing and building applications without the overhead of managing the infrastructure running them. You can use ACI to deploy additional compute power for those workloads that are demanding on an ad hoc basis. For instance, with the virtual kubelet, you could use ACI to burst elastically from your AKS, your Azure Kubernetes Service cluster, when traffic starts to spike. We looked at AKS in the previous lesson. ACI offers hypervisor isolation for each container group for securing containers by running them in isolation without a shared kernel. And if you run out of capacity in your AKS cluster, you can scale out extra pods in ACI without having to manage additional servers. There are several use cases for Azure Container Instances. You can combine ACI with the ACI Logic Apps connector, with Azure Queues, and Azure Functions, allowing you to build robust infrastructure so you can easily and rapidly scale out your containers as needed. You can use ACI for data processing, where source data is ingested, processed, and placed in a durable store, such as Azure Blob storage. You can also use Azure Machine Learning to deploy a model as a web service on Azure container instances. As a homework assignment, let's go take a look at docs.microsoft.com at a walkthrough that you can do on your own in your Azure account to do this exact thing. If you go to docs.microsoft.com and look at the article Deploy a Model to Azure Container Instances, you can go through the walkthrough and learn how to use Azure Machine Learning to deploy a model as a web service in ACI. Now, you won't have to do this on the exam, but you will want to understand the use cases for Azure Container Instances on the exam. If you scroll down, though, it'll show you your options for deploying to ACI. Lesson 10, Automate Deployment of VMs. In this lesson, we'll modify an Azure Resource Manager ARM template. We'll configure the location of new VMs. We'll configure and deploy from a VHD template. We'll save a deployment as an ARM template. And finally, we'll deploy Windows and Linux VMs. With ARM, you can create a template in JSON format that defines the infrastructure and configuration of your Azure solution. You can repeatedly deploy your solution throughout its lifecycle and be confident that your resources are deployed from a single truth. Before we can modify an ARM template, we need to be aware of the basic structure of this JSON template and the formatting of it. The first element is the schema it's required, and it's basically a URL, as you can see here, the URL to the JSON schema that defines the version of this template language. So for example, 2015-01-01. Next we have content version. That's your versioning. So you can create your own versioning model of the template, like 1.0, 1.00, 1.000, any value you want to offer. Basically to document any changes in your template. This way you can make sure that you're using the correct version of the template. The content version is also required. The API profile element is not required. It's basically an API version that serves as a collection of API versions for resource types. You could use this to avoid having to specify API versions for each resource in the template. Next is parameters, not required. These are basically values that are offered when the deployment is executed, when you customize your resource deployment. Variables are also optional, and these are values that are used as JSON fragments in the template to designate template language expressions. Functions, also optional, are user-defined functions that are available within the template. Resources is required, and these are resource types that are deployed or updated in a resource group or a subscription. Now remember, this template, if you go to the schema up here, that is actually the path for resource group templates, which is what we're focused on in the exam. However, you could have subscription deployments. If that's the case, it'll actually be a different URL that's up there in the schema area. As a matter of fact, it would say 2018-05-01/subscription deployment template.json. So keep that in mind. We're focusing here on resource group deployments. Next we have outputs, and that's also optional, and these are values that are returned after the deployment. Now obviously each one of these elements has different properties that you can configure, so we'll look at some simple examples. Now on the exam, your focus needs to be on going through the process of spinning up a virtual machine, which we'll go ahead and do real quick, but instead of creating the virtual machine, we're going to do something that we've seen before already in this training, and that is download a template for automation. Then once you have that template, you can make a modification to the actual template. So I'll just go here and quickly go through and add. I'll name it and then just stick with the defaults here. Create a password. I'll have no public inbound ports. Go to disks, standard SSD, networking, keep all the defaults, management, turn off all the diagnostics, no advanced settings, no tags, and I could have skipped right to the review and create, by the way, but then notice down here at the bottom, download a template for automation. So you can see now here in the portal, we've got our generated template. There's the schema, there's the content version, which is 1.000, and of course our parameters, for example, location, network interface name, and you can see the different types we have for these parameters. Strings, arrays, if I scroll down, much more. Then we have, of course, variables, network security group ID, VNet ID, subnet reference, and our resources. Notice on the left-hand side over here, you can expand out different parameters, different variables, and different resources. So notice it says virtual machine size, or admin username, or virtual machine resource group. Now this is a read-only editor, okay? But if I wanted to actually modify this, I could download it, make my change, let's say put in a different virtual machine name or a different resource group, and then deploy it with the deploy button. That's all we're going to cover in this sub-lesson, okay? Just kind of an introduction to the actual template itself. In the next sub-lessons, we'll actually look at some management and some configuration and deployment of a ARM template.
In this short demonstration, we'll use the ARM template to configure the location of a new VM. Now let me just say this. ARM templates aren't a huge area on this exam. However, it is a huge area going forward. So make sure that from this point on, you start to learn as much as you can about the ARM template in Microsoft Azure. All right, let's go to the demonstration.
Alrighty, let's say I just spun up a new virtual machine. Let's say it's dev VM2, which is an Ubuntu image, and I select that particular image. I could scroll down here under the settings area and find export template. And if I choose that, don't forget, once I get into this area, I can see the template. I can also go up here and say I want to see parameters. Okay, it'll show me just the parameters. I want to see the CLI, where if I wanted to configure it in the CLI, I could. Take a look at that. A lot of if statements and FIs. PowerShell. Come down here. Here's select AZ RM subscription, for example. Get Azure RM resource group. Okay, so there's PowerShell. There's also .NET, and there's also Ruby. So different options to work in here. All right, let's go back to the template. I've got a new VM I've spun up called dev VM2, and I decide I want to change the location. This is actually one of the objectives of the exam. I come in here to resources, okay? And under resources, I look for location, and I could just modify this to central US, for example, and then I could deploy it. Or I could add it to the library and then deploy it later.
In this lesson, we'll deploy a generalized VHD image to create a new Azure VM resource using a Microsoft-supplied Azure Resource Manager template and Azure PowerShell script.
What I'm going to do in this particular demonstration is kind of take you to some documentation where you can go through a walkthrough and deploy a virtual machine from your VHD, a user VHD. Basically involves configuring a VHD template. But before I do that, I want to talk about something that may come up on the exam that involves having two Active Directory tenants. Now, in my situation here, in the demonstrations that I've been doing so far in this training, I only have one tenant, okay? So let's say, for example, hypothetically, that you had 2 tenants, and we can use, Microsoft's Fabricam and Contoso, for example. But you have an account that you use that signs in to both of those tenants. However, you want to configure the default sign-in tenant for the Azure portal. So how would you do that? Well, the answer is in PowerShell. So you would use PowerShell or the Cloud Shell, and you would run this command, set-azure rm context. This commandlet will configure the authentication information for commandlets that you run in a current session. And that includes tenant, subscription information, and environment information. So remember that scenario for the exam. I'm extremely confident that you wouldn't have to deploy this for the exam, but however, you may want to look at deploying an Azure VM from a user VHD. So what they do here in this walkthrough is they have you copy this template. And this is a template for VHD deployment. And so I did this. I saved it to VHD to image.json. Then you want to go into this particular JSON document and configure all of these parameters, and there's quite a few of them, okay? For example, the resource group name, subscription ID. You can use PowerShell commands to get this information. You can go to the portal, the name of the virtual machine, the URL of the VHD, and so on. Then you'll copy and edit this PowerShell script that's going to give you value for a couple of variables, the storage account variable and the VHD URL variable. Then you run it to create the Azure VM resource using your existing generalized VHD. After you do that, you have to certify your VM image to be able to use it.
On the exam, you'll definitely need to know how to save a deployment as an ARM template. So let's go take a look.
Okay, so technically this lesson is entitled Save a Deployment as an ARM Template, but frankly, you already know how to do that. We've already done that. So what I really want to do in this sub-lesson, and hopefully you're going to watch this one, is try to pack it full of things that are important that may come up on the exam related to these ARM template topics. So let's just go and grab a virtual machine here, my Win server. As you already know, you can export this as a template, so let's click on that again. I could add this to the library. Now, I've already done this. Just clicked on the button, add it to the library. If you were to do that, how would you find it? Well, if you go to All Services, and you just come up here and you just type in Templates, you'll see Templates right here. Click on that, and it's basically Home Templates. So here is that exported Windows Server ARM template. All right. That's something to remember for the exam. Let's take a look at it. This template that's in my library, I can go ahead and deploy it right now. If I do, it's going to ask me for some basic information, basically the subscription, the resource group, the location. Notice that I can also put some other settings in here. For Microsoft Insights Diagnostics, I've also got the virtual machine name which I can change. There's terms and conditions down here. Basically, you agree to the terms and then you purchase this custom deployment. However, I can edit this template right here in the library. I can also edit certain parameters by clicking on Edit Parameters. And then from here, I can save it, I can download it again, or I can go ahead and load the file. Make sure you walk through that so that you can answer these questions yourself for the exam. Let's go back here to Edit Template. Notice that in this template, I can add a resource to the template. I can just select it from the drop-down list, cancel out of there, go back to my templates area again. Okay, some other things that might show up on the exam. Let's say that you have deployed from a custom template, and let's say it's this one, my WinServer ARM template.json. Let's say you get a notification that this virtual machine is going to be having to have some maintenance. So you have to move this to a different host, and it must be done right away. It's in the pay-as-you-go subscription. Moving this VM that was deployed from a template to a different subscription is not going to be the answer. In addition, check this out. If I go to, let's say, this virtual machine. Let's go back to dev VM2. Notice that if I scroll down here, there's a update management blade under operations. If I select that, it tells me that the solution cannot be enabled because it's not running. Okay, but if I had it running, I could enable the update management. All right, that's something good to know, but it's also good to know that enabling update management on the blade is not what I want to do if I need to move a virtual machine to a different host right away. So, what is the solution? Okay, after I just gave you two things that are not going to work, what is the real solution? The real solution is to just redeploy the VM. Remember that for the exam. Okay, here's another situation you may have to be aware of for the exam. This particular template is a Windows Server 2016 data center image. Okay, let's say I'm planning on automating deploying my VMSS, my virtual machine scale set, and that scale set uses this image. Let's say I want to make sure that when those VMs are provisioned, that certain application components are installed. They could be custom applications, they could be, Windows servers, whatever. So what would I have to do? Well, obviously I have to create a virtual machine scale set and typically do that in the portal, but it also introduces a new section of the resource manager template. Now, if I go to this particular template and look at view template, I'm not going to find it. It's called extension profile. So it would be an extension profile section, and it looks like this. So basically the extension profile is going to outline what's applied to my Windows Data Center instance in a scale set. So you would specify, for example, a publisher of Microsoft.Azure.extensions. That's publisher. The type would be custom script. We're setting auto upgrade minor version to true. And then one of the settings is a file URIS property. This defines the source install scripts or packages. So you can see here, this points to raw GitHub user content.com. So this is a sample script from GitHub that installs and configures the Nginx web server. So keep that in mind. Okay, here's another exam tip for you. There's a tutorial called Monitor and Update a Linux Virtual Machine in Azure. Okay, so this is the name of the tutorial. Here is the URL up here. I want to scroll down to a particular area of interest. Okay, so it's the diagnostics extension. You can get more granular in VM specific metrics if you install the Azure Diagnostics extension on the VM. So basically, you would go to the portal, you would go to resource groups, choose the proper resource group, choose the proper VM in the resource list, and then choose diagnostic settings, choose a storage account from the drop-down, and then there's a enable guest level monitoring button. You can see kind of a screenshot right here. And that is the Azure Performance Diagnostics extension. Remember that for the exam. Now, we learned about availability sets earlier on in this training, remember? And I went to basically all services and just typed in availability sets. And so I'm in this area, and this is an availability set in the test group that I already created earlier in this training. So here's a scenario. I have a availability set. It's called MyLB Avail Set 99. Let's say it has 3 virtual machines in it. Now at this point it has 0, but let's just pretend it has 3 VMs in it. By the way, I can go to Settings Virtual Machines and I would be able to see them. So let's say I've named these MyVM1, MyVM2, and MyVM3. Well, I want to reconfigure MyVM1 to make it larger, but I get some kind of failure notification, right? So what do I have to do? Bottom line is this. I have to stop all 3 of the VMs, MyVM1, 2, and 3, stop them, resize the first one, VM1, MyVM1, and then go ahead and start all 3 VMs again in the availability set. Something to keep in mind. Let's go back to WinServe 19-1. And it's stopped right now, but let's say hypothetically that this were actually hosting a LOB or a line of business application. So it needs to be up on 24/7, okay? Let's assume that WinServe 19-1 has one network interface. Go to networking, one network interface, and it has a managed disk, which it does, and the size, if we click on that, is using DS1 version 2, but I want to make some changes. Maybe I want to change the size to, let's say, DS3 version 2. Maybe I want to add under disks a 500 gigabyte managed disk. I might want to add an extension, let's say some type of agent, and I want to add another network interface. So 4 things: change the disk size, add a managed disk, add an agent extension, and add a network interface. Of those 4 things, what do you think is going to cause downtime for WinServe 19-1? Actually changing from DS1 version 2 to DS3 version 2, changing that disk size is actually going to be the one that causes downtime. Remember, while resizing the VM, it must be in a stopped state. Okay, let's go to a different virtual machine, dev VM version 2, and let's export the template. Let's scroll down here and let's say that under this OS profile area, let's say that I wanted to modify this JSON template and I wanted it to reference an administrative password on this Ubuntu VM. But I don't want that password to be stored in plain text. Well, what would I do? Well, hopefully you remember this from earlier in this training. I'm going to create an Azure Key Vault and an associated access policy for the administrative user. Then the template can retrieve the password stored in the Key Vault, and it won't be in plain text in the template parameter area.
In this demonstration, I'll show you how to automate the deployment of Windows and Linux VMs with ARM templates. By the way, an excellent resource is the Azure Quick Start template site. Go check it out. In the meantime, let's go look at a demonstration.
Okay, when it comes to deploying VMs through a template, whether it be Linux or whether it be Windows, really the best place to start and to actually spend quite a bit of time here as a learning tool is the Azure Quick Start templates. I want to highly recommend that you come spend some time here, not just before the exam, but as a useful resource for deploying all different types of resources to Microsoft Azure. Now, as I scroll down here, you can see there's 795 Quick Start templates in the gallery at this point in time. So let's just click on See All. And then over here on the left-hand side, we can sort these by different resource types. Now, here's one right off the bat that should be looked at, okay? Deploy a simple Windows VM. So let's click on that. You can browse this on GitHub, but you can see it's going to deploy a simple Windows VM with a few different options for the Windows version using the latest patched version. It's going to deploy an A2 size VM in the resource group location and then return the fully qualified domain name of the VM. So you can see down here there's some parameters that you'll have to provide values for. Admin username, admin password, DNS label prefix, the unique DNS name for the public IP used to access the virtual machine, Windows OS version, and then location. Down here, you can see a PowerShell that creates a new resource group. We know that command already, new-az resource group, followed by new-az resource group deployment. You can see it's referencing the URI of the template, which is at this location. So to deploy this, you just simply click on Deploy to Azure, and it brings me right up into Deploy a simple Windows VM. So I would choose my resource group. For example, here's one I just created recently. The location's already going to be in Central US. You provide these values. These are the values we saw just a while ago, right? Admin username, admin password, DNS label prefix, OS version,
It's defaulting to 2016 data center, and of course, location. It's using this variable. You can edit the template. We can break down the different parameters. Those are the ones we saw. Different variables. Excellent. And then resources. If I want to add a resource, I can click on the Add Resource button and choose something like a storage account, an availability set. I can download it. I can edit parameters. And if I'm ready, just agree to the terms and conditions and click on Purchase. If you want to back out of the operation, just click on the X. All right, let's take a look at some other ones. If you're into the compute type of resources, go to Microsoft.compute. There's a bunch of them here. Here's an SSL-enabled VM scale set, which deploys web servers configured with SSL certificates deployed securely from Azure Key Vault. Here's deploy a simple VM scale set with Linux VMs and a jump box. Click on that one. The jump box is also referred to as a bastion host or a jump host to allow you to manage through those devices. Some of the parameters here would be the size of the VMs in the scale set, the Ubuntu version for the VM, the number of instances, 100 or less, admin username, authentication type, secure shell recommended, and a secure shell key or password for the VM. If you scroll down, you can see other templates that are cross-referenced. For example, Neil has a VM scale set with Linux VMs behind a load balancer. Here's a simple VM scale set with Windows VMs and a jump box. I can browse on GitHub, got a README file, got some JSON documents, and a description with some parameter restrictions as well. If I click on Deploy to Azure, it brings me up here. You can see there's 6 resources. Here's the settings that we saw that we'd have to fill in. The SKU, the Ubuntu OS version. I might change that to 16.04. A name for the scale set, the instance count between 1 and 100, admin username, authentication with a password or preferably the secure shell public key, and then put in a key. If I like it, agree to the conditions and purchase. If I want to check out the template or edit it, I can click on this, and there we go. So this is an excellent way to see different types of templates that use different parameters, that use different variables, and you can go through these and you can see a lot of the variables here for the bastion host, okay, or the jump box, and you can go through and you can get a good handle on the way different resources are deployed. Again, don't get too hung up on having to think you have to memorize some of these things for the exam. You will not, but these quick start templates are an excellent way to really start to understand and get deeper into the JSON and some of the different options for a wide variety of different implementations and deployments in Microsoft Azure. So I highly recommend you go spend an hour up here, maybe even actually bring up some of these resources in your own subscription that meet your needs and really start to get your feet wet. All right, we'll see you in the next lesson, which is Manage Azure VMs.
Lesson 11, Manage Azure VMs. We're going to add data disks. We're going to add network interfaces. We're going to automate configuration management with PowerShell DSC. We'll manage VM sizing and VM locations. And we'll learn how to redeploy VMs. Azure Managed Disks are virtual hard disks, or VHDs. Managed disks are stored as page blobs. In other words, random I/O Azure storage objects. The 4 available disk types are Ultra SSD, Premium SSD, Standard SSD, and Standard HDD. We'll learn more about these in my demonstration. Let's get to it.
Okay, in this demonstration, we're going to look at adding a data disk to an existing VM. We're going to use the portal, and it's really very similar to the creation process, which you've already seen. So let's choose a VM. Let's go to Dev VM2.
Over here for the virtual machine menu under settings, we'll click on disks and click on add data disk. Now remember, this virtual machine was not created with managed disks enabled. So notice that it's saying attach unmanaged disk. And I'm going to show you an example of both, okay? So you can see here's the name, the source type, new empty disk, or I can choose an existing blob. If I choose that option, existing blob, it's going to have me browse my storage accounts in any subscription I have access to and choose the virtual hard disk, the VHD. Let's say new empty disk. I only have two options here, standard HDD and premium SSD. I don't have Ultra available because I'm not using managed disks here. I can choose my size, which will give me estimated performance, my IOPS limit, and my throughput limit. Browse and find a storage container. In this example, I need to come in and create one. You know how to do that. And to make sure you document the name of the unmanaged disk and the storage blob name. I'm going to back out of here. Let's see what happens if I choose a different virtual machine, like WinServe 19-1, and go to disks. Notice that even though I'm using managed disks, I still don't have the ability to use Ultra disk because it's not compatible for this particular location. When I click on Add Data Disk, it starts with the LUN number 0. I'm going to click on Create Disk and give it a disk name. Choose a resource group, standard HD or SD and premium SD, the size, source type. Here we see another option, snapshot. If you choose this, we can then browse for snapshots in the current subscription and location. Again, we see storage blob and we see none. If I choose none, it's going to create a new empty VHD with much better performance than the other option we saw earlier, 16,000 input output per second and throughput up to 500 megabytes, and then click on Create. And I'm going to pause while this happens in the background. Okay, so now on this Windows server, I have an operating system disk up here of 30 gigabytes using standard SSD, no encryption. And my data disk is disk 0. There's the name, 5,000 gigabytes, premium SSD, and also no encryption enabled. Let's look at some PowerShell to show us how to attach a new managed disk. Here's our syntax in PowerShell. I highly recommend that you do this yourself and just substitute your own variables here. I created a couple of variables right off the bat. A data disk name, which is my new data disk, the location West US. To create the new disk configuration, commented that out. We're going to create a variable, disk config. We're going to use the commandlet new az disk config. The SKU name is premium LRS. The location is West US, the location variable. Then create option, we're going to go empty as opposed to blob or snapshot. And then the disk size in gigabytes is 200 gigabytes. Next, we're going to create the data disk. Create a variable called data disk 1. Remember, we already created data disk 0 just a minute ago. We're going to use the commandlet new az disk. The disk name is going to be that variable, my new data disk. The disk is going to be from the disk config variable. When we created our new disk config, right there, and the resource group name is test group. Let's get the current VM. So the VM variable is going to use the get az VM commandlet. The name is WinServe 19-1, the one we just created the disk LUN 0 in. The resource group name is test group. Let's attach the new disk. We'll use the add az VM data disk commandlet. The VM is going to be this variable, this information. The name, data disk name is new data disk. We're going to use the create option. We're going to attach, we're going to manage the disk ID, and you can see that the disk ID is going to be LUN number 1. Can't use 0, we've already used that one. Finally, you want to update your VM after you've attached the new disk with the update-azvm commandlet, followed by the VM switch and then the VM variable, and finally the resource group name test group. Like I said, in your own environment, use this PowerShell script and go and attach your own disk to one of your VMs and be prepared for the exam.
A network interface allows an Azure VM to communicate with the internet, with Azure, and on-premises resources. As we saw in an earlier lesson, when creating a VM using the Azure portal, the portal creates one network interface with default settings. A VM can have one or more interfaces. You can also add or remove network interfaces from an existing VM as long as it's in the stopped or deallocated state. Remember that for the exam. You can also designate network interfaces and settings in advance if you want to. There's reasons for having multiple network interfaces. For example, enabling other appliances like load balancers, firewalls, and various proxies. Or you might want to isolate networks or isolate network bandwidth.
Okay, the first thing we have to realize is if you want to attach a network interface, we have to go ahead and stop the virtual machine or deallocate it, is another way to put it. We're going to do this one right here. We're going to add a new network interface to file sync test VM. So we take a look at that. We can see that right now it is running and that it has a public IP address of 13.90.200.113 and a private IP address of 10.0.0.6. Notice that it's in the test group -vnet virtual network. It's in the default subnet. If I go to networking over here, we can see the network interface. This is the one I got by default, file sync test VM434, showing the NIC's public IP address and the NIC's private IP address and other information as well. It will let me go through the process of attaching the network interface, but I need to go back here and stop this resource, and then we'll pause, and once it's deallocated or stopped, we'll go ahead and attach that network interface. All right, so it's stopped or deallocated. So remember, when I showed you before, you can actually create the network interface, but you have to first deallocate the VM before you can actually attach it. So let's go back in here and go back to networking. And now we can attach a network interface. Click on Create a Network Interface. Let's call this a backend NIC. Backend NIC 1. We'll put it in the default subnet. If we had another subnet like subnet 1, for example, or subnet 2, we could put it in there. We'll make it a static IP address assignment, 10.0.0.100. Make sure it's in the right resource group, test group. It is, and click on Create. Okay, now that it's created, we can go up and attach the network interface. There it is. Click on OK, and it's attaching. Successfully attached. So now we see our first default network interface, and now here's backend NIC 1. Here's a PowerShell script you can use to create and attach another virtual network interface. I'm not going to go through all of this. It's actually a lot more work to do it this way. You saw how simple and quick it was to do in the portal. That's the preferred method. But notice I've created some variables here for the VNet name, the subnet name, resource group name, the VM name. My NIC here, instead of being called backend NIC 1, will be called nickname, will be called new NIC. I like nickname. Nickname. You could call it Rusty or Bubba, whatever you want to do. So notice a couple of commands to remember for the exam. To get VM configuration, we've got that commandlet. To get info for our network, get AZ virtual network. To create a new NIC, new AZ network interface. And then down here we're using get AZ network interface and add AZ network interface. So if you want to go through the script yourself in PowerShell and create a VNIC and create a network interface. That'd be a good exercise. It won't be something you have to walk through in a simulator on the exam, but it doesn't hurt to know some of these different commandlets and go through it on your own just to familiarize yourself with the process. All right, I hope this demonstration was informative for you. See you in the next sub-lesson.
PowerShell Desired State Configuration, DSC, is a PowerShell management platform that lets you manage your IT and development infrastructure with what we call configuration as code. DSC is a declarative platform for configuration, deployment, and management of systems. DSC consists of three primary components: the configurations, the resources you're configuring, and the LCM, the Local Configuration Manager. Let's check it out. Well, as you can see, I'm pretty far through the process of spinning up a virtual machine or creating a virtual machine. I've already gone here through the basics. I've gone through the disks, the networking, the management, and I'm in the advanced area of bringing up this Windows Server 2016 instance. Now, Azure virtual machines have a collection of built-in extensions. Notice it says down here, extensions provide post-deployment configuration and automation. A little information box will pop up, and you can choose an extension to install. Now, if I click on this, which I will in a second, depending upon what the basic platform is, that's going to determine my list of extensions. So if it's an Ubuntu image, I'll have a different list of extensions than I will with Microsoft. There's some that carry over between the two, but Microsoft definitely unique. Now, these extensions can enable configuration management. They can allow you to do things like install software agents, set up remote debugging for live troubleshooting, and typically the extensions that are chosen are going to be the Windows PowerShell DSC, which I talked about in the introduction, desired state configuration. And there's also a more generic custom script extension. Both of these, if I go ahead and click on select an extension to install, if I scroll down, you can see here's Microsoft's custom script extension, and then below that, the PowerShell desired state configuration. These are the two to be aware of on the exam. I'll also mention the Network Watcher Agent for Windows. That one's important, okay, to use with our Network Watcher tool that we saw in previous sub-lessons. A lot of these, again, are, other types of third-party vendors, right? Different companies, like Rapid7 Insight Agent. So the PowerShell DSC extension will let you define the state of a VM using the configuration language and then apply it and perform continuous updates when it's integrated with the Azure Automation DSC service. But again, right here we're talking about the PowerShell desired state configuration. But I can use the language to declaratively configure the state of the virtual machine. I can use built-in resource providers or custom providers with the DSC script. And what's really awesome about this is instead of having to write logic to find and modify or correct the state of the machine, the actual providers will do that work for me and change the system state as defined in the script. For example, you could have a DSC script that declares that the web server role should be installed on this Windows 16 data center server along with the web ASP Net45 feature. And there's also an open source DSC resource kit that you can go to GitHub and you can get that. It's a GitHub repo. Either one of these will let you use the DSC configuration management language to accomplish this. Go ahead and click on Create down here. Now it asks me to choose a configuration module or a script, and I don't have one. Okay, so here's what I'd have to do. Before you can apply the DSC script to the virtual machine, you have to use a commandlet in PowerShell, and it's publish-az vmd sc configuration.
So that commandlet will package your script, whatever you're trying to do with the configuration language, into a zip file. This commandlet will also import any dependencies, okay? Any dependent DSC modules. It's going to include that into the zip file as well. So I have that zip file. I basically click on this little folder here on my local machine, and I would go and I would add that configuration module or script. I'm modifying the state of the configuration when I instantiate this Windows server. And of course, I need to have a qualified name of the configuration. I may have arguments for particular functions that I'm using. This next area, configuration data PSD1 file, one of the really excellent features of the DSC is the ability to parameterize this configuration. So I could generate a single configuration that has different behaviors based on the parameters that I pass to it. And I could do that in this PSD1 file. That's a little bit advanced. Next, I could choose, the latest version or an earlier version. I can enable or disable data collection. That's collecting data in the extension. And then, of course, I can have my own versioning, which, I have to do this. So I have to go ahead and put in a version number. And do I want to auto upgrade minor versions? I can say yes or no. And then when I'm done, click on OK. And it's going to install this extension to my Windows server. So I'm going to back out of there. So I'm not going to go all the way through this. I also have the custom script extension that I can use in the Azure portal. This can be done here in the portal. I can also do it from PowerShell, and you can just go, and when you click on create here, it's going to ask you for a script file, so whatever .ps1, and then some additional arguments or variables, for example, like a password or something like that you might want to have for the administrator. Not as elaborate as DSC, but still an available option.
In this demonstration, you'll learn how to change the size of VMs and move VMs from one resource group to another. Various management methods will be explored in this demonstration as well.
Okay, as you can see, I'm in the Create a Virtual Machine area, or Blade if you want to call it that. Let's go down to the image here, and let's remind ourselves of the VM sizes. Okay, so I'm going to go and choose a Windows Server 2016 data center. Very common, kind of just put in a name here. And let's go down and look at the size. Go to change size. For the real world and for the exam, we do want to understand these different families. Remember, general purpose is basically a balanced ratio of CPU to memory. It's good for testing and for development, small to medium-sized databases, and web servers that have low to medium traffic. I'm going to clear all the filters here so we can scroll down. Here we see memory optimized, basically offering a high memory to CPU ratio, excellent for relational database servers, medium to large caching, and in-memory analytics. Compute optimized, high CPU to memory ratio, good for medium-sized traffic web servers, network appliances, batch processing, and application servers. I filtered out for storage optimized, and we can see that these are going to offer high disk throughput and I/O. These are excellent for big data, SQL, NoSQL databases, data warehousing, large transactional databases. Some examples of using storage optimized, you can see that's unavailable here with this Windows Server 16. But with other builds, they could support Cassandra, MongoDB, Cloudera, and one of my favorites, Redis. Go back here to family. There's also GPU and high performance compute. The GPU optimized or specialized virtual machines that give you a single or multiple NVIDIA GPUs. These are for compute intensive, graphics intensive, and visualization workloads. High performance compute is specialized for handling batch processing, molecular modeling, fluid dynamics, built on high performance specialized processor technology. For example, the Intel Haswell E5-2667 V3 processor. So let's make sure we understand these 6 different VM sizes or families on the exam. Also keep in mind if the size isn't available, it's either not available in the region or it's not available on that current hardware cluster. So there is a place you can go and get a resource on this. Let me show you. I went to azure.microsoft.com/regions/services to find products available by region. Okay, so if you come down here and you browse virtual machines, I'm going to get this table down here. So I can see that certain ones like A8 through A11, compute intensive, are only available in the East US, North Central US, and South Central US, West US. If I scroll down to the bottom here, not available in West US too. So this is an excellent resource to make sure that those different virtual machines are available in certain regions. Okay, so that's a good resource for you. Okay, I've gone over to one of my virtual machines, DevVM2, and on the settings menu, I've gone to size, and you can see that if I want to go in and let's say change to this A11 high performance with 16 virtual CPUs, 112 gigabytes of RAM, 64 data disks for $11.60 a month. If I was, willing to do that, I needed it, I could choose that option and click on resize. It's going to remind us that prices presented are estimates and to go look at the Azure pricing calculator, which is a tool we've already looked at previously in this course. Now, if I want to use PowerShell to resize, I'm going to use several commandlets. First, I'm going to get the available sizes with the get-azvm size commandlet. Then I'll change the VM to the new size with the update-azvm commandlet. And if the VM is part of an availability set, I could use this code to shut them all down at the same time and then restart them using the new size. So I need to give the resource group name, the VM name, the size, and the availability set. What if I wanted to move DevVM2 from the test group to another resource group? Let's go up here to Overview, and where it says Resource Group, I would just click on Change. By the way, it's stopped or deallocated. It also says below Related Resources to move. This is optional. I'm not going to select all because it's going to choose some things to move that I don't really want to move. But you might want to check on this list to see if there's some other things here, like the DevVM274 network interface, for example, DevVM2 network security group, the DevVM2 IP address. I think that's about it. Then you're going to say, I want to move these resources to, and you could choose another resource group. Click on the drop down. For example, myberg99 or myrg1st or the network watcher resource group, or I could click on create a new group on this link and on the fly create a new group. Click on the I understand that tools and scripts associated with moved resources will not work until I update them to use new resource IDs. And then when I'm done, I click on OK. Now, what if I want to do this using PowerShell? First, I would use the get-az-resource commandlet to identify the resource ID value. Then, I would specify the destination resource group and resource ID to move using the move-az resource commandlet. By the way, I could also move to a different subscription. I would still use the move-az resource commandlet, but I have to designate the destination subscription ID. Realize that not all resources are going to be fully supported when you move between resource groups and subscriptions. There's some caveats, there's some landmines regarding VMs. So here's a link to a document at docs.microsoft.com that you might want to get as a resource for the real world. In the next sublesson, we'll look at redeploying VMs. If you have problems troubleshooting RDP connections, and you will, or application-based access to Windows-based VMs, then redeploying the VM may help. And this involves shutting down the VM, moving it to a new node within the infrastructure, and then powering it back on. That's exactly what we're going to do in this demonstration. This will be a pretty short demonstration. Realize that to help out with some troubleshooting issues, for example with secure shell connectivity to my Ubuntu VMs, or maybe my RDP connectivity to my Win Server 19-1, or it could be application access, sometimes the solution is to redeploy the VM. When you do this, it basically moves the virtual machine to a new node within Azure and then turns it back on. Here's how you do it. I'm going to go choose my VM. We'll do WinServe 19-1. And if I scroll down to the bottom, I'm going to see under Support and Troubleshooting, or Support plus Troubleshooting, the Redeploy option. And it basically just says, hey, having trouble connecting to your virtual machine, this might help out. So you just go to the bottom and click on the Redeploy button. It's going to say it failed to redeploy because it's not allowed on a VM that's either deallocated or stopped. Well, that's good to know. Remember that for the exam. Let's go back to virtual machine and we'll start it. Executing. It's going to take a while to do this. So here's an idea. Let's go ahead and redeploy this VM using PowerShell. All right, that took a few minutes, but we can see that WinServe 19-1 is now status of running. I'm going to exit out of here, and we'll go to the PowerShell and redeploy from there. I'm going to connect -AZ account. It's going to ask me to log in, which I'll do in the background, if you don't mind. So let's go ahead and set -AZ VM, then redeploy. Put in the resource group name, which is test group. Then the name of the VM is Win SRV 19-1. There we go. Okay, so there's our operation ID. The status was it succeeded, and you can see that it took about 2 minutes and there was no error. So we've now redeployed my WinServe 19-1 data center server to a new node. Lesson 12, Manage VM Backups. In this lesson, we'll configure a VM backup, we'll manage Azure VM backups, we'll perform a VM restore, and we'll learn about Azure Site Recovery. In Lesson 8, we covered the basics of the Azure Backup Service with topics like Recovery Services Vault, restoring data and backup policies. This lesson, however, will focus on backups as they relate to virtual machines. Well, right now I'm in All Resources, looking at all my resources in Azure in this subscription. And earlier in this training, we talked about using the Mars agent, and we actually learned how to protect files and folders using Azure Backup. But as you know, Azure Backup can also back up one or more VMs. And we can use this to restore an entire virtual machine or individual files from the VM. And there's a couple of ways to approach this. So for example, if I'm in All Resources, I could go to the Vault first. I've got my new backup vault. I've got Shannon Vault 99. So let's go to my new backup vault, which by the way is in another resource group. And I can go up here to the backup area and say, what is your workload running? It's running Azure or Azure Stack, or it's on premises. What do you want to back up? Back up a virtual machine. So click on Backup. Choose a policy or create a new policy. And you can see here, you can go through, and I'm going to look at this in a different area in a second. So this is one way to approach it, right? This policy has a daily backup point, a weekly backup point, a monthly backup point, and a yearly backup point. And I would name it and I would apply it to a virtual machine. That's one way to approach this. Another way to approach it is to actually go to the virtual machine itself, right? So if I were to go to virtual machines and I were to choose, let's say, a Windows virtual machine or an Ubuntu virtual machine, let's just click on the Ubuntu virtual machine, I can scroll down in the menu here, and under Operations, I could go to Backup, and I could back it up here. So I can create a new Recovery Services vault, or I can select an existing vault. So let me go back one level here and kind of talk about the way this works. So if you choose an Azure VM, let's say Dev VM2, backup's going to start a backup job according to the specified backup schedule. Typically there's a default schedule, but you can modify that. Now, during the first backup, a backup extension is installed if the VM's running. So on the Linux VM, it's going to install the VM Snapshot Linux extension. If it's WinServe 19-1, it's going to install the VM Snapshot extension. Notice that WinServe 19-1 is running, so backup is going to coordinate with the VSS, the Volume Shadow Copy Service, to take a app consistent snapshot. By default, backup will take a full VSS backup. If backup cannot take an app consistent snapshot, it'll take a file consistent snapshot of the underlying storage. For the Linux VM, let's say Dev VM2, backup will take a file consistent backup. After backup takes the snapshot, it'll transfer the data to the vault. When the transfer of data is complete, the snapshot's removed and a recovery point is created. Now when you back up Azure VMs, VMs are encrypted at rest with the SSE, Storage Service Encryption. But you can also back up Azure VMs that are already encrypted by using Azure Disk Encryption. Azure Disk Encryption will encrypt both the operating system and data disks for Azure VMs. With SSE, Azure Storage provides encryption at rest by automatically encrypting data before it stores it. Azure Storage will also decrypt the data before retrieving it. So let's go back into WinServe 19 and just make sure we know how to do a backup. Scroll down to Operations, choose Backup. It's going to create a new recovery service vault, or choose an existing one. Choose your resource group. Choose a backup policy, which is by default this daily policy, 3 p.m. UTC. Retain the instant recovery snapshot for 2 days, and retain the backup taken every day at 3 p.m. for 180 days. So I can enable the backup right there. You may want to look into the pricing so you can learn more about pricing, because the charges are based on the number and size of VMs being protected. Okay, I don't want to incur any new charges, so I'm going to go take a look at create or edit a new policy. It's going to be daily policy by default. I can change that. I can change the schedule, the daily schedule. So notice how this backup policy, which is directly on the virtual machine, only has the daily backup schedule, no weekly, monthly, or yearly. But if I went through the other direction to the recovery vault, that default policy had weekly, monthly, and yearly backup points. Then of course at the recovery vault level, I could go in and I would get a dialog box that would allow me to add multiple VMs to that particular recovery services vault backup policy. In the Azure portal, you can use the Recovery Services Vault dashboard to see a variety of things. You can see the most recent backup, which we call the restore point. You can see the backup policy. You can see the total size of all backup snapshots. And you can see the amount of VMs that are enabled for a backup. As you can see, I'm in the Recovery Services Vault called Shannon Vault 99. We actually saw this in the previous sub-lesson. Notice when I look down here under Protected Items, I see Backup Items. As I mentioned in the introduction, I can see my Azure Backup Agent. I've got one. Other areas to be aware of that are part of backup management is SQL and Azure VM, Azure Storage or Azure Files. We saw that in a previous sub-lesson. DPM, which is Data Protection Manager, which actually provides functionality to the Azure Backup Server. That's a standalone service that you install on a Windows server that stores the backed up data in a Microsoft Azure Recovery Vault, and of course, Azure Virtual Machine. If I click on the Azure Backup Agent, I can see my backup item, the protected server, the last backup which was successful, and the last backup time, which for me was 7/21/2019. I also have an activity log. I can change the time span to the last week. While we look at this dashboard, I want to mention a few considerations that might show up on the exam. For example, when you do a VM backup, the backup of the VM disks will be done in parallel. So for example, if a VM has 4 disks, then it'll back up all 4 disks in parallel. By the way, that type of backup is incremental only, so only the changed data. You obviously want to consider the time you need for Azure Backup to identify the changes from the previous backup and perform the backup. So things that can affect the total backup time are adding a new disk to a protected Azure VM. If it's going through an incremental backup and a new disk is added, that's going to increase the backup time. Also, fragmented disks. Backup operations are faster when the disk changes are contiguous. If the changes are spread out and fragmented across a disk, it's going to be a slower backup. Also, disk churn. If protected disks that are undergoing incremental backup have a daily churn of more than 200 gigabytes, backup can take a long time, actually more than 8 hours. And finally, realize that you want to, as part of your optimization process and continual improvement, don't be afraid to modify the default schedule times for best results. And stay on top of the Azure backup pricing. I showed you that link in the previous sub-lesson.
Well, as I said before, your backup strategy is only as successful as your ability to restore the data. The restoration process should be tested and affirmed on a regular basis as part of the business continuity and/or disaster recovery plan.
All right, let's restore a virtual machine. Let's go to Dev VM2, and we'll select that one. Under the VM menu, we're going to scroll down under Operations, and we're going to go to the Backup area. What you're looking for is a restore point, and I can see it directly here under Backup. Now, I could also go to the Recovery Services Vault, Vault 309. So there's a couple of ways to approach this. But here, I can go right to the backup of this virtual machine, and I can see that this is a file system consistent restore point, which tells me that this is a Linux build or a Linux image, and the recovery type is a snapshot. Notice that there's a ellipsis over here, a context menu where I could restore the VM or perform file recovery, or I can go up here to the top and click on Restore VM. If you have a lot of these, which I don't, but you could filter them out, obviously, and make them easier to find, or you could select the one you want and then click on OK. If I go up to All Services and I type in Backup Vault, I can go to Recovery Services Vaults, and notice I have Vault 309 here. Go to Backup Items, Azure Virtual Machine, and so I can recover my Dev VM2 here. I also see a warning of an initial backup pending for WinServe 19-1. There's also Vault 520, Backup Items, and nothing in there. So, 2 ways to approach this. Go to the Recovery Services Vault, go to the vault itself, and do the restoration, or you can go directly to the virtual machine and restore it that way. Now, for the exam, remember, to restore a VM that has encrypted disks, you also have to provide the Azure Backup Service access to the key vault that's holding those keys. So remember that for the exam, but for the real-world application, here's the URL to go and check this out at docs.microsoft.com/azure/backup/backup Azure VMS encryption.
Azure Site Recovery is Microsoft Azure's built-in disaster recovery as a service
They actually call it DRAAS or DRAS. The Azure Site Recovery Service contributes to your business continuity and disaster recovery, or as they call it, BCDR. Site Recovery manages and orchestrates disaster recovery of on-premises machines and Azure VMs, including replication, failover, and recovery. You set up a site recovery by simply replicating a VM to a different Azure region directly from the portal. You can even sequence the order of recovering multi-tier applications running on multiple VMs. Let's take a look at a demonstration. In this demonstration, we're going to set up disaster recovery for an Azure VM. In this example, file sync test VM, an Ubuntu virtual machine, by replicating it to a different Azure region. I'm going to go ahead and select this VM. And under the menu for this VM, I'm going to go over to Operations, and I'm going to choose Disaster Recovery. And it's going to say, welcome. You can replicate your VMs to another Azure region for business continuity and disaster recovery needs, otherwise known as BCDR, according to Azure. You can conduct periodic disaster recovery drills to ensure that you meet the compliance needs of your organization. Notice here I'm going to replicate from the East US region, where I'm at right now, to the West US region. Let's take a look at some advanced settings, although you could just go ahead and start replication. I'm going to accept all the defaults here, but notice that I could do subscription, VM resource group, virtual network, and availability from single instance to availability set. I also have some storage settings. A new cache storage account and 2 replica managed disks will be created. Replication settings, an existing recovery services vault will be used, and a new replication policy will be created, and extension settings, where site recovery extension updates will be enabled for all the replicated items. Also, 1 new automation account will be created. Click on Review and Start Replication. It reminds us if you're choosing general purpose V2 storage accounts, ensure that operations and data transfer prices are understood clearly before you proceed. You can see the source information for managed disks, the replica, and the disk type, premium SSD. And when I'm done, click on Start Replication. I'm actually not going to follow through with the replication because I don't want to incur the extra cost, but simply to verify it, you would just come back in to the operations area and go look at disaster recovery, and you can see the replication health. You'll see that recovery points are being created. You'll also see source and target regions on the map. Module 4 has 6 lessons, and it's all about the virtual networking infrastructure. In Lesson 13, we'll create connectivity between virtual networks. In Lesson 14, we'll implement and manage virtual networking. Lesson 15 covers creating and configuring network security groups, NSGs. Next, in Lesson 16, we'll implement Azure load balancers. Then, in Lesson 17, we'll monitor and troubleshoot virtual networking. In the last lesson of this module, we'll integrate on-premises networks with virtual networking. Lesson 13, create connectivity between virtual networks. We're going to create and configure VNet peering first. Then we'll learn about global VNet peering. We'll create a virtual network gateway, and then we'll verify virtual network connectivity. VNet peering is virtual networking that allows for connecting virtual networks in the same region. For complex networks, you can use IPsec site to site. Configuring a VNet to VNet connection is a really good way to easily connect your VNets. Azure regions. Well, as you can see, I've navigated on the Microsoft Azure menu in the portal down to virtual networks, and you can see I've got 2 VNets. One that I've been using pretty much all along so far, the test group VNet. Then I created another VNet for the myberg99 resource group. The test group VNet is in the East US, and myberg99 VNet is in Central US. The virtual network, or the VNet, is basically a foundational element of your network infrastructure. Every VNet lets you define a network space with one or more IP address ranges. You can then take this space and carve it into subnets. So for example, if I want to go and add a new virtual network, I'm just going to call this sample VNet because I'm actually not going to use it. So notice my address space it's assigning me is the 10.2/16 space. I've already been allocated the 10.0 space and the 10.1 space. Those were given to the other two VNets I have. You choose your subscription, you choose your resource group, you choose a location. Maybe we'll try North Central US this time. You can create subnetworks. Okay, so I can go with the default subnetwork. Notice that it's going to be 10.2.0.0/24. Now remember, they're going to remind us here that this is insider notation, obviously, but it must be contained within the address space of the virtual network, which it is. And the address range of a subnet, which is in use, can't be edited, right? We'll talk about some of these other settings later. For example, I might want to enable some service endpoints, and I'll just go here and just select all of them, but you can see this is going to allow instances, Windows instances, Linux instances, and other marketplace solutions that are inside this subnetwork to have secure endpoint connections to these other services that are running within Microsoft Azure, like Azure Active Directory, Event Hub, Key Vault, Microsoft SQL, Microsoft Storage, and so on. In upcoming lessons, we'll look at service endpoint policies and firewall settings. So I just wanted to kind of just give you that setup. The first thing we're going to do, let me back out of here. What we're going to do in this first sub-lesson is something a little bit advanced, actually, and we might be getting ahead of ourselves, but this is actually the order in which the exam objectives was presented. So I'm kind of going in that order, but we're going to create a VNet peering between the test group VNet and the myberg99 VNet so that resources in these VNets can communicate with each other and perform a wide variety of activities. Now, before you do that, I want to point out to you this document at docs.microsoft.com, basically in the Azure Virtual-Network directory, and it's called Virtual Network Managed Peering. What I want you to realize is that before you dive into this, you need to understand some of the permissions. Okay, so the accounts that you use to work with virtual network peering must be network contributor role. We don't really care about the classic network contributor. We're not going to be using that deployment model. So network contributor. If you have a custom role, then it's just showing you here the actions that that custom role has to have, right? And so some next steps. A virtual network peering is generated between virtual networks created through the same or different deployment models that exist in the same or different subscriptions. Now, my VNets are in a single subscription, and we're going to create a peering through the portal, and we'll also look at some PowerShell commandlets. We're going to use my two VNets for our practical configuration, but first let's make sure we understand, some of the distinctives about VNet peering. Obviously, it allows virtual machines in two different networks, virtual networks, to communicate directly using their private IP addressing. So we have VNet A on the left-hand side in network 10.1/16 with two web servers. And of course, they both have IP addresses within that /16 space. Those just happen to be in the 10.1.1/24 subnetwork. On the right-hand side, we have VNet B on the 10.2/16 network with two SQL servers in there. This is a very common scenario. Front-end servers in one VNet, back-end servers or database servers in another VNet. Remember, the VNets can be in the same Azure region or they could be in separate Azure regions. If we're going to peer between these two VNets and they're in different regions, that would be called global VNet peering, like we see at the top. But regardless, in all situations, the traffic between the peered VNets is going to go over the Microsoft backbone infrastructure in Azure, not on the public internet. Now I'm going to peer between VNets in the same subscription, but you could also peer between VNets in different subscriptions, even if they're under different tenants. If they were under different tenants, that would be called cross-tenant VNet peering. Keep in mind, if you decide to do that, that's not supported in the Azure portal. You would have to configure it with the CLI or PowerShell, or you could use ARM templates. Now, something else to keep in mind is that VNet peering is not transitive, okay? So if VNet A and VNet B have a two-way peering relationship, and by the way, 2 peering connections are required. These are resource manager VNets, okay? So VNet A and VNet B are going to have a peering from A to B and a peering from B to A. Well, let's say that VNet B and VNet C have that same relationship. They have peering. That relationship is not transitive, okay? That doesn't mean that VNet A has a peering with VNet C and vice versa. Keep that in mind. Also, the peered VNets cannot have overlapping IP address spaces. Okay, that's the same thing. For example, if you had 2 branch offices and they were on a VPN and their private addressing overlapped, you'd have to use something like bidirectional NAT, or it's often called twice NAT, to compensate for that. Also, there's a hard limit of 100 peering connections per VNet. But the good news is no VNet gateways are necessary. We don't have to incur the cost, the throughput limitations, the additional latency, and extra incurred complexity that you would have by setting up VNet gateways. Okay, let's go back to the portal. Before we dive in to this peering demonstration, let's identify my Berg 99 is going to be the VNet 1 or VNet A. Let's say it has the front-end web servers. And then test group will be VNet B or VNet 2 with the back-end SQL servers. We want to also go and take a look at this and make sure that we're not in the same address space. Okay, so VNet 1 is in 10.1/16, and I'm positive that test group's in 10.0/16. There we go. So they're not overlapping IP addresses. Also, if, for example, you were going across subscriptions, right? Let's say one of these VNets is in one subscription and one is the other. You might want to go ahead and copy the subscription ID to the clipboard, because it would involve knowing that information to create the peering. It's going to be pretty easy to do this, though. Let's just go to the VNet 1 or VNet A, which is the first one here. My Berg 99 VNet, and under settings on the menu for the VNet, we'll choose peerings, and we'll click on the add plus sign, and we're going to call this peering Berg to test. I'm going to stick with the resource manager model. You could choose the I know my resource ID, and that would be helpful. You know, if you were going cross subscriptions, we don't have to worry about that. Just choose your subscription, pay as you go. They're both in the same one. Find the virtual network. So here's test group VNet right there. I need to name this, so I'll name the peering from test group back to my Berg. Remember, you have to have a two-way peering. So I'm going to call this one peering test to Berg. And then I'm going to leave the other settings at the defaults. We're basically allowing and enabling virtual network access bidirectionally between both these VNets. I'm going to disable the traffic forwarding, and I'm also not going to enable the gateway transit settings. Just click on OK. And it's adding the virtual network peering. You can see in the upper right-hand corner. Okay, it's successful. And now we see our peering Berg to test. We can go take a look at that, and you can look at the details. Here's the name, it's connected, it's succeeded. See the address space, the remote VNet ID, which you could copy to the clipboard if you needed that. And now my front-end web servers can communicate with the back-end SQL servers, and they can do it by bypassing the internet and using the Azure infrastructure. All right, let's go back to virtual networks. What if I wanted to do this using PowerShell? Well, obviously you're going to have to get some information, so you're going to use the get-az virtual network commandlet to get information about both of the VNets. Then to create the peer, you simply use the add -az virtual network peering commandlet. The information you would invoke in that commandlet would be a name of the peering, the virtual network that you're on, and the remote virtual network ID. I'm just going to jump right into this demonstration with no introduction as we talk about global VNet peering. If you look at this diagram, notice that what we have here is a hub VNet here at the bottom. So the hub VNet basically allows transitive peering between VNet A and VNet B because it's serving as a hub. So once these networks are peered, then resources in VNet A and resources at VNet B can then directly connect with each other. Now the latency that might occur between these virtual machines in these peered networks is the same as the latency inside a single virtual network as long as they're in the same region, because it's routed directly through the Microsoft backbone infrastructure, not across the public internet. Notice the little yellow padlocks? So those are network security groups. They can be applied in either virtual network to block access to other virtual networks, or you could, target certain subnets if necessary. So you can either open or close the network security group rules between the virtual networks. The default option is to have full connectivity between VNet A and VNet B. We'll talk more about network security groups in Lesson 15. Notice between VNet A and our hub VNet, or the NVA subnet, we're using UDR. So we can configure user-defined routes that actually point to virtual machines in peered VMs as the next hop IP address. Or you could configure user-defined routes, or UDRs, to virtual network gateways. This is going to enable a feature called service chaining. Service chaining lets you direct traffic from one virtual network to a virtual appliance, like something from Cisco or Palo Alto Networks, or to a virtual network gateway in a peered virtual network. We could also use this design to deploy hub and spoke networks, where our hub here hosts infrastructure components like the NVA down here, the network virtual appliance, or on the right-hand side, we could host a VPN gateway, which is, of course, inside a gateway subnet. When virtual networks are peered, you could also configure the gateway in the peered virtual network as a transit point to some on-premises network. So notice at the bottom right that VNet B is using a remote gateway. It's connecting to the gateway subnet in the VPN gateway, which also goes to some on-premises, maybe at the headquarters or some branch office. In this example, VNet B, which is using a remote gateway, cannot have its own gateway. A virtual network can only have one gateway. So the gateway can either be local, like the one in the hub VNet, or it could be a remote gateway, like the one in VNet B, the peered virtual network. We'll create a virtual network gateway in the next lesson. VNet to VNet connections are similar to site-to-site IPsec VPN to an on-premise location. The difference is the way the local gateway is configured. With the VNet to VNet, you don't see the local network gateway address space. Let's go configure it in the demonstration. Okay, so in this demonstration, we're going to create a virtual network gateway, and we're going to configure VNet to VNet connectivity between VNet GW01 and VNet GW02. Now, when we do this, remember we have to designate if it's going to be used for VPN connections or for express route connections. If it's VPN, it's going to be called a VPN gateway. If it's for express route, it'll be called an express route gateway. Obviously, VPN gateways are used to generate VPN connections, for example, to an on-premise network or some other virtual network. If we create a VPN connection to an on-premises network, this is what we call a site-to-site VPN. We're going to talk about those in a different sublesson. A VPN connection between two VNets, like these, is called a VNet to VNet connection. Now, in the previous sublesson, we saw virtual network peering, which actually is a better solution than this VNet to VNet connection. This scenario has some disadvantages. For example, additional cost and additional complexity. I mean, we saw how easy it was to create that VNet peering in the previous sublesson, right? But these can be useful in situations where maybe VNet peering is not suitable for our scenario. Maybe, for example, we need the additional security of end-to-end encryption. Maybe due to compliance or some governance. Let's say you want to be HIPAA compliant. Now, since a VNet to VNet connection is a type of site-to-site VPN, we have to deploy a VPN gateway in both of these subnets. So the first thing we have to do is to go into each one of these VNets and create what are called gateway subnets. So basically a dedicated subnet just for that gateway. So let's go into VNet GW01 and go to subnets. Here's our default subnet. Let's add a gateway subnet. Let's make this 10.3.1.0/27. No NSGs right now, no route table, no service endpoints. Just click on OK. Let's go back over to VNet GW02, add a gateway subnet. We'll do the same thing, 10.4.1.0/27, and OK. Next, we have to provision a VPN gateway, and we're going to do that for VNet GW01. Go up to Create a Resource up here on the Azure menu, and we'll just type in here Virtual Network, and we should see Virtual Network Gateway. There it is. And we're going to create this. Okay, the first thing I'm going to tell you is that you have to make sure under Region that you choose the correct region where your VNets are. Because if you don't put the right region in there, when it goes down to try to find the virtual networks, for example, my VNet GW01 and 02, you won't be able to find it. So I have to remember that these were in the US Central, and now when I go down, I should be able to find those. Okay, so that's just a little thing to keep in mind. So I'm going to name this VNet 01 Gateway. Make sure to choose the correct region. Like I said, the gateway type is VPN. Remember, for the exam, it's got to be one or the other, VPN or Express Route. We're going to go with the route-based VPN. I'll just stick with this default SKU that's here. For my virtual network, obviously I want to find VNet GW01. And there's that gateway subnet. Remember, you have to create that first or it won't be in there. I'm going to let it create a new public address. And I'll say the public address name is going to be VNet GW01 IP address. And I can click on Review and Create. And good, it passed validation. Now here's the deal. I need to do this also for the other VNet GW02. This takes 45 minutes, okay, at least, to provision this. So obviously, you know how to do one side of the gateway, right? You would just do the other side of the gateway, VNet 02 gateway. But the final step in this is to actually create a VPN connection between the two gateways. And so 2 connections are necessary, one in each direction. So basically you would open up the gateway blade and click on Connections and then click on Add. Let me just show you a screenshot of what that add connection looks like. Okay, so these screenshots are from docs.microsoft.com, but you get the idea, okay? In the Azure portal, go to All Resources, right? And then put in Virtual Network Gateway, and then you will actually see the 2 gateways you created, okay? So for example, I would see VNet 01 Gateway and VNet 02 Gateway. So choose your gateway, go to Connections, and then click on the Add button, and then you would just name the connection. Remember, it's a VNet to VNet connection type. Put in a shared pre-shared key. Okay, that's for the secure VPN connection. And of course, make sure it's associated with the right virtual network gateway. And that's all there is to it. Now, if you're going to use PowerShell to do this, you're going to have to declare a bunch of variables, and you can see those right here. All these different variables that we're setting up here: resource group, location, and this is just for one side, right? VNet 1, gateway 1. You can use an existing resource group, or you can create a new one. You know how to do that. So you'll use commandlets like new AZ virtual network subnet config. You'll use new AZ virtual network. You'll use new AZ public IP address, and then a couple of git commandlets. And of course, the biggie down here, new AZ virtual network gateway. If you want to do this in PowerShell, you can go up here to this link. It'll take you right to the PowerShell code to do this. It'll obviously take the same amount of time to spin up these gateway blades, and obviously it's a lot easier to do in the portal. Don't sweat this on the exam. Knowing new AZ virtual network gateway would be a good commandlet to know, but other than that, don't sweat the PowerShell.
The ability to verify, diagnose, and troubleshoot virtual network connectivity is vital for the Azure Administrator. Verification using the Azure portal, as well as with PowerShell, are valuable skills to have. And that's what we're going to learn in this demonstration.
Let's talk about verifying virtual network connectivity. First off, try to establish an RDP or SSH session between the two peers. Then use PowerShell commandlet get AZ virtual network gateway connection. As you can see here, I'm following this up with the name and my resource group. Look for things like connection status connected. Make sure that there's ingress bytes transferred and egress bytes transferred. Other reasons why your VNet to VNet connection might not work as expected is maybe you have a network security group or an NSG associated to the gateway subnet. You want to avoid doing this. This is a known issue for causing problems with VPNs in Azure. Also, make sure that the peering is enabled. Has it enabled the Allow Virtual Network Connectivity option? Make sure your VNet to VNet connection is established. And finally, if you're using user-defined routes or UDRs, they may be misconfigured, and that will cause traffic to be routed incorrectly.
Lesson 14, implement and manage virtual networking. We're going to configure several things. We're going to look at private and public IP address configuration. We're going to configure network interfaces and subnets. We'll configure network routes and name resolution. There are two types of IP addresses you can have in Azure. Public IP addresses, which are used for communicating with the Internet and Azure public-facing services. Then there's private IP addresses. These are used within the Azure VNet and your on-premises network. Public IP addresses allow Internet resources to communicate inbound to Azure resources. Public IP addresses also enable Azure resources to communicate outbound to the Internet and public-facing Azure services with an IP address assigned to the resource. If a public IP address is not assigned to a resource, the resource can still communicate outbound to the Internet. Public IP addresses are created with an IPv4 or IPv6 address. As we'll see in the demonstration, public can be basic or standard SKUs. With the ARM model, a private IP address is associated to the following types of Azure resources: virtual machine network interfaces, internal load balancers or ILBs, and application gateways, and they can be allocated as dynamic or static.
As you can see, I'm in the virtual machines blade. I'm going to go down to Dev VM2 and select this running machine. And we go to settings, and the first thing we see is networking. That's where we want to go. We see in the networking on the default network interface the two IP addresses, the public IP at 40.117.113.67 and the NIC's private IP address. Let's start with the private IP addresses. These are basically configured as properties in the configuration of the network interface. They're not a separate resource. There's two methods to assign private IP addresses. It can be done dynamically or it can be done statically. The default allocation method is dynamic, and the IP address is automatically allocated from the resource's subnet. And you can see we're in the test group VNet virtual network in the default subnet. When private IP addresses from each subnet are dynamically allocated, you're going to start with the lowest available IP address in the subnet IP range, which is exactly what happened here, because the first 4 IP addresses in each subnet are reserved by Microsoft Azure. So 10.0.0.0.1.2.3, those 4 are reserved. So the first available private IP was given to this network interface. Static private IP addresses are typically used for VMs that act like domain controllers or DNS servers in your VNet. Maybe you have resources that need firewall rules that use IP addresses, or resources that are being used by other applications or resources through an IP address explicitly as opposed to a domain name. Now, even though both IP version 4 and IP version 6 private addresses are supported, IPv6 has several limitations. For example, VMs can't communicate between private IPv6 addresses on a VNet. Let's look at the public IP address here. This was associated with the network interface to give us an internet-facing endpoint, so our virtual machines can receive traffic from the internet. Remember, as opposed to the private IP address, the public IP address is actually its own standalone resource. So if we went to configuration over here, first we see that it's either dynamically or statically assigned. Go to properties. You can see that it has its own resource ID associated to dev VM 274 at this point in time. So I could take this, deassociate it from this VM, and associate it to some other virtual machine. And also, as a standalone resource, this public IP address could be deleted independently. I can create a new one. I can move it from one VM to another very easily. Notice the SKU says basic. Okay, public IP addresses have 2 pricing tiers or SKUs, basic or standard. The main difference is that the standard tier public IP address supports zone redundant deployment. So you can use availability zones to protect your deployments against potential outages or problems caused if there's a data center level failure, like a cooling problem, a power issue, a fire, things like that. Let's just talk about the basic tier because that's what we're going to be using. The basic tier supports both static and dynamic allocation. It's open by default for inbound traffic. Later on in this training, we'll use network security groups, NSGs, to restrict inbound or outbound traffic on our basic SKU public IP address. Again, it's not zone redundant like the standard tier, but it could be assigned to a specific availability zone if you wanted to.
This demonstration is very important for the exam, and it focuses on the task of creating and configuring network interfaces and network subnets. Let's take a look.
Now I could add a network interface directly to a VM by just going to the virtual machine and going to the networking area as we saw in the previous sublesson. However, I could also go up to create a resource and just start typing in network interface. If I want to specify my own network interface settings, I could basically create the network interface with custom settings when I'm spinning up the virtual machine or the Azure CLI. But I can also create a network interface and then add it to an existing virtual machine. Let's click on Create here. I'm going to name this. Obviously, the name has to be unique within the resource group I choose. Choose my virtual network. I'm going to stay with my BURG99 VNet. They're going to assign me a default subnet. I can accept that. I can always change it after it's created. For private IP address assignment, this is what we talked about in the previous sublesson. I can do dynamic or I can do static. If I do static, I can choose my own private IP address. It has to be within the 10.1.0/24 space. We did this earlier in this training. Remember, we created a /27 subnet for the VNet to VNet VPN. So I can do the same thing right here, create another subnet within this subnet. I think I'm just going to go with dynamic. I can apply a network security group here. I can leave it set to none, or I could choose an existing network security group, which I don't have, or I could create a new one on the fly. We're going to talk about network security groups in lesson 15. I can also choose a private IPv6 address. If you do that, you're going to go and give it a name. I'm not going to do IPv6. My subscription is pay-as-you-go. Choose a resource group. I'll choose my BURG99, and a location. I'm going to stick with Central US. Now notice that I'm not able to assign a public IP address to this network interface through the portal. However, the portal will create a public IP address and assign it to a network interface when you create a virtual machine. Let's click on Create. Okay, in the background, I went ahead and spun up a quick new machine, Shannon VM13. It's just a simple Ubuntu image. It's running. It's in the My BURG99 resource group in the Central US. So let me show you how you can attach a network interface to an existing VM. I'll just choose Shannon VM13. And you can see, by the way, I do have a default. I already have a network interface that's attached to this instance. You can see it has a public IP address and a private IP address, right? It's in the default subnet. If I want to go and add or attach a network interface, go to Networking under Settings, and then go Attach a Network Interface. Notice I could create one on the fly right here, and I would see the same thing I just saw previously, right? Or I could go ahead and attach Shan Custom IF, the one I just created. Now I'm not going to click on OK, because if I do, I'm going to get an error, because it's going to ask me to go back to virtual machines and deallocate. So select that one and stop it or deallocate it. Then I can attach that new additional network interface that I might want to use, for example, for private connectivity to some other VNet. I may want to have one or more IP addresses. It just depends upon my use case. All right, let's look at some PowerShell now. The first thing I want to do is use PowerShell to get information about my network interfaces. Now, if I do get-az network interface, I just hit enter. I'm going to get all of them in my subscription. So I'm going to narrow it down. I'm going to say, let's do name, and then I'll say capital SHAN with an asterisk. You can just get a couple of them probably. And so let's see, there's my Shan Custom IF, the one I just created, okay, in the My BURG99 resource group in the Central US. Next, let's look at some PowerShell code to basically create an Azure network interface with a public IP address. Remember, this is something that we could not do in the portal. So the first two commands, we've got a couple of variables, VNet and subnet. Basically, we're getting a virtual network. The name is MyBurg99 VNet in the resource group MyBurg99. In the subnet, we're getting the AZ virtual network subnet config. The name is new subnet, so we're actually creating a new subnet in PowerShell. Remember that for the exam. Get-az virtual network subnet config. Then the virtual network is the information in the VNet variable above that. Let's assume that we've already created a public IP address called PIP1. We'll use the commandlet get-az public IP address. We're going to name it PIP1. It's going to be in the resource group MyBurg99. The next command creates a new IP configuration called ipconfig1. This is the primary IP configuration with the public IP address associated with it. Notice the commandlet new AZ network interface ipconfig. And then finally, we're creating a network interface using this same IP configuration. Again, notice the commandlet new AZ network interface. Azure routes traffic between all subnets within a virtual network by default. You can generate your own routes to override Azure's default routing if necessary. For example, we could use custom routes if you need to route traffic between subnets through a network virtual appliance, an NVA. Okay, in this demonstration, we're going to go through the process of creating a route to a network virtual appliance, an NVA, and you should be able to walk through this process and do this for the exam, especially here in the Azure portal. I'm going to go up to the upper left-hand corner, click on Create a Resource, and I'm just going to go ahead and type in route, and I'll see route table. And I'll get this, create a new route table, and it reminds us of some of the things I mentioned in the introduction. Basically how we route our packets on our virtual network. Remember, route tables are associated to subnets, and each packet that leaves a subnet is going to be handled based on its associated route table. Keep in mind that each route table could be associated to multiple subnets, but a subnet can only be associated to a single route table, and that makes sense. Now, what are the destinations in a route table? Well, an IP address, a virtual network gateway, an NVA or virtual appliance, which we're going to use here in this example, or the internet. And finally, if a matching route cannot be found, the packet's going to be dropped. Let's click on Create. I'm going to call this SHAN Route Table Public. In the pay-as-you-go subscription, I'm going to create a new resource group. I'm going to call it NVA for Network Virtual Appliance -RG. I'm going to locate it in the central US. Let's click on Create. Okay, so it's finished, and I went to the route table, SHAN Route Table Public. Let's say I want to create a route to a network virtual appliance that goes to a private subnet. I'm going to click on Routes under Settings over here, and I'm going to add, and we'll say through NVA. Address we'll say is 10.0.1.0/24. Notice the next top type. By default, it's saying a virtual network gateway, which is a popular option. Okay, I could also choose a virtual network, a VNet. I could say to the internet, but I'm going to say virtual appliance. Remember these options for the exam. Then the next top address will be 10.0.2.4. And of course, it says make sure you have IP forwarding enabled on your virtual appliance. And when you're done, just click on OK, and you've added a route to your new route table. Okay, I'm back at my home page. Let's go over here to Virtual Networks. And I can go to a virtual network, let's say VNet GW01. Click on that and choose a virtual network. And if I want to, I can associate a route table to a subnet. So if I click on subnets here, I can see here's my default subnet. If I choose that, notice where it says route table down here, I can click on the drop down and I could choose my SHAN route table public and associate a route table to existing subnet.
In this lesson, I'll demonstrate configuring Azure DNS, configuring custom DNS settings, and configuring private and public DNS zones. I also want to remind you that with this training, there is a practice exam, and it's critical that you take that practice exam and get a high score on it before you take the actual exam. All right, let's go to the demonstration.
First of all, DNS can be quite a complex conversation, not something that's for the faint of heart if you're new to networking. So I'm going to give you a document that I want you to use as a resource to kind of build a foundation. But realize that once you get to this document, it's going to state the obvious, that you can communicate by using IP addresses, but it's much easier to use some type of friendly name, some type of DNS name, a name that's not going to change even when the IP address changes, right? And it really depends on various scenarios. And we're going to look at a table here that's going to lay some of those out for us. But it basically reminds us that when your resources are deployed in VNets, and they have to resolve domain names to internal IP addresses, there's two ways to do it. The most popular way is to use Azure Provided Name Resolution, or you can do name resolution that uses your own DNS server. So if we come down here, we see different scenarios. And this is the table I want you to study for the exam, because it tells you, look, if you have name resolution between VMs located in the same VNet, or Azure Cloud Services role instances in the same cloud service,
that we're going to use a relatively new solution called Azure DNS Private Zones or Azure Provided Name Resolution. If you need name resolution between VMs in different VNets or role instances of different cloud services, then they're going to point you to the Azure DNS Private Zones, or you could do your own customer managed DNS servers. And actually, all of these other solutions down here are going to involve customer managed DNS servers, which are beyond the scope of this particular training. And notice that the suffix is, for the most part, going to be fully qualified domain name or FQDN only, except for this first scenario where it's name resolution between VMs in the same VNet, where you can use an actual host name or the fully qualified domain name. Now for this exam, we want to focus on Azure Provided Name Resolution, and notice the features it provides. It's easy to use, there's no configuration required, you get high availability based on the Azure infrastructure. You can use this service together with your own DNS servers to resolve both on-premise and Azure host names. You can use name resolution between VMs and role instances in the same cloud service without having to use a fully qualified domain name. You can just use the host name. You can also use name resolution between VMs and virtual networks that use the Azure Resource Manager Deployment Model, or ARM, without having to use an FQDN. And you can use host names that best describe your deployments as opposed to working with auto-generated names. What are some of the considerations though? The Azure created DNS suffix cannot be modified. You can't manually register your own records. Also, there's no support for Wins and NetBIOS. Host names must be DNS compatible, and the DNS query traffic is throttled for each VM. And notice, by the way, the last bullet point, the Azure DNS IP address is 168.63.129.16. This is a static IP address, and it will not change. Okay, so let's say you want to configure Azure DNS to resolve host names for your own public domain. So let's say I purchased Trainology.com, and I registered it with register.com. Well, I could configure Azure DNS to host that domain and resolve www.trainology.com to the IP address of my web server or my web application. So I click on Create a Resource in the upper left-hand corner. I'm just going to type in there just DNS, and I should see DNS zone. And I would click on Create. I'll use the pay-as-I-go subscription. I'll create a new resource group, call it DNS Zone RG, and the name of the instance is www.trainology.com, and the resource group's going to be in the central US. Notice I could create some tags to tag this with some metadata, or I could download a template to automate this process, but click on Review and Create, and you can see the details. When you're ready to create your zone, just click on the Create button. I can now go to the resource. Let's say I want to create a DNS record. I'll click on Record Set. And let's say the name of this record is going to be Azure. Okay, so this is an A record for Azure in this domain, Trainology.com. The A record is the most common. Quad A is going to be for IP version 6. A canonical name or a CNAME is an alias. The MX would be the mail server, okay, like an Exchange server in this domain, another name server in this domain, another server in this domain. Okay, so I'm just going to go ahead and stick with the A record. The time to live, basically, this is the amount of time the DNS will stay cached at the client. So it designates how long the DNS server and client cache a response. So the default is 1 hour, but I could make it, longer, make it 4 hours. Now, the IP address, by the way, this would have to be a public IP address. So when I create my instance, let's say it's my web server, for example, I'm obviously going to get a public IP address. Whatever that is for that web application or that web server, that's the IP address I would put in here. When you're done, just click on OK.
Lesson 15. Create and configure a network security group, NSG. We're going to create security rules. We're going to associate an NSG to a subnet and to an interface. We'll identify required ports, and we'll evaluate effective security rules. In this lesson, we're going to create security rules. You can filter network traffic to and from resources in a virtual network with an NSG, a network security group. An NSG contains security rules that allow or deny inbound or outbound network traffic to or from various types of resources. Let's look at some of the components of a network security group. First, you have the name. That's a unique name within the network security group. The priority, a number between 100 and 4096. The rules are processed in a priority order with lower numbers processed before higher numbers, because lower numbers actually have a higher priority. Once traffic matches a rule, the processing stops. As a result, any rules that exist with lower priorities or a higher number that have the same attributes as rules with higher priorities are not processed. Also, the source and destination address, which can be any address or an individual IP address expressed in CIDR blocks like 10.0.0.0/24, for example, or it can be a service tag or an application security group. Then the protocol, TCP, UDP, or any, which includes ICMP. Realize you cannot specify ICMP alone, so if you require ICMP, use any. Then there's direction, inbound or outbound. We also call that ingress or egress. Then the port range. You can specify an individual TCP or UDP port or a range of ports. And then the action, allow or deny. All right, let's go configure the NSGs in this demonstration. The first thing I want to do is go to my virtual machines and find a VM and look at the default NSG, the default network security group. I'm going to go to Dev VM2. I'm going to go to the settings and go to networking. And you can see here that I've got my effective security rules. Let's choose that option. The associated NSG was Dev VM2 NSG, so on the network interface. And we can see kind of the default rules here. Let me scroll over a little bit so we can see everything. All right, let's look first at the inbound rules. We have allow VNet inbound. So of the 3 inbound rules, it has the lowest priority number. If I were to create my own inbound rules, obviously I'm going to use numbers lower than that, so they'll be processed first. So we're allowing all the source ports, 0s through 65,535. The destination is the virtual network itself. All destination ports on all protocols allow. Then we have our allow Azure load balancing rule, which is the next one. And it's basically allowing all ports, all source ports, all destination ports to any address. Notice the allow VNet inbound has a destination of the virtual network or 2 prefixes. Then there's an implicit or implied deny all at the end. It has a high priority number of 65,500. So basically any source, any port, any destination, any port, deny all. So if it doesn't match the allow VNet inbound or doesn't match the allow Azure load balancer inbound, then the packet will be denied. Notice the outbound rules. We have allow VNet outbound, basically sourced from 2 prefixes representing the virtual network on any source port to any destination port on any protocol. We also have what's called allow internet outbound from any source, any port to the 216 prefixes that represent the internet on any port, any protocol, and then allow is the access or the permission. And of course we have another implicit or implied deny all outbound. So obviously for the exam, you want to be aware of the default inbound rules and outbound rules that's going to be applied. But how do you create a network security group? Well, let's go to create a resource up here. And we could just start typing in network, and we'll see network security group, which is basically an access control list. Okay, it's a virtual firewall for controlling traffic in and out of virtual machines based on the network interface, but you could also apply a network security group to the entire subnet. Keep that in mind. That's different from other providers like, let's say, AWS, Amazon Web Services. With Amazon Web Services, you have a network access control, NACL, that applies to the entire subnet, and then you have security groups which apply to the network interfaces or the instance virtual Ethernet interfaces. It's different in Azure. You create the network security group, and then you determine to apply it to a virtual machine on its network interface or apply it to a subnet. We've already seen in the existing default the 5 tuples they're talking about here. Okay, the 5 tuple is protocol, source IP address range, source port range, destination IP address range, and destination port range. So this is basically a layer 3-4 access control list. The NSG can be associated to multiple network interfaces and multiple subnets, but remember, each network interface or subnet can be associated to only one network security group. The second paragraph basically just reestablishes everything we just talked about when we looked at the default security group that's applied to that VM network interface. We're going to deploy our NSG in ARM as opposed to Classic, so we're going to click on Create. I'm going to call this Test NSG. I'm going to put it in the test group and click on Create. Now, when the network security group was finished being initiated or created, a little pop-up box came up and I could have just gone to the resource directly, but I've gone to all resources and I've basically filtered out for type network security group, and I can see some existing security groups that are here already. But let's go to Test NSG. So here's our default rules. If I go to Inbound Security Rules, under Settings, I can say source any, or I could have the source be an IP address, or you could even have the source a service tag or an application security group. Maybe I only want to allow from a certain corporate network. Maybe I only want to allow from the 209.200.66.0/24 network. I can put my source ports. This is an asterisk saying any. But if I only want to allow, let's say, port 80, port 22, port 443, I can say destination any. I can say destination port or port range. I can say any protocol, or I can designate TCP or UDP or ICMP. And then, of course, an action. And then the priority number. Notice that by default, it's going to get a priority of 100, which means it's going to be processed first. Remember, the lower numbers are processed first in the network security group. And since it's a number of 100, which is lower than 65,000, it'll be processed first. And so if there's a match, okay, if it's from 209.200.66/24 on one of those ports destined for anywhere on port 8080, and it's TCP or any traffic, we're going to allow that. Then it'll be allowed into whatever, okay? Now remember, I haven't applied this security rule yet. And I would typically go in here and I can stick with the default port 8080. And I would, of course, want to describe it. And again, if it matches none of the other entries, 65,000, 65,001, or 65,500 will even be processed, okay? So once there's a match, that's where the processing ends. So I can just click on Add and create the security rule. It'll be called port _ 8080, which is the default. That's fine for this example. That's the inbound security rule. And of course, I can also come over here and create an outbound security rule. And again, I can just click on Add and add an outbound security rule. In the next sublesson, we'll actually look at applying this test NSG to a virtual machine and to a subnet.
In this demonstration, we'll complete the configuration from the previous lesson.
we will compare the application of NSGs to individual network interfaces versus entire subnets. This demonstration is really part 2 to the previous demonstration, and when I configured my network security group test NSG, I was hoping to get a reaction out of you. For any of you out there who have worked with, let's say, network ACLs at AWS, or you've worked with router access control list, hopefully you noticed that I did something unconventional. And I did that on purpose. Notice that on the first entry in our inbound security rule, there's an exclamation point by port 8080. What are they telling us? And if we scroll down and look at this again, it's going to say the recommended value for source port is actually asterisk or any. And so on an inbound security rule, typically what we would do is we would make the source port asterisk, and then the destination port ranges would be the services that are running, for example, in the subnet that you attach this to, or on the virtual machine that you attach this to. So this might be things like 8888, if you're using different proxy numbers, port 80, port 443, for HTTPS, maybe 22 for secure shell, SMTP, port 25. So we're going to talk more about this in the next sub-lesson. But I hopefully got your attention when I configured this originally. Let's go ahead and save this. Update the security rule. Now once you create the NSG, you can then go to network interfaces and associate this to the network interface. I've got a couple here. Notice that there are network interfaces in my subscription and only ones that are located in the central US. So all I really have available to me here is this SHAN custom interface. And you can see we've successfully saved the network security group for this custom interface. Now I could also apply test NSG to a subnet. So click on associate, and you can choose a virtual network. And within that virtual network, you can then choose a subnet, for example, like default. If you don't like it, just X out of here, okay, and try a different association, okay. Now remember, you can associate a network security group with an entire subnet, more than one subnet, with a VM, or more than one VM. However, I cannot associate a subnet or a VM to more than one network security group. Okay, keep that in mind for the exam. While we're here, let's go ahead and take a look at some important commandlets to know for the exam that you would run in PowerShell that relates to network security groups. Okay, so if you want to work with network security groups in PowerShell or the Azure CLI, let's start with PowerShell. To create a network security group, you use the PowerShell commandlet new-az network security group. The Azure CLI would be az network nsg create. If you want to view all your network security groups in PowerShell, it's get-az network security group, and the Azure CLI would be az network nsg list. In the CLI, you could also use az network nsg show to see some details. If you want to change a network security group, in PowerShell, you would use set-az network security group. In Azure CLI, you would use az network nsg update. To delete a network security group in PowerShell, you would use remove-az network security group, and in Azure CLI, you would use az network nsg delete. All right, in the next sub-lesson, we'll talk more about ports. In this demonstration, we want to dive deeper into the strategy behind choosing the appropriate ports. We're going to explore some common scenarios in the Azure cloud. In this demonstration, we're going to talk about just allowing the necessary or required ports, and it really comes down to what we call reducing the attack surface or reducing the blast surface of your subnet or your VM. Let's go back to the test NSG here, and let's kind of look at this. And of course, we talked about in the previous sub-lesson the inbound security rules in the ports and outbound security rules in the ports. Let's go back to inbound security rules here and click on Add. Now, even though we talked about the source port ranges could be any, it's actually better to reduce the attack surface of ephemeral ports. So for example, if you're creating an inbound security rule that you're going to apply to a subnet, you want to think about the instances that are in that subnet. As we know, clients are going to initiate requests choosing something from an ephemeral port range. So that port range is 1024 through 65,535. And that's valid. However, many Linux kernels use ports 32,768 through 61,000. So if it's Linux clients that you're dealing with, you could reduce the range to that. Let's talk more about destination port ranges. You have to be careful with port 25 because that can actually be an SMTP relay. Microsoft recommends that you utilize authenticated SMTP relay services, and that's typically going to be port 587. You might want to add that one to your list. Also, think about licensing through the key management service. Windows images that are running in VMs have to be licensed, so often a request is made outbound. So I could go to the outbound security rule here, and I could add port 1688 in there for destination. I'm going to go ahead and type it in here. Even though it's the inbound security rule, you get the idea. For an outbound security rule, I might want to have destination port 1688 there for licensing through the key management service. Also realize that inbound, I don't have to allow port 80. Often I'm going to have a load balancer, and I can set up my load balancer to talk on 8080 or 8888. So we don't have to always include port 80 in there for HTTP as well. Allowing port 80 from the internet is almost always a bad idea. Also, don't forget that as a source, we can use service tags. Service tags are basically a group of IP address prefixes that minimize the complexity for creating security rules. You don't create your own service tags. You don't even specify which IP addresses are included in that tag. These are managed by Microsoft, okay? They manage the address prefixes that are encompassed by the service tag, and they automatically update the service tag as addresses change. So let's say I choose, for example, for a source service tag. Notice the source service tag by default is the internet service tag, but there's so many more. And we don't have to go through these, but notice that a lot of these are for Azure services, okay? Azure Load Balancer is a very common service tag to use as the source in your inbound security rule. There's Azure Active Directory, Azure Monitor, Azure Backup. If we go down, we can see some storage service tags, a bunch of SQL service tags, and you can do SQL and you can actually control the region, the specific region. There's also Azure Key Vault service tags, Azure Cosmos DB. This is only if you're using the ARM model, but basically the address prefixes of the Cosmos database service. So again, we can use these to simplify matters based on the services that we're running and know that we don't have to worry about the port numbers, okay? Because they're going to change those port numbers, they're going to change those addresses accordingly within their infrastructure. So keep that in mind for the exam.
In this lesson, we'll take a web safari up to Microsoft to evaluate some best practices and effective security rule examples. We'll also look at creating security rules in the CLI and with PowerShell.
In this short demonstration, I want to point you to this article at docs.microsoft.com, Azure Best Practices for Network Security. As we scroll down, basically using strong network controls, connecting VMs and appliances to other network devices in virtual networks, and possibly using more secure services like ExpressRoute, for example. They want you to logically segment your subnets. Don't assign allow rules with broad ranges, and we just talked about that. segment the larger address spaces into subnets. When you use NSGs for network access control between subnets, you can put resources that belong to the same security zone or role in their own subnets. Adopt a zero trust approach. Perimeter-based networks should be operating on the assumption that all systems in the network can be trusted. However, we've evolved from that traditional defense approach to a zero trust approach. We eliminate the concept of trust based on network location in a perimeter. Zero trust architectures use device and user trust claims to gate access to organizational data and resources. So we give conditional access to resources based on device, identity, assurance, network location, and more. Control your routing behavior using the route tables that we talked about in the previous sublesson. If you can, use virtual network appliances. And you can go to the Azure Marketplace and search for security and network security and find a wide variety of vendors like Fortinet and others that can help provide those solutions. Deploy a perimeter network for your security zones. This is known as a DMZ. Often in that DMZ, we're going to place a jump host or a bastion host, and we actually use that to get secure connectivity to the instances inside of our subnets that we're managing. Again, that goes into this concept: disabling direct RDP and secure shell access to your virtual machines. In other words, disabling direct RDP and secure shell from the internet. Enabling a single user to connect to the VM using point-to-site VPN, or enabling users on your on-premises network, for example in a management VLAN, to connect to your VMs on your Azure VM through a site-to-site VPN, or you can use ExpressRoute. And then finally, secure your critical Azure service resources to only your virtual networks and use virtual network service endpoints to extend your virtual network private address space, as well as the identity of your virtual network to the Azure services over a direct connection. Service endpoints are going to give you improved security, optimal routing, and they're easy to set up with less management overhead. For more information, here's an article called Azure Security Best Practices and Patterns, and you can click on that and you can go get this article and add this to your knowledge base. Azure Firewall is a managed service from Microsoft. It's a cloud-based network security service that offers protection for your Azure VNet resources. It's a stateful firewall service, and it has built-in high availability and limitless scalability in the Azure cloud. Network administrators can create, apply, and log Layer 3 through Layer 7 application network connectivity policies in a centralized manner across all subscriptions and virtual networks. Also, Azure Firewall is fully integrated with Azure Monitor for doing logging and analytics. Take a look at this diagram from docs.microsoft.com. Here you can see the centralized creation and enforcement of security. So for example, on the left-hand side we have two spoke VNets, let's say at regional branch offices. We have our central VNet at Azure Firewall in the middle. Notice it can connect to your on-premises site for on-premises traffic filtering. You can also configure Layer 3 through Layer 7 connectivity policies. This is often referred to as deep packet inspection or advanced visibility and control, or next generation firewall. Azure Firewall also works with Microsoft Threat Intelligence and can indicate known malicious IPs and fully qualified domain names. And by using the Azure Cloud, you can get threat intelligence, network address translation, network and application traffic and filtering rules, allowing inbound and outbound access. The high availability is built in, so you don't need any additional load balancers. This is a relatively new service, so you can go up right now to your Azure account and get a 30-day free trial, and I highly recommend it. You can configure Azure Firewall during deployment to span multiple availability zones to give you higher availability. And your availability SLA is going to be 99.99 or 4 nines of uptime. You get unrestricted cloud scalability based on using Azure Cloud. In other words, you can scale up as much as you need to deal with any changing network traffic flows. You can use application FQDN filtering rules to limit inbound HTTPS or Azure SQL traffic to a designated list of FQDNs, including wildcards. Keep in mind that this feature doesn't need SSL termination. You can create centralized allow or deny network filtering rules based on source and destination IP address, ports, and protocols. Azure Firewall is a fully stateful next-generation firewall. FQDN tags let you permit well-known Azure Service Network traffic through your firewall. For example, Windows Update Service. A service tag is a group of IP address prefixes that allows you to lower the complexity for creating security rules. Microsoft fully manages the address prefixes used by the service tag and automatically updates the service tag when addresses change. You also have threat intelligence-based filtering to allow your firewall to alert and deny traffic to and from known malicious IP addresses and domains. These come from the Microsoft Threat Intelligence feed. You also have outbound support for SNAT and inbound DNAT support. You can associate up to 100 public IP addresses with your firewall, all supporting DNAT and SNAT, and all events are integrated with Azure Monitor logging. And finally, Azure Firewall is compliant with PCI DSS, Service Organization Controls, SOC, ISO, and ICSA Labs. On the exam, simply realize the process that you go through to use Azure Firewall. Obviously, you want to have a resource group and a VNet, and possibly some additional subnets. You'll create virtual machines, for example, Windows Server 2016 Data Center. Then sign up for Azure Firewall, of course. Choose Firewall in the Create a Resource area and create a firewall. There'll be some basic settings like put in your subscription, that resource group, the name of your firewall, the location, choose the virtual network, and add a new public IP address. Then choose Review and Create. When the deployment is finished, you want to create a default route. So you go to Networking and then choose Route Tables, and you'll add a firewall route. For the address prefix, you'll use 0.0.0.0/0 or any, and then for your next hop type, you'll choose Virtual Appliance. Remember, Azure Firewall is actually a managed service, but in this situation, when you're creating a default route, you're going to choose Virtual Appliance. Then you can configure your rules, application rules, for example, to allow certain IP addresses and protocols like HTTP and HTTPS. You can put in target FQDNs, for example, www.microsoft.com. You can create network rules, for example, choosing protocols like UDP, source and destination addresses. And then, of course, test your firewall. Once you sign up for Microsoft Azure Firewall, there are several walkthroughs you can go through to help familiarize yourself with the graphical interface. Take advantage of that 30-day free trial and take a look at Azure Firewall. In this lesson, we're going to look at the Azure Bastion service, which is a fully managed platform as a service offering that delivers secure and seamless secure shell and RDP connectivity to your VMs in the Azure portal over Transport Layer Security, or SSL/TLS. The Bastion service protects your VMs from exposing RDP and secure shell ports to the internet while still offering secure access. Also, your VMs don't need a public IP address when connecting through Azure Bastion. Here's a diagram from docs.microsoft.com. As you can see here, the Bastion host is deployed in the virtual network. The subnet must be called Azure Bastion Subnet. The user connects to the Azure portal using any HTML5 browser, and they select the virtual machine to connect to. And then, with one click, the RDP Secure Shell session will open in the browser. As mentioned, we don't need a public IP address. Some of the features of Azure Bastion are that RDP and Secure Shell are directly connected in the Azure portal, and it's a single-click seamless experience. Using an HTML5-based web client, you get RDP SSH sessions over SSL on port 443. Also, you get firewall traversal, and there's no need for network security groups on the Bastion subnet. You get protection against port scanning and zero-day exploits, and the managed platform as a service keeps your Azure Bastion hardened. Let's go up to the portal and look at how to configure the Bastion. All right, using the Bastion host service is very easy. If you notice here, I've got a virtual machine that I've spun up called Test Bastion VM. You just simply go up here to the Connect button, click on Connect. You're going to see three options: Secure Shell, RDP, and the relatively newer option, Bastion. We'll click on Bastion. It's requesting the Bastion data, and then click on the Use Bastion button. The name defaults to the resource group, so my RG1 VNet Bastion. The subnet name has to be Azure Bastion Subnet. Remember that for the exam. This way Azure knows which subnet to deploy the Bastion resource to. And this subnet is different than the gateway subnets that we saw earlier in this training. And it tells us here to associate a virtual network with a Bastion, it must contain a subnet with the name Azure Bastion Subnet and a prefix of at least /27 or larger. So /27, 26, 25, so on. So then we can create a new IP address. That's the public IP address name. So when we click on create, we could choose something, let's say like 10.1.254.0/27, and then we'll have our Bastion, and then we just click on connect. Now at that point, you'll enter the username and password that you have set up for your virtual machine. Lesson 16, Implement Azure Load Balancer. In this lesson, we're going to configure internal load balancers, we'll configure public load balancers, and, of course, learn how to troubleshoot load balancing. Public load balancers process incoming traffic to your VMs. Internal load balancers will allow several things. They allow you to load balance traffic across VMs inside a virtual network. You can reach a load balanced front end from your hybrid on-premise cloud. You can port traffic to a designated port on specific VMs with inbound NAT rules. You can offer outbound connectivity for VMs inside your virtual network by using a public load balancer. Here's an exam tip. Although Azure Load Balancer supports both basic and standard SKUs, each differing in scenario scale, features, and pricing, new designs should adopt standard load balancer. In this demo, we'll look at internal load balancer configurations. An Azure Internal Load Balancer, or ILB, gives us network load balancing between virtual machines that exist inside a cloud service or a virtual network within a regional scope. In this demonstration, we're going to create an internal load balancer in a virtual network like this. We'll have two virtual machines, one named DB1 and one named DB2. We'll have endpoints for the internal load balancer, and then we'll have the internal load balancer. To deploy our load balancer, we need to create a front-end IP pool. This is the private IP address for all the incoming network traffic. A back-end address pool, the network interfaces that receive the load balanced traffic from the front-end IP address, load balancing rules, which is the port, the source and local port configuration for the load balancer, a probe configuration, which is the health status probes for VMs, and our inbound NAT rules. These are the port rules for direct access to virtual machines. This is a really long process and a lot of commands to type in. What I'm going to do is I'm going to show you the different commandlets that you'll know them for the exam. You won't have to configure this on the exam, but I want to show you this script from docs.microsoft.com. You can try to do this yourself in your own account, but I can tell you it's got bugs in it and it's not going to work properly. So first you would connect to your account with Connect-AZ account. Then you would get your available Azure subscriptions with Get-AZ subscription. You should know those for the exam. Then you're going to choose that subscription, and then after the subscription ID flag or switch, in quotes, you're going to put that GUID. Then you're going to create a new resource group. It's going to be called NRP-RG and choose a location. Next, you're going to create a virtual network and IP address for the front-end IP pool. So you'll use the new AZ virtual network subnet config commandlet, and you'll assign this to a variable called backend subnet. Notice the address prefix is 10.0.2.0/24. Then you'll create a virtual network. You'll use the new AZ virtual network. You're going to name it NRP VNet, put it in that resource group, put it in the same location. The address prefix will be 10.0.0.0/16, and then of course the subnet is going to be that backend subnet variable. You'll assign this to the variable VNet. It's created, the subnet will be added to the virtual network, and they're assigned to the VNet variable. Next, you're going to create a front-end IP pool for the incoming traffic and back-end address pool to receive the load balance traffic. We'll use the new AZ load balancer front-end IP config commandlet. We're going to name it LB front-end. We're going to give it a private IP address of 10.0.2.5. Then the subnet ID will use the code vnet variable.subnets open bracket 0 close bracket .id, and we'll assign that to the variable front-end IP. Next, we'll create a back-end address pool to receive incoming traffic from the front-end IP pool. Here we're using the commandlet new-az load balancer back-end address pool config. We're going to name it lb-backend, and we'll assign that to the be address pool variable. For the exam, remember you have to create 4 rule objects, an inbound NAT rule for RDP that redirects all incoming traffic on port 3441 to port 3389, a second inbound NAT rule for RDP that redirects all incoming traffic on port 3442 to port 3389. You're going to create a health probe rule which checks the health status of the health probe.aspx path, and a load balancer rule which load balances all incoming traffic on public port 80 to local port 80 in the backend address pool. We're just going to notice the commandlets here, the new AZ load balancer inbound NAT rule config, the new AZ load balancer probe config, and the new AZ load balancer rule config. By the way, feel free to go up to this site at docs.microsoft.com, log into your account, and copy the code in and try it yourself. Maybe you'll have better luck than I did. Next, we're going to create the load balancer with the new-az load balancer command, and we'll assign that to a variable nrplb. After you create your internal load balancer, we need to define network interfaces. You'll create the first network interface. It's going to be named lbnic1be. So basically, we're using the new AZ network interface commandlet in our resource group. We've got our name lbnic1-be, the location, the private IP address, the subnet, and our load balancer backend address pool, and our load balancer inbound NAT rule, and those are being assigned to the backend nic1 variable. And then down here we're just doing the same thing, and we're naming it lbnic2be. And once you type in the variable backend nic1, you'll be able to see your settings. To assign the NIC to a virtual machine, you'll use the add AZ VM network interface command. Here they give you a link to show you how to do that. After the VM has been created, you add the network interface. We're going to get the AZ load balancer. We're going to get the AZ load balancer backend address pool config. We're going to get the AZ network interface, and then we're going to change the backend configuration on the network interface using this command. And then finally, we'll save the network interface object with the set AZ network interface commandlet. Here they're assigning the load balancer object that we created to a variable called SLB. Then we're going to add a NAT rule to an existing load balancer, and they're using port 81 for the front end pool and port 8181 for the back end pool. Notice front end port 81, back end port 8181, protocol TCP. And again, we're using that SLB variable here. Save the configuration by using the SLB variable and pipe to set AZ load balancer, and you're all done. Like I said, be familiar with the commandlets and the objects that you need to create for an internal load balancer. And if you want to, go up and try this on your own.
This demonstration will step through creating a public standard load balancer with a zone redundant front end using a public IP standard address. A single front end IP address on a standard load balancer is zone redundant by default.
As you saw in the previous sublesson, creating a load balancer with PowerShell is a very long and cumbersome process. The preferred method is to really use Azure Portal. So we're going to do a public load balancer here. Remember that a public load balancer has to be associated with a public IP address resource. If the load balancer is using the standard pricing tier, then the public IP address must also use the standard pricing tier. To use our Azure load balancer, we have to first provision the resource. This includes the front-end IP configuration like we saw in the previous sublesson. After we do that, we can create the back-end pool, the health probes, and then the load balancing rule. So we're going to go up here to create a resource, start typing in networking there. I think I'll just go back and actually do load balancer. There we go. Go right to load balancer. Why mess around? It reminds us that an Azure load balancer is a layer 4 load balancer that distributes incoming traffic among healthy virtual machine instances. That's why we need those probes. They use a hash-based distribution algorithm, uses a 5-tuple hash to map traffic to available servers. They can be internet-facing, where it's accessible through public IP addresses, or internal, where it's only accessible from a virtual network. The PowerShell we saw in the previous sublesson was for an internal load balancer. And we're also aware that load balancers use NAT to route traffic between public and private IP addresses. Let's go ahead and click on Create. I'm going to use the test group resource group. I'm going to call mine shanpub.lb, US Central. Notice the type is public. There are differences between the SKUs, between basic and standard. So standard tier load balancers use standard tier public IP addresses. And by default, these are closed to inbound traffic. If you use a standard tier load balancer, traffic must be whitelisted using an NSG. If you use a basic tier load balancer, which is the default that I'm using here, traffic should be whitelisted using an NSG, but it's going to flow even if an NSG is not used. I'm going to go ahead and stick with the basic SKU. Let me do a public IP address name. We'll dynamically assign it, and we won't add a public IPv6 address. Pass the validation, and we'll click on Create. Okay, my deployment is complete, and I got my deployment details here. There's my load balancer resource and my public IP address resource. The next thing to do is create our backend pool, and the backend pool defines the backend servers over which the load balancer is going to distribute the incoming traffic. If it's a basic tier load balancer like mine is, this backend pool has to be either a single virtual machine, virtual machines in the same availability set, or a VM scale set. Remember the VMSS. Traffic gets distributed to all the virtual machines in a VM scale set. With a basic tier load balancer, I can't distribute traffic to multiple VMs unless they're members of the same availability set or a VMSS. If you have a standard tier load balancer, you don't have these limitations. So let's go over here to load balancers on the Azure menu, and we'll see our load balancer We'll click on our load balancer and we'll go to the settings over here and choose backend pools, and we'll add a backend pool. Notice you can associate it to an availability set, a single virtual machine, or a virtual machine scale set. So let's do single virtual machine. Then assign a network IP configuration and click on OK. Okay, so I only have one virtual machine here, and realistically, I'm going to go ahead and use an availability set that would be in the test group resource group in the central US region, or a VMSS in the test group in the central US region. Next, I'm going to do health probes. So we'll click on health probes under the settings menu. This is basically continual health probing of our backend pool instances to see if they're healthy, to see if they can receive traffic. It'll stop sending traffic flows to any backend instance that is deemed to be unhealthy. Now, the unhealthy instance will keep receiving health probes, so the load balancer can resume the traffic once it gets to a healthy state. And it supports 3 types of health probes. TCP, basically doing a 3-way TCP handshake. HTTP probes, using an HTTP GET with a specified path, or HTTPS probes. These are a lot like HTTP probes, but they use a TLS wrapper instead. I personally can't use an HTTPS probe because they're only supported on a standard tier load balancer, and I'm using the basic tier. So we'll just click on Add. My probe for LB1. Notice that I've got my different protocol options here. I don't have HTTPS available to me. I got to choose my port, my interval in seconds, and then the unhealthy threshold is 2 consecutive failures. Now, what is going to determine if an endpoint, for example, that VM that we've got here, is marked as unhealthy? Okay, if it's an HTTP probe, if the endpoint returns an HTTP status code other than 200 OK, it's unhealthy. If the probe endpoint closes a connection using a TCP reset, that's going to be unhealthy. Or if the probe endpoint fails to respond during the timeout period for, in this example, 2 consecutive failures. So we'll click on OK. The next thing we're going to do is we're going to create our load balancing rules. And these are a lot like an Azure Application Gateway. They're used to connect the front-end IP configuration to the back-end server pool and to our health probe. But where it differs from an app gateway is there's no separate back-end HTTP setting configuration. Any additional HTTP settings are defined in the load balancing rule. So these would be the things like the front-end ports and the back-end ports. Remember, we saw those in the previous sublesson. There's also things like idle timeouts, the protocols, whether it's TCP or UDP or IP version 4 or IP version 6. Basically, the load balancing rule lets us determine how inbound connections are distributed between the back-end instances. So let's go to the load balancing rules and click on Add. For the front-end IP address, I'm just going to choose Load Balancer Front End. I'm going to go ahead and use TCP on port 80. The back-end port is 80. The back-end pool is BE Pool 1. It's just one virtual machine, okay? Like I said, typically this would be an availability set or a VMSS. There's my health probe, and I can set my idle timeout in minutes. Notice this last thing, floating IP direct server return. It's disabled by default, but this is really only recommended when you're load balancing for a SQL server always on availability group listener. Okay, so only for that scenario, SQL server always on availability group listener. Otherwise, go ahead and leave that disabled. We'll click on OK. All right, so that is how we configure a load balancer. You'd want to test this out. So obviously what you want to do is go to the load balancer and you'll see public IP address, and I'm not going to show you this one. So you click on my public IP for LB, and then you would send traffic to that public IP address. You want to make sure that your network security groups are configured to allow incoming traffic and health probe traffic. Remember, this is a basic, so there's no firewall rule in an NSG that's blocking traffic. And so if it's a web server, you should be able to connect to the public IP address and see the web page of the web server.
In this demo, we're going to take a web safari up to the Azure site and explore valuable documentation on basic troubleshooting of internal and public load balancers. Let's go.
Okay, this will be a pretty simple and short video as we look at troubleshooting the Azure load balancer. You're going to want to go to this site at docs.microsoft.com, and it reminds us that there's two types of load balancers, basic and standard. This article is about the basic load balancer. If you want the standard load balancer, click on the link and you can go look for some troubleshooting steps for the standard load balancer. We're going to go back here. Basically, when your load balancer connectivity isn't happening, the most common symptoms are the VMs behind the load balancer are not responding to health probes, or VMs behind the load balancer are not responding to the traffic on the configured port. So, the load balancer backend pool VMs may not be responding to the probes due to the backend pool VM is unhealthy, the backend pool VM is not listening on the probe port, the firewall or an NSG is blocking the port on the load balancer backend pool VMs, or just a total misconfiguration in the load balancer. If the backend pool VM is listed as healthy and responds to the health probes, but it's still not participating in the load balancing process or not responding to data traffic, it may be that the load balancer backend pool VM is not listening on the data port, the network security group is blocking the port on the load balancer backend pool VM, accessing the load balancer from the same VM and NIC, or accessing the internet load balancer front end from the participating load balancer backend pool VM. So they also give you some steps in here for validation and resolution. So you want to add this to your knowledge base and use this as a resource for the exam. Just make sure that you remember those bullet points just in case you get a question on troubleshooting your basic Azure load balancer.
Lesson 17, Monitor and Troubleshoot Virtual Networking. First, we're going to monitor on-premise connectivity. We'll use the Network Watcher tool. Then, we'll troubleshoot external networking, and then troubleshoot virtual networking connectivity. Microsoft Azure offers a number of powerful options for monitoring your networking assets. Azure has solutions and utilities to monitor network connectivity, the health of express route circuits, and analyze network traffic in the cloud. Some of these tools include Network Performance Monitor, NPM, Performance Monitor, Express Route Monitor, Service Connectivity Monitor, Traffic Analytics, and DNS Analytics. Let's explore.
Network Performance Monitor, or NPM, is actually a suite of three broad capabilities: Performance Monitor, Express Route Monitor, and Service Connectivity Monitor. Each of these is focusing on monitoring the health of your network connectivity to your applications, and giving you insight into network performance. It's a cloud-based solution, and it provides a hybrid network monitoring solution that monitors connectivity between cloud deployments and on-premises locations, multiple data centers and branch offices, mission-critical multi-tier applications and microservices, and user locations and web-based applications, HTTP and HTTPS. On the exam, you'll need to be aware of the capabilities of the three aspects of Network Performance Monitor, along with Traffic Analytics and DNS Analytics. Performance Monitor is for monitoring the cloud, hybrid, and on-premises environments. You can monitor network connectivity over remote branch and field offices, retail locations, data centers, and clouds. You can use the monitor to detect issues before it becomes a problem with your end users. Key aspects of Performance Monitor are the ability to monitor loss and latency across various subnets and set alerts, monitor all paths on the network, including redundant paths, troubleshoot transient and point-in-time network issues that are often difficult to replicate, determine the specific segment on the network that's taken the performance hit, and monitor network health without having to use SNMP, which has known security vulnerabilities. NPM for Express Route gives you comprehensive monitoring for Azure Private Peering and Microsoft peering connections using the Express Route solution. You can monitor E2E connectivity and performance between your branch offices and Azure when using Express Route. Express Route gives you auto detection of ER circuits, detection of network topology from on-premises to your cloud applications, capacity planning, bandwidth utilization analysis, monitoring and alerting on both primary and secondary paths. You can monitor connectivity to Azure services such as Office 365, Dynamics 365, and more, and detect degradation of connectivity to your VNets. Service Connectivity Monitor lets you test reachability of applications and detect performance bottlenecks across on-premises, carrier networks, and cloud private data centers. Service Connectivity Monitor will monitor end-to-end network connectivity to applications. It'll correlate application delivery with network performance, detecting precise location of degradation across the path between the user and the application. You can test application reachability from multiple user locations across the globe. You can determine network latency and packet loss for your line of business and SaaS applications. You can determine hotspots on the network that might be causing poor performance, and you can monitor reachability to Office 365 applications using built-in tests for Microsoft Office 365, Dynamics 365, Skype for Business, and other Microsoft services. Traffic Analytics is a cloud-based solution that offers visibility into user and application activity on your cloud networks. NSG flow logs are analyzed to give you insights into traffic flows across your networks between Azure and the Internet, public cloud regions, VNets and subnets. Visibility into applications and protocols on your network without needing packet sniffers or dedicated flow collector appliances. You can find the top talkers, chatty applications, VM conversations in the cloud, and traffic hotspots. Discover the sources and destinations of traffic across VNets, interrelationships between critical business services and applications. It gives you security insights into malicious traffic, ports that are open to the Internet, applications, or VMs attempting Internet access, and capacity utilization. It helps you eliminate issues of over-provisioning or underutilization by monitoring utilization trends of VPN gateways and other services. Finally, there's DNS Analytics. This is built just for DNS administrators, and it collects, analyzes, and correlates DNS logs to offer security, operations, and performance-related insights. It can identify clients that try to resolve malicious domains, identifies stale resource records. It gives visibility into frequently queried domain names and talkative DNS clients, and the request load on DNS servers. And it can monitor dynamic DNS registration failures. Make sure you know the capability of all 6 of these Azure Network Monitoring solutions for the exam.
Azure Network Watcher provides tools to monitor, diagnose, view metrics, and enable and disable logs for resources in an Azure virtual network. Network Watcher will be enabled automatically in your virtual networks region. There's 4 main things we can do with Network Watcher. Monitoring. We can monitor communications between a virtual machine and an endpoint. We can view resources in a virtual network and their relationships. We can diagnose network traffic filtering problems to or from a VM. We can diagnose network routing problems. We can diagnose outbound connections, capture packets to and from a VM. We can also diagnose issues with an Azure Virtual Network Gateway and connections.
We also can gather metrics, a wide variety of key performance indicators, and logs. We can analyze traffic to and from a network security group, and we can view diagnostic logs for network resources. In this demonstration, we'll learn about the Network Watcher. Well, I'm in the Network Watcher, and I got there by going to All Services and just typing in Network Watcher, and here I am. Realize that this is actually a service that's automatically enabled. When you create a virtual network or you update a virtual network in your subscription, then the Network Watcher tool is automatically enabled in your region. Also, there's no impact on the resources you have or any associated charge for the automatic enabling of Network Watcher. Now, realize you can opt out of the Network Watcher automatic enablement feature. If you do this, though, it's a permanent change, and once you opt out, you can't opt in without going and contacting Azure support. Now, if you want to do it, you're going to do it through the PowerShell or the CLI. So if you want to opt out in PowerShell, this is the command: register-az provider feature name, disable Network Watcher auto creation, provider namespace, and then Microsoft.network. Then register-az resource provider provider namespace, and then Microsoft.network. In the Azure CLI, the command is az feature register --name disable Network Watcher auto creation --namespace Microsoft.network, and then az provider register -n Microsoft.network. If I go to my pay-as-you-go subscription, I can see which regions it's enabled in, and I can see that I'm enabled in East US, Central US, and that's it. If I go to the ellipsis over here, I can set as a default subscription. So if I had multiple subscriptions, I could do that for pay-as-you-go, or I could enable Network Watcher in all the regions. I'm not going to do that. So now that I have an instance of Network Watcher, some of the features we have would be first under monitoring, the topology. So if I choose the test group, resource group, and the test group VNet, it'll show me my topology. So you can see I'm in the test group VNet in the default subnet. In the default subnet, I've got 4 virtual NICs: backend NIC 1, file sync test VM 434, dev VM 274, and WinServe 19-1616. And you can see, for example, in dev VM 274, I have my dev VM 2, I have my network security group, and I have my dev VM 2 IP. Obviously not an elaborate topology, but it does map to the things we've been doing so far in this training. Another tool is the packet capture under network diagnostic tools, and I can add a packet capture. This will let me create packet capture sessions to track traffic to and from a virtual machine. We can diagnose anomalies. We can do it reactively. We can do it proactively. We can also gather network statistics, get information on network intrusions, and even debug client-server communications. It's basically a virtual machine extension that's remotely started through Network Watcher. So it requires an extension called Azure Network Watcher Extension, which I need to install on the Windows VM or the Azure VM. But here you would basically create a name for the capture, store the information in a storage account or in a file, determine the maximum bytes per packet, maximum bytes per session, and the time limit, and you can actually go and add a filter, which is optional, and you can filter out IP addresses and ports, and TCP and UDP traffic. Let's take off the filter. For the exam, I want you to remember that if you leave the maximum bytes per packet blank, then all bytes will be captured. Also, if all you need is the IPv4 header, just put 34 in here. The default time limits in seconds, 18,000 seconds is 5 hours. Going back to the Network Watcher, another tool is IP Flow Verify. This is going to check if a packet is allowed or denied to or from a virtual machine. In this case, Shannon VM 13 on the Shannon VM 13735 network interface. Of course, we can do TCP or UDP, inbound or outbound, and then we can put in local and remote IP addresses and port numbers, and then do a check. When we do the check, It'll tell us either access allowed or access denied. Another tool is NextHop. We can use NextHop to diagnose VM routing problems. Traffic from a VM is sent to a destination based on the effective routes that are associated with a network interface. NextHop will get the NextHop type and IP address of a packet from a specific VM and NIC. Knowing this information will help you discover if traffic's being directed to the intended destination or whether it's being sent to nowhere. Improper routing configuration is one of the most common troubleshooting issues in Azure VM. We can also look at the security group view by effective security rules. So you would choose a resource group and a virtual machine. For DevVM2, you can see the scope, the associated NSGs, and then there's our effective rules. Just in case on the exam, if they ask you how to create a network watcher from PowerShell or the CLI, here's the commands. So from PowerShell, it's new AZ network watcher, and then the name, which is going to be by default network watcher underscore and then the region. So network watcher underscore central US. Then the resource group name will be network watcher RG. Those are the defaults. And then the location, central US. In the CLI, it's going to be AZ network watcher configure, then -- resource group, followed by network watcher RG, the name, then -- locations, and then central US is the location, and then -- enabled.
Any IT certification exam of value will have a domain that focuses on troubleshooting. This is one of the most important skills for an administrator. In this lesson, we'll take a web safari up to resources at the Azure website.
In this sub-lesson on troubleshooting external networking, we're going to do a web safari to some valuable resources up at docs.microsoft.com that can help you not only for the exam but also for the real world. Realize that troubleshooting is a very, very valuable skill. It's also kind of a combination of an art and a science, in that the more experience you have, the better you get at troubleshooting. Now, we already saw in the previous sub-lesson how we can use the network performance monitor and the different features to monitor and fix things across both our Azure networks and our on-premises networks. In the next sub-lesson, when we look at troubleshooting virtual network connectivity, we'll also return to some tools that we saw in Network Watcher. But a great resource, if you go to docs.microsoft.com, is right up here. It's in the Azure directory. It's in the VPN-Gateway directory. It's called VPN Gateway Troubleshoot. If you'll notice, it's going to give you 4 key scenarios. Okay, so troubleshooting scenarios. Is it to validate a VPN throughput to a VNet? Is it a VPN and firewall device settings? Are you troubleshooting your point-to-site connection? Or are you troubleshooting a site-to-site connection? And then another excellent resource, it says you can use these steps to validate VNet and VPN connections. When you follow that link, you're going to get to this page, which is a guided walkthrough with step-by-step guidance to configure and validate different VPN and VNet deployments. Now, most of these are going to be well beyond the scope of this exam. Okay, this exam is a basic associate exam, but if you'll notice down here where it says, where you get started, is it a VNet to VNet VPN connection? Is it a point-to-site connection? Those are the only two really to be concerned with on the exam. So if I choose VNet to VNet VPN connection, it's going to open this up and it's going to give me some options to choose the connection type. Is it VNet peering? Are you validating an ARM-to-ARM connection? Or is it a classic VNet to Resource Manager VNet connection? So if it's VNet peering, choose that option, and it gives you some steps, and of course it's in the portal. It also gives you some PowerShell. If we go back to the original article, we went to troubleshoot site-to-site connections. If we click on that, we'll see some troubleshooting steps. So for example, check whether the on-premises VPN device is validated. Verify the shared key. Verify the VPN peer IP addresses. Check user-defined routing or network security groups on the gateway subnet. Remember, UDR is an extra configuration. It's not a default, so anything you do that's not going to be a default that adds more user-defined settings, that's one of the first places to look for troubleshooting. Check the on-premises VPN device external interface address. Realize that can change. If you have a broadband connection at your small to medium-sized business, it's possible that's a dynamic address that's being assigned to your broadband router. Make sure the subnets match exactly. Verify the Azure Gateway Health Probe. Here you can see the URL to open a health probe by going to https:// your virtual network gateway IP :8081/health probe. Click through the certificate warning, and if you get a response, the VPN gateway is healthy. And finally, check whether the on-premises VPN device has the perfect forward secrecy feature enabled. This can cause disconnection problems. If we go back, we can look at VPN and firewall device settings. And they give you a list of common devices and related help. For example, the Cisco Adaptive Security Appliance, or the Cisco ISR router, Integrated Services Router, the Cisco Aggregate Services Router, ASR. They give you other solutions as well: SonicWall, Checkpoint, Juniper, Barracuda F5, Palo Alto Networks, and WatchGuard. Excellent resources. If you choose Validate VPN Throughput to a VNet, it's going to remind you of the components that make up the VPN gateway. These are all areas for troubleshooting. The on-premises VPN device, we just saw a list of those. The public internet could be down, your provider. It could be the Azure VPN gateway, we talked about that, or it could be problems with the Azure VM itself. On the exam, be aware of this tool, iPerf, for validating network throughput, iperf3.exe. It's a third-party product, however, it may show up on the exam.
This lesson is actually Network Troubleshooting Part 2. Our focus will be on solving problems with the virtual networks in the Azure cloud. Let's go take a look.
Well, hopefully at this point, this far along in the training, that you've already got your own Azure account going and that you're actually creating some real-world solutions and real-world scenarios and working through those in your own account based on what I'm teaching you and what I'm showing you. Doing it yourself in your own Azure account, keep your costs down. You can go through, you can create things and then immediately delete them if you want to. But doing it yourself in your own account is going to help you not only pass the exam, but also prepare you for more advanced techniques and more advanced solutions in Microsoft Azure, as well as higher end certifications, of course. Now, what we're going to do here is we're troubleshooting virtual network connectivity. So I'm going to go to All Services, and I'm going to go in here and type in Network Watcher. And there it is. A couple of tools I want to show you here that we didn't look at earlier when we were looking at the Network Watcher that you can use for troubleshooting is first the Connection Monitor. Here you can configure and track connection reachability. You can look at any latency issues you have. You can also monitor topology changes. For example, they may be unauthorized topology changes. And you can go in here and you can see I've already added a test in here. So once you create that, you can click on it and look at details and find out, hey, this particular system, this VM is unreachable between two different systems. So you can see that I've got, problems that probes are failing, 100% probe failure, and I can do a topology view and notice that I've got a connectivity problem between a couple of my VMs. Make that a little bit bigger. My file sync test VM at 10.0.0.6 and my WinServe 19-1 at 10.0.0.5. And they both have a check mark, which means they're both up. They're not stopped or deallocated. So you can always go in here and click on Add and name. I could do Test 2, and I can do my subscription. I can choose my virtual machine, and then choose another destination virtual machine or specify it manually with a URI or a fully qualified domain name or by its IP version 4 address, and then what port are you testing on. And so what happened here was I tried to connect on port 80 and I wasn't able to do that. The main reason is neither one of these are running a web server. So if WinServer 19-1 was running IIS, for example, or was hosting some other web service and file sync test VM, I brought up a browser session, I should be able to connect to that, and I couldn't. You also have some advanced settings here, like you could specify the source port, especially if you're using network address translation. So the connection monitor is an excellent tool to troubleshoot network connectivity. There's also a connection troubleshoot diagnostic tool that you want to be aware of. Here, you're going to go through and you're going to choose your subscription, your resource group. Maybe I'll choose test group. And like I said, hopefully you've got your own resource group, you've got your own instances spun up. Obviously, spinning up just a basic web server, very easy to do. You're not tested on that on this exam because that's really more of an application thing, but bringing up a web server in one of your virtual machines and then accessing it with a web browser from a different machine would be an excellent exercise to go through. And like I said, you don't have to leave it up and running all the time. You can bring it up, do your testing, and then deallocate it. So you basically test your virtual machine, okay, choose one, and then a target virtual machine. In this example, it could be in a different resource group, or it could be in the same resource group, right? It cannot be the same virtual machine. If I tried to choose, for example, a dev VM2, it's going to tell me, the source of the connection and the destination cannot be the same, right? So if I'm going from my dev VM machine to my Windows server, and you can also say, how do I want to probe? Do I want to use TCP probes, which are going to try to do a three-way handshake, or am I going to use ICMP messages? And so obviously with ICMP, there's no port numbers. Okay, I'll just be doing reachability tests with ICMP, but with TCP, you actually have to designate a destination port, okay? So you might want to use port 80 and test with web services. You might want to do a telnet, with 23, a secure shell with 22. And the same thing here under advanced settings, you can put in a source port. And that might come in handy again if you're using some network address translation. And then once you set this up, you just click on check and it's going to run the check for you and help you determine, what the problems are with your connectivity. So those are two more diagnostic tools that we're adding to our toolkit. Remember, in the previous sub-lesson, we looked at topology, we've looked at the network performance monitor, the IP flow verify, the next hop. We looked at effective security rules. We also have a VPN troubleshooting tool here as well. And this is a tool we could have used in the previous sub-lesson when we talked about VPN troubleshooting. So I gave you from docs.microsoft.com quite a few scenarios and solutions, but in the Network Watcher, you've also got a VPN troubleshooting tool, and you just go up here and you click on, first you would choose your resource group and your location. I don't have a VPN set up, and the storage account container, and then you would start troubleshooting. So some excellent tools to be aware of for the exam, and hopefully you'll use these in your own test environment that you're setting up at Microsoft Azure. Lesson 18, integrate on-premises network with a virtual network. We're going to create and configure an Azure VPN gateway. Then we'll create and configure a site-to-site VPN. We'll configure express route and verify on-premises connectivity. Azure VPN Gateway connects your on-premises networks to Azure through site-to-site VPNs. The connectivity is secured using the industry standard IPsec and IKE protocols. Point-to-site VPN lets you connect to your virtual machines on Azure Virtual Networks from anywhere. Let's learn how to configure gateways in the Azure portal. I wanted to begin this demonstration with a diagram To help visualize what's really going on, and what really is going on is we're talking about hybrid cloud, okay? We know there's public cloud where everything's up in the public cloud at the provider, like Azure. We have private clouds, we have on-premise cloud, we have community, but this is a hybrid. And this is what we typically see when we're doing the Azure VPN gateway solutions. In other words, many Azure deployments need connectivity between the on-premises network and the Azure VNet. And so this integrated network is what we call hybrid cloud or hybrid networking. Now, typically, we're going to use a hybrid network for, let's say, intranet applications. So, for example, in your on-premises network, instead of having services in your data center or your server farm or whatever, we're going to go ahead and host those up in our VNet. Okay, so you can see, for example, our web tier might be Microsoft SharePoint. And then the database tier would be the back-end SQL servers, very common in modern enterprises. But it could be many other things as well. We could have developers in the on-premises network use instances that are spun up in our VNet for a wide variety of, production and testing. We could create sandboxes to look at malware and file disposition. I mean, the list goes on and on. It could just simply be an Azure application that needs access to an on-premise resource, like a database. So you could have the databases on-premise, either physical or virtual, but something in the VNet needs to access that back at the headquarters. So with the on-premises network over there, what we're going to have is some type of router, right? Some type of VPN gateway or router or some hardware or software that's going to be one of the endpoints in two different types of connections. So when you create a gateway, you have to designate, is this going to be for VPN connections? Okay, so that would be at the bottom, right? So we have either site to site between those two routers or between our on-premise router, what we call our local customer premises edge equipment, and the VPN gateway that we spin up in our VNet. That could either be site to site, or let's say those hosts on the on-premises network have some type of VPN client software, like a Cisco AnyConnect client or some other type of built-in VPN client software. They could connect in what's called peer-to-site, right? So those could be, administrators, engineers who actually have a peer-to-site VPN. They go through the VPN gateway and then maybe to the management VLAN where they have their jump box or their bastion host. And then from there, they go and they do management on servers in those back-end tiers, the web tiers, the database tier. There may be a middle tier here, like a business tier, a business logic tier. We often see that in larger organizations. So the VPN option would be site-to-site or point-to-site, or the other option is to use ExpressRoute. And technically an ExpressRoute connection is not a VPN, okay? It's an ExpressRoute circuit, and they're called ExpressRoute gateways. Now, early on in this course, we saw how VPN gateways can be used to connect one Azure VNet to another Azure VNet. We've already done that in this course. You've learned how to do that. But we can also create VPN tunnels, like I said, site-to-site, point-to-site, or of course we can use the ExpressRoute circuit. Now remember, VPN gateways can only be implemented with a dedicated gateway subnet within the VNet. Okay, we have to remember that. And by the way, we've already done that, right? We created a gateway subnet in our VNet to VNet connectivity, a special type of subnet that's only used for the virtual network gateways. And so that's what we see here. We have a gateway subnet. We've got a VPN gateway in there. We have an ExpressRoute gateway in there. And actually what's happening under the hood is Azure is providing VMs. Okay, we can't directly access them, but they're managed VMs just for us, and they support the ExpressRoute and the VPN gateway as part of their infrastructure. Now, the minimum size for the gateway subnet is actually the CIDR range of /29, but in the previous demonstration I did for you, we did the Microsoft best practice And we used a /27 address block because that gives us a little bit more for future expansion. Now, something else I want to mention here, and I'll just kind of bring this up on the screen, is Border Gateway Protocol. BGP is the standard used for dynamic routing on the internet. It can be optionally enabled on the VPN gateway down there at the bottom, but your on-premises gateway, let's say your Cisco ISR2 router or your Cisco ASR router, has to support BGP, and by the way, it does. So if you use BGP, it allows the VPN gateway and the on-premises gateway to exchange routing information automatically. And BGP is advantageous for other reasons. It allows for highly available redundant connections and some advanced features where you can do transit routing across more than one network. Now take a look at the VPN gateway at the bottom. It's only one object, but by default, each VPN gateway is actually deployed as two virtual machines in an active standby configuration. Since only one is active, that's why I only have like one router icon there. But by default, there's actually a standby VM. Now you can also configure what's called an active-active configuration, but that's only supported by certain SKUs. And most likely for this exam, you're going to be looking at the basic SKU, and that doesn't support active-active configurations. Okay, but if you did, both of those gateway instances would have their own public IP addresses, and there would be two connections made to the on-premises network's VPN gateway. Or you could have multiple gateways there. All right, well, let's go up to the Azure portal and kind of start this process. I'm going to return to this virtual networks area where we were in the previous demonstration of the VNet to VNet connectivity. I've got VNet Gateway 01. If I click on that, if you remember, we created the gateway subnet by clicking on subnets, and then here's the gateway subnet. And we decided to choose 10.3.1.0/27, which gave us some room for growth, 27 available IP addresses. Next, we'll go to create a resource. And if we start typing in here networking, we should see virtual network gateway. There it is. This should look familiar to you, okay? And so again, this is the panel you have to know for the exam, right? You will not, under any circumstances, have to go through some simulation of actually connecting some other corporate network to your network gateway, but you have to understand the options here, right? So you're going to name your instance, choose your region, for example, central. And it's important to choose a region, by the way, that you have resources in, because when it says filter virtual networks, well, I've got to have a virtual network in that region. When I first came in here, it defaulted to some other region and they're not available, right? Here's my VNet GW01. Okay, so here's the next thing. It's the gateway type. Okay, so is this a VPN gateway, which means it's going to be a site-to-site where I'm connected to some device. And by the way, Azure has a whole list of different devices from Cisco and Palo Alto Networks and Checkpoint and Fortinet, of all these supported devices at the headquarters, okay, the customer edge equipment, different vendors. So if it's VPN, it means it's going to be a site-to-site VPN, or it's going to be a point-to-site VPN. Somebody, let's say a developer or an engineer, will have some type of VPN software, and they're going to connect to this gateway. Now the other option is express route, but we're going to talk about that in an upcoming lesson, 18.3. So I'm going to save that express route discussion for then. For VPN type, we want to go with route-based, not policy-based. The SKU, we have basic. And by the way, if you use the basic SKU, you cannot do the active-active high availability thing. So with the basic SKU, listen carefully because this may be on your exam. With the basic SKU, I get 10 maximum site-to-site VPN connections, and my throughput is 100 megabits per second. If I choose VPN Gateway 1 or VPN Gateway 1AZ, I'm going to get 30 maximum site-to-site VPN connections at 650 megabits per second. If I choose VPN GW2 and VPN GW2AZ, I'm going to get still 30 max VPN connections. As a matter of fact, everything but basic gives me 30 maximum site-to-site VPN connections. But if I go with GW2 and GW2AZ, I'm going to get 1 gigabit per second throughput. If I go with VPN GW3 and GW3AZ, I get 1.25 gigabits per second. Okay, now if I use one of these tiers, right, the GW1, 2, or 3, I could actually resize the gateway. Like if it's not enough after the fact, I want to go from GW1 to GW3 to go from 650 megabit per second to 1.25 gigabits, I can do that. But you cannot resize the basic tier. Okay, so remember on the exam, the basic tier, you cannot resize it. And secondly, you do not have the active standby high availability. Next, you would just basically create a new public IP address. Okay, and by the way, you're giving it a name, remember? I can't do active mode because I'm doing the basic SKU. And configuring BGP autonomous system number, again, will only be used with the other SKUs other than the basic, okay? And you have to be doing route-based VPN. And of course, at the bottom they mention, try to use a validated VPN device with your own virtual network gateway, okay? So you can go to this documentation link, you can follow that, and it'll give you a list of devices that they find adequate. And something like the adaptive security appliance from Cisco, or one of their high-end routers, an ISR G2 or an ASR, and other vendors, that's what you'll go with. So the only difference between the site-to-site is what you configure on your end, okay, and the point-to-site is basically the configuration on, let's say, the laptop or the workstation of that user, you know, behind your home edge router. Neither one of those two things are pertinent for this exam, but this creative virtual network gateway is, and upcoming we'll look at some of the express route distinctives.
We saw the topology for site-to-site VPN in the previous demonstration. This feature is very easy to configure in the Azure portal. We'll also explore the PowerShell configuration for this VPN solution as well.
Okay, in this demonstration, I'm going to configure a site-to-site VPN using Azure PowerShell. And if you want to do this, I'm going to show you the PowerShell commands, but I want to recommend that what you do is, without having to go out and get, you know, a VPN device, and you could find a very inexpensive adaptive security appliance, 5500 or 5510X or some other device. What you could do if you're running Windows 10 like I am is, here's an article up here at pureinfotech.com, okay, how to set up a VPN server on your Windows 10 device. So even if you ran it in a virtual machine, you could get Windows 10 up and you could have one side of the site-to-site VPN be your Windows 10 server. Then I'll show you how to configure in PowerShell the other site on Azure, okay? So basically they're going to tell you find your IP address information, okay, whatever your IP address that's given to your broadband router from your service provider, okay? Set up port forwarding on your router if necessary, and then here's how to set up a VPN server on Windows 10. Go to the control panel, click on the Network and Sharing Center. In the left pane, click on the Change Adapter Settings, and then on Network Connections, open the File menu, pressing the Alt key, and choose the New Incoming Connection option. Then choose the users you want to have VPN access to your computer, and click on the Next button. Make sure you click on Through the Internet, and then click on Next. Then in the Network Software page, choose IP version 4, click on the Properties button, and then choose Allow Callers to Access My Local Area Network. And then of course you can specify the IP addresses, and those of course would be the IP address at your Azure side, and then click on OK. Then you can come in and first you'll create a local gateway. So we might use a variable and say something like local GW, and we're going to use the commandlet new AZ local network gateway. And here's what you want to do. You want to give it a name, okay? So name it whatever you want to name it. You want to do the resource group name. So in my example, I could do test group or BURG99. Next, do the location. So for example, Central US is what I've been using. Next, you would put in the gateway IP address. And so in quotes, you would put in, remember I told you to get the IP address that your service provider has given you to your broadband router or whatever you're using. You put the IP address in there. And then of course, what is your inside network? Okay, that's the gateway address. So you're going to have an inside network that uses some type of private addressing. So that would be address prefix. That would be something like, 10.10.10.0/24, something like that. So that's the creating of the local network gateway. Then we want to get the VPN gateway. So we'll have a variable called gateway, and we'll use the commandlet get-az network gateway. So we'll have a name for that. Okay, maybe something like VPN 01. Okay, again, we'll also need to do the resource group name. So that could be test group for me. That's all we need there. Then we create the actual connection, right? So we'll call this connection. Then again, we would name the connection, whatever we want to name it. We would do that resource group thing again, okay? Test group. We have to do the location, Central US. Then we're going to do virtual network gateway. And we'll go ahead and invoke that variable gateway. Then in our connection, we want to do local network gateway. And then we'll use that variable local GW, right? The first thing we created. Then we want to do the connection type. It's going to be IPsec. And then finally, remember this is IPsec IKE version 1 with pre-shared key. So the final thing we have to do is have a shared key. And we'll just say it's key 1, 2, 3, 4, 5, 6, 7. Okay. Remember, both sides of the VPN tunnel, of the side-to-side VPN, have to use that same shared key. And so those are the steps that we go through. And again, really the key commandlets here are new AZ local network gateway, get AZ virtual network gateway, and new AZ virtual network gateway connection.
Azure Express Route enables the creation of private connections between Azure data centers and infrastructure on your premises or in a co-location environment. ExpressRoute does not use the public internet. ExpressRoute offers better reliability, faster speed, and lower latency, and it can offer substantial cost benefits. It uses ExpressRoute locations through an exchange provider or directly from an existing WAN using MPLS through an ISP.
I'm going to use this diagram to further explain ExpressRoute. ExpressRoute is different than the site-to-site VPN. You're actually working with a third party referred to as an ExpressRoute provider, as opposed to a site-to-site VPN between the Azure gateway and the customer network. Another difference between ExpressRoute connections and site-to-site VPN connections is that site-to-site VPN links only offer connectivity to your Azure VNet. Remember that. ExpressRoute provides connectivity to all Microsoft Cloud services. That goes beyond just Azure VNets, but Azure platform services like Cosmos DB, and Microsoft services outside of Azure like Office 365. Now, for the exam, remember that ExpressRoute circuits can be established 3 ways, and the characteristics of ExpressRoute are the same in each connectivity model. First, if your network already has a presence, At a colo facility with a cloud exchange, your colocation provider can establish a virtual cross-connection with the Microsoft Cloud, a Layer 2 or managed Layer 3 connection. Second, your connectivity provider might be able to offer a point-to-point Ethernet connection from their network to your on-premises network. Again, a Layer 2 or managed Layer 3 connection. The third option is using your existing IPVN wide area network provider, your service provider, who might be able to integrate ExpressRoute into your own WAN if they're a registered ExpressRoute partner of Microsoft. From the partner edge to the Microsoft edge, we have an ExpressRoute circuit. This circuit is identified by a GUID, and the GUID is called a service key or an S key, and this gets shared with your connectivity provider. Every circuit has a fixed bandwidth, and the bandwidth options are 50, 100, 200, or 500 megabits per second, or 1, 2, 5, and 10 gigabits per second. And it could be metered, where all the inbound data traffic is free, but the outbound traffic that's transferred is charged on a predetermined rate, or it could be unlimited, where both inbound and outbound data transfers are free of charge, and the users are charged a single fixed monthly port fee. As we see here, we have a primary link, and we have a secondary link. Each ExpressRoute circuit has two connections from your network edge to two Microsoft Edge routers, and you're going to configure these using Border Gateway Protocol, BGP. Microsoft requires dual BGP connections to each Microsoft Edge router. And you can choose Azure Private Peering, where we see here at the bottom right, where you're getting connectivity over an intranet or an address space in the customer network into your Azure virtual network. This is basically a trusted extension of your core network into Azure. The second peering option is Microsoft Peering at the top right. This provides connectivity over the internet address space into services like Office 365 and the internet-facing endpoints of the Azure Platform as a Service services. Keep in mind that ExpressRoute's only available in certain cities, so make sure you go to docs.microsoft.com and look for a list of ExpressRoute providers and their supported locations. There's also an ExpressRoute Premium add-on where your connectivity could be extended to all Microsoft data centers across the world. If you choose this add-on, it's going to raise the number of routes permitted for the Azure Private Peering from 4,000 routes to 10,000 routes. It also increases the number of virtual networks that you can connect to each ExpressRoute circuit, which is 10 by default, to between 20 and 100 depending upon your circuit bandwidth. Let's go over to the Azure portal and see how we create an ExpressRoute circuit. Okay, let's navigate up on the Microsoft Azure main menu to create a resource. And I'm just going to start typing in here Express, and it should say ExpressRoute, and there it is. And we'll click on the Create button. So we can create a new ExpressRoute circuit, or we can import one from Classic. We're not going to do that. We're going to give it a circuit name. Call mine Shan ER Circuit. Choose our provider. Huge list, okay. Kind of gives you an idea though, in case you're doing this in the real world. You might want to look at this list slowly. I'll go through the whole list and kind of take a look at this AT&T, which we have in our area, very popular, Comcast. And again, this is global, okay, so you're going to see international providers here as well. So I'm going to go through the whole whole list, level 3 communications, also NTT, Packet Fabric, some from the Asia Pacific there. Okay, and realize that a lot of these providers, these carriers, are also going to support, let's say, Amazon Web Services in their Direct Connect service, which is similar to what this ExpressRoute is. I'll choose AT&T. Next, choose your peering location, either Silicon Valley or Washington, D.C. I'm closer to Silicon Valley, so I'll choose that option. Then we choose our bandwidth, and there are the options I gave you in the earlier discussion. I'm going to choose 200 megabit per second. The premium SKU is what I was talking about earlier when I mentioned the ExpressRoute Premium and the advantages there. We're going to stay with the standard. I gave you two billing models. One was metered, talked about that, and one was unlimited. The subscription is going to be pay-as-you-go. Going to choose a resource group and a location. And for me, I'm going to choose US Central US. And then you would click on Create. My deployment succeeded. It was successful. If I scroll down, here's my ExpressRoute circuit. Now, as you can see, it's not provisioned. Okay, up here it says provider status not provisioned, but here's my service key right there, and I'll need to copy that and save it somewhere. I'll have to share that with my ExpressRoute provider, who in this case is going to be AT&T, hypothetically. The next thing to do is to provision either Azure private peering or Microsoft peering, as we saw in the earlier diagram. So you would go over here to peerings, select that, and choose either Azure private peering or Microsoft peering. If I choose Microsoft, I'm going to fill in the BGP information, right? The BGP autonomous system number, subnets, okay, the primary subnet, secondary subnet, both that has a /30 prefix, a VLAN identifier, the advertised public prefixes, and other information. But the circuit's not provisioned, so this is hypothetical. Now, don't forget, I have to create a gateway, which is a virtual network gateway. We know what that is, right? We get a virtual network gateway. So we've been here before, right? Several times creating the virtual network gateway, but this time when we create the gateway, we're going to come down and choose the ExpressRoute option for the gateway type. So once the gateway is created, it can be connected to the ExpressRoute circuit, but of course has to be enabled by AT&T and then have the Azure private peering enabled beforehand. And that's it. When dealing with connectivity issues on Windows Azure site-to-site, it's important to start by scoping the problem properly and making certain that all the fundamental connectivity tests were done before performing deeper troubleshooting. Here are 3 questions you should ask even before you start collecting and analyzing data. If the answers to questions 1 and 2 are no, then the problem is most likely the new VM that you just spun up. So, question 1, is this VM able to ping another VM located on the same subnet? Question 2, are they part of the same virtual network in Azure? If the answer to this third question is no, do I have another VM on the same virtual network able to communicate with on-premises resources? Then the problem might be related to the site-to-site connectivity itself. In this demonstration, we'll look at some good verification and troubleshooting techniques and resources. Here are some other things to use to troubleshoot and verify on-premises connectivity. First, verify the status of every VPN connection, virtual network gateway, ExpressRoute connection, and circuit. Use network resource monitoring and the network watcher tools that we talked about earlier. For ExpressRoute, you might want to attempt to reset a failed circuit. That's going to involve the get AZ ExpressRoute circuit and set ExpressRoute circuit PowerShell commandlets. You can read more about that at docs.microsoft.com/Azure/ExpressRoute/reset-circuit. The simplest way to verify initially is to try an RDP or secure shell connection. A peering connection might not have enabled the Allow Virtual Network Connectivity option. Also, make sure your network security groups are not blocking any traffic. Ensure the successful establishment of VNet to VNet peering. Check any user-defined routing, UDRs, for misconfiguration. Also, if you're using a network virtual appliance, an NVA, that might be misconfigured as well. Use all troubleshooting tools and resources mentioned earlier in this course. The final module, Module 5, is titled Manage Identities. The 4 lessons in this module cover managing Azure Active Directory AD, managing Azure AD objects, implementing and managing hybrid identities, and in the final lesson, implementing multi-factor authentication, MFA. Lesson 19, Manage Azure Active Directory, AD. First, we're going to add custom domains. Then, we're going to configure Azure AD Join. We'll configure self-service password reset and manage multiple directories. Each new Azure AD tenant comes with an initial domain name, domainname.onmicrosoft.com. You can't change or delete the initial domain name, but you can add your organization's name to the list. Adding custom domain names helps you to create usernames that are familiar to your users, such as elaine@contoso.com. Before you can add a custom domain name, you must create your domain name with the domain registrar. For an accredited domain registrar, visit https://www.icann.org/registrarreports/accreditedlist.html. Well, as I just mentioned in the introduction, you need to find an accredited domain registrar to have a custom domain in which to add. So here I am at the website I mentioned at icann.org, and there are a ton of registrars all over the world. So you can come up here and go through this list. All I can do is tell you the ones that I've used successfully, okay? So that's all I'm gonna do. It's not an endorsement, but I've used them and I haven't had any real issues I can think of. So as I scroll down here, there's a lot of dropcatch.com. You can tell somebody's really a spammer there. So I've used GoDaddy.com quite a bit, and I also use register.com right here. Those are the couple I've used. No endorsement, just passing along some information. Also, if you're planning on federating your on-premises Windows Server Active Directory with Azure Active Directory, then you'll have to select the I plan to configure this domain for single sign-on with my local Active Directory checkbox when you run the Azure AD Connect tool, synchronizing your directories. You also have to register the same domain name you chose for federating with your on-premises directory in the Azure AD domain step when you go through the wizard. If you don't have the Azure AD Connect tool, then you can go to microsoft.com/en-us/download. Let's go up here to create a resource up on the upper left-hand corner, and we'll type in here directory, and we'll see Azure Active Directory show up there. You have to create a new tenant. Click on create. So let's say for me, I registered Trainology. Okay, so my company is called Trainology, and this is actually a domain name I did create, but I'm not going to actually register it with Microsoft Azure, if you don't mind. And then, of course, the initial domain name will be trainology.onmicrosoft.com, and I'll be in the United States, and the creation process takes a few minutes. If you do this yourself, you can go ahead and create the tenant, but then if you're not going to use it, okay, then just go ahead and go back and choose Delete Directory under Azure Active Directory. I'll go ahead and click on Create. Okay, so it's been successfully created. You can click here to manage your new directory. Now what I recommend is if you're not going to actually use this in the real world, just go up here and delete the directory, kind of clean it up. Notice the person who creates the tenant is automatically the global administrator for this tenant. You can see that's my role over there. So the global administrator can add additional administrators to this tenant. I can also add a custom domain name to this new Azure AD. And if I want to go back to my default directory
I can just go up here and switch directory and go back to the one I've been using, the default directory. Okay. If I go down to custom domain names though, and this is something also to know for the exam, I might want to add a custom domain name within this new directory. So I can click on Add Custom Domain. If I want to make it trainazure.com, which, by the way, I'm sure somebody else already has that, but I can click on trainazure.com and then add the domain. Realize it's an unverified domain, right? I'm sure I wouldn't be able to get that, but this is just for training purposes. I have to create a TXT record for every custom domain name that I add. Also, it must be something that's a TLD, a top-level domain, like, .com or .net or .info, things like that. Now, after I add this domain name to Azure AD, I have to go back to my domain registrar, which might be, register.com or GoDaddy, and add the Azure AD DNS information from my copied TXT file here. By creating that TXT record, I'm basically doing a verification that I own this domain name. Now, the final thing I would have to do here for the exam is to go down and click on Verify. Now, if I actually had this domain name, trainazure.com registered, and again, I'm adding this custom domain name to the Trainology Active Directory, it would do what's called a domain verification, DV. Now, that is not EV, extended verification. So let's say you went to https://docs.microsoft.com. There would be a green padlock up there in the address bar, right? In front of the URL. That's the extended validation. That's not what you're going to get here, okay? You have to go through a different company to get that. Just keep that in mind. Now, I doubt they'll ask you that on the exam, but just realize that kind of the last step here is to verify. Now, there might be some troubleshooting issues, okay? Maybe Azure can't verify the custom domain name. Well, it's like the old joke from Jim Carrey and Ace Ventura. If I'm not back here in 15 minutes, just wait longer, okay? So wait an hour and then try again. Then make sure the DNS record is correct, right? This information that we put in here. And of course, once you have successfully added this domain, you might want to add some additional global administrators to the Trainology directory. You might want to add some users to your trainazure.com domain. Some of those things you've already learned previously in this training.
Historically, you could have user accounts in Azure AD, but you couldn't have computer accounts and join computers to the domain. Well, this changed in Windows 10 with a feature called Azure AD Join. It's now called Hybrid Azure AD Join. Let's go take a look.
As I mentioned in the introduction, we are going to look at Azure AD Join, which allows us to manage both user and device identities while protecting the data that those identities access. But this is just one of the three things we're going to look at. We're going to look at AD Join first, then we're going to look at Azure AD Identity Protection, which is a feature of the Azure AD Premium, which my account is not Premium 1 or Premium 2. It's a Premium 2 feature, but we're still going to learn about it. And Enterprise State Roaming. But let's begin with Azure Active Directory Join, which gives you the ability to manage identities, enabling single sign-on to devices and to the applications and services that are managed through Azure AD accessed from that device. So managed devices would include both enterprise and BYOD, bring your own device scenarios. So for example, with your phone or your pad. So you can work from any device, even personal devices, and still protect corporate intellectual property, or IP, also helping you to become compliant with your regulations. Bottom line, Azure AD Join lets us control these devices, the applications installed and accessed from these devices, as well as how the applications interact with corporate data. Realize when you associate a device with Azure AD, you have two choices. One choice is to register a device, which would be appropriate for personal devices, and the second option is joining a device.
And joining is useful for, let's say, corporate-owned workstations and laptops. Often when you do registration of devices in Azure AD, you're going to combine it with MDM, Mobile Device Management. For example, Microsoft Intune. So notice here, I'm in the default directory. If I go over here to under the Manage area, I'll see Devices and then Device Settings. Now, these are the settings that I'm going to see for my account. I don't have a Premium 2 account, and by the way, you don't need a Premium 2 account either to pass this exam. So what's missing, I'll fill in the blanks for what you would see if it was Premium 2. How's that sound? Here we can see users may join devices to Azure AD. This lets us choose the users and groups that can join devices to Azure AD. So it says all right now, but I could go to selected and I could put in certain users from Active Directory, or I could say none. All is the default. Another setting you would see in a Premium 2 account is additional local administrators on Azure AD joined devices. If I had AD Premium, I could also decide which users are granted local administrator rights to the device. Keep in mind that global administrators like myself and the device owner will be granted local administrator rights by default. And the default is none, and you can change it to selected. Next, here I see users may register their devices with Azure AD. This is a feature called Workplace Join. So if you have, if you're enrolling with Microsoft Intune or MDM, Mobile Device Management for Office 365, that's going to require device registration. So if you've configured either one of those services, all will be selected, and this would actually be disabled. Next, I see require multi-factor auth or authentication to join devices. The default here is no. Obviously, multi-factor authentication is recommended when you add a device to Azure AD. If I change this to yes, users that are adding devices from the internet first have to include a second method of authentication. This is only applicable to Azure AD Join on Windows 10 and bring your own device registration for Windows 10, iOS, and Android. I also have maximum number of devices per user. That's pretty self-explanatory, but there's other valid settings besides 50. Click on the drop down, you can see it's 5, 10, 20, 50, 100, and unlimited. And finally, if I had a Premium 2 account, I would see another setting here that said users may sync settings and app data across devices. I could choose a subset of my users through the selected option to enable enterprise state roaming. If I had Azure AD Premium, I could choose a subset of users using the selected option and enable the enterprise state roaming feature. Let's talk about that feature next. This is available for Windows 10 devices, and it lets users synchronize user settings and application data through Active Directory. When you enable this, the Azure Rights Management or Azure RMS is used to encrypt the data before it leaves the device, and all data is encrypted in transit and encrypted at rest. The license used for Azure RMS is a limited use license just for encryption and decryption of data, but you could purchase a full Azure RMS license to get access to extra functionality like document protection and bring your own key BYOK support. If I had a premium account, under the manage area up here, under device settings, there'd be another entry that says enterprise state roaming. And I could choose that, and it's basically, like as you see here, under users may join devices to Azure AD, it had the same option for enterprise state roaming. It would be all selected or none. I'm going to go back to the dashboard, and I'm going to go to the marketplace down here and click on that. And I'm just going to type in the search box here, identity, and we'll see Azure AD Identity Protection. What this feature does is it protects you from compromised accounts, identity attacks, and configuration problems. It gives you a consolidated view. So if I scroll down here, it's kind of a sample of the screenshot, basically using machine learning algorithms to detect potential vulnerabilities, to configure automated responses to detected suspicious actions and investigate incidents and take the appropriate action to resolve the incidents. You have to be a global administrator to onboard this service. And once I onboard it into the Azure AD tenant by just clicking on Create, I can then choose users with global administrator and security administrator roles in AD to work with this solution. Now, if I click on Create, it's going to tell me that I need an Azure Premium 2 license to do that. I don't have that license, and nor do you need that license for the exam. So just be aware of what the Azure AD Identity Protection service that you get through the marketplace provides for your enterprise. And you can see these 3 bullet points right here pretty much tell you what this service can do for you.
Self-Service Password Reset, or SSPR, is a simple method for IT administrators to allow users to reset their passwords or unlock their accounts. And that's what we're going to look at here in this demonstration.
The SSPR is another service that you need a premium to use, and you can get a premium trial to use this feature, but I don't really want you to have to do that to prepare for this exam. It's just not necessary. I also don't want you to have to risk any additional cost. So I'm trying to keep this training where you don't have to spend any extra money to pass this exam, and you don't need to. If you want to go ahead and get a premium trial and do that in your account, that's fine, but I'm not going to encourage you or tell you that you have to do that. It's going to tell you right here a little bit more about SSPR, why you would use it, to reduce cost, to improve the user experience. You don't want them calling the help desk or the service desk all the time when they forget their passwords. Lower the volume of the input to the help desk or service desk, and you can enable mobility because they can reset their passwords regardless of where they are. You can enable this feature by going to your Azure AD tenant, as I'm doing here, default directory, and under Manage, I've gone down to Password Reset. Now, if I had a Premium 1 or Premium 2 account, this is what I would see. First, I would tell them how many number of methods are required to reset, 1 or 2 methods. The authentication methods would be email, mobile phone, office phone, and or security questions. And you can see them here, methods available to users. Here we've selected mobile app code, which is a preview feature, and email. So 2 options. And then finally, you'll configure the registration options. In other words, whether registration is required to use SSPR and the number of days for reconfirmation. Obviously, these are all features that deal with security, and that's a huge thing for organizations, especially when they use the cloud. Another option is to implement conditional access policies. I've navigated back to my default directory, and with Azure AD conditional access policies, I can put into place automated access control decision making, allowing access to my cloud applications once a user is authenticated based on certain conditions that are evaluated in real time. If I scroll down under Security, I'll see conditional access. Now, I went ahead and did something that I really was avoiding trying to do, and that is doing the premium upgrade trial. And again, you don't have to do that for this exam. You can just watch this and that'll be fine. Because I've done the free trial, I have the new policy option available to me here, which I can click on. Otherwise, you won't see that. Now, basically, a conditional access policy defines a certain scenario for access. Basically, when this happens, then do this. So the when this happens part is the entry point, or it's what triggers the conditional access policy. It's where the evaluated conditions are defined. The then do this refers to the response of the policy. Realize that conditional access doesn't grant authorization to a cloud application or override any user rights within the application once they access it. That still happens through the user assignments to an application registration in Azure Active Directory. Basically, conditional access lets you define the conditions under which that access should be granted. At the very minimum, what you must do is configure assignments for users and groups. So you come over here and you say include or exclude. So you can obviously exclude certain guests and external users. You can exclude directory roles. You can exclude certain users and groups, or you can include none. You can include all users. And it says, hey, you're including all users here. Don't lock yourself out, because this policy will affect all of your users. They recommend applying a policy to a small set of users. So you can say, select users and groups, and then just come down and select an individual user, and I'm going to select Tom Jones. Once that happens, you have to supply at least one access control, right? The then do this part of it. Let me click on Done at the bottom. If I go up here, select what the policy applies to, cloud apps or user actions. If I stay with cloud apps, I can say all cloud apps, again, warning me, don't lock yourself out, or select apps. And I could choose a particular application. I think I'll say Office 365 SharePoint Online and select that. I'll click on Done, and then the conditions. I could say this is a sign-in risk, 4 different levels. So I could apply a sign-in risk level, right? High, medium, low, or no risk. I could choose platforms. So I could say I'm going to include any device, or Tom can only use SharePoint 365 from his iOS, Windows Phone, or Windows, if I wanted to do that. I could choose locations. I could say he could log in from any location, all trusted locations, or selected locations, and I could choose that option, and I could find a location. I could also say client apps, browser and or mobile apps and desktop clients, and device state. When I'm done, I'm not going to add any conditions there, but now I have my access controls. If I click on Grant, I can block access to Tom on SharePoint 365, or I can grant access, and I can say if he's going to access this, I'm going to require multi-factor authentication. This is a very common option, by the way, and it's one of the ones that when you go through any other type of training or any kind of walkthroughs with Microsoft, this is kind of the one they do. So on the exam, I'd like you to kind of think about, I'm assigning to a specific user or group on a particular application a requirement to require multi-factor authentication, and to remember that one, okay? That's the only one I'm really, you want to focus on here. So I can click on Select. Then there's finally a session one down here, and these controls enable limited experiences within the cloud app. For example, sign-in frequency or persistent browser sessions. When I'm done, just switch over from off to on, and I've enabled the policy.
In Azure AD, each tenant is a fully independent resource. It is a peer that is logically independent from the other tenants that you manage. There's no parent-child relationship between tenants. This independence between tenants includes 3 aspects: resource independence, administrative independence, and synchronization independence. Let's break these down. Resource independence. If you create or delete a resource in one tenant, it has no impact on any resource in any other tenant. If you use one of your domain names with one tenant, it cannot be used with any other tenant. Administrative independence. By default, the user who creates a tenant is added as an external user in that new tenant and assigned the global administrator role in that tenant. If you add or remove an administrator role for a user in one tenant, the change doesn't affect the administrator roles the user has in another tenant. And thirdly, synchronization independence. You can configure each Azure AD tenant independently
to get data synchronized from a single instance of either the Azure AD Connect tool to synchronize data with a single AD forest, or the Azure Active Tenant connector for Forefront Identity Manager to synchronize data with one or more on-premises forest and/or non-Azure AD data sources. Let's go take a look.
Well, that was a pretty long introduction, and so this is going to be a pretty short demonstration because of that. Realize that each Active Directory tenant and each directory, so as you can see here, I've got the default directory and the Trainology directory in this tenant. They're still managed as an independent resource. So there's no parent-child relationship between the default directory and the subsequent Trainology directory, even though users from the default directory could be invited to the Trainology directory through Azure Active Directory business-to-business functionality. Directories can be created and deleted on an ad hoc basis, and my Trainology directory could have independent administrators and independent role assignments. If I decided to delete the Trainology directory, that could have impact on some outside users. For example, they've been given access to applications or resource groups that was shared with them. Well, if that's the case, I have to remove both the users and the association to the resource group before I can delete that Trainology directory. If you want to delete a tenant or a directory, you have to be a global administrator. If I delete the Trainology directory, all the resources or objects within that directory will be deleted as well. So you can see up here is the Delete Directory button. So finally, remember for the exam, if I want to delete this directory, I can't have any existing users or groups except for that single global admin, which is me. Also, I can't have any enterprise application registrations in the Trainology directory. Also, I can't have any multi-factor authentication providers linked to Trainology. And finally, there could be no subscriptions for Azure, Office 365, or any Microsoft SaaS services associated with the directory. I have to remove that relationship before I can delete it.
Lesson 20, Manage Azure AD Objects. First, we're going to create and manage users and groups. Then, we'll manage device settings. We'll perform bulk user updates and manage guest accounts. In this demonstration, you'll learn how to create and manage Azure Active Directory organization users and groups. We'll go beyond the portal to explore several PowerShell and Azure CLI commands as well. You ready? Let's look at the demo.
Okay, let's return to a place we've been in the previous lesson, but also early on in this course. If you remember, we came in and we did create a user, another user named Tom. We actually revisited Tom in the previous lesson when we implemented conditional access policies. So we're going to return to this concept in this lesson and look at groups and users. And for the exam, it's important to remember that there's two types of users in Azure Active Directory. There are cloud-only users, and there are users who are synchronized from an on-premises directory. So when you create a user, it'll depend upon where that user is sourced from. Cloud-only users are generated and controlled completely in Azure AD, while the synchronized identities are generated and controlled in whatever source system they're in. So if you update an attribute for a user named Mary, who was created in an on-premises AD and synchronized to Azure AD, then that attribute will have to be updated on premises and then synchronized to Azure AD through Azure AD Connect. Now, if it's a cloud-only user, and if we click on Users real quick, under Manage, we'll see our old friend Tom Jones. Tom Jones, who's a cloud-only user, well, his attributes need to be updated directly here in Azure AD. Now, we created Tom Jones through the Azure portal, but we can also create users, of course, in PowerShell and the Azure CLI.
I was able to create Tom Jones because I'm a global administrator. However, if Tom Jones had user administrator rights in the directory, he could also create new users. Obviously, to create a new user, I would go up to the plus new user button, but let's go over here next to that and see new guest user. This is all about Azure Active Directory business to business, or B2B. So a partner can use their own identity management solution, their own identities and credentials. They don't have to be in Azure Active Directory. You don't have to manage external accounts or passwords, and you don't have to sync accounts or manage account lifecycles. You basically just go over here and put in their email address and invite the users. Guest users will sign in to our apps and services with their own identities from work, from their university, from their social media site. If the guest user doesn't have a Microsoft account or an Azure AD account, then one will be created for them when they redeem the invitation. So basically I'm inviting some user, let's say Abdul at whatever.net, which by the way, I just made that up. And then basically they'll follow a few simple redemption steps to sign in, okay? So I wanted to talk about the new guest user. Let's go up to new user here, remind ourselves of what we did before. So I'll create a user called Mary Green, or if she was in French, it would be Mary Grand. Our naming convention is the first initial of the first name, the last initial of the first name, and then the last name, and then at, and then that whole domain there. Then of course we create her profile. Her first name's Mary, last name's Green, her work title, her department. And I'm going to stop here because we've done this already. We did this with Tom Jones at the very beginning of this training. We're talking about users, but we're also talking about groups. So let's approach this from a more practical standpoint, whereas you'd be creating your groups first, and then when you add your users, when you get down here, you would just simply add them to the available groups. For example, the dev group. But let's go back and look at groups for a second. So I'm going to back out of here. In addition, we also want to look at using other ways to create groups and users besides just the Azure portal. It's very possible on the exam you'll have to know some of the PowerShell commandlets and CLI commands to do this. So let's go up here to the default directory again. Remember, we have our groups. Now I already have a group called dev, so to add a new group, notice it could be a security group, which is what we're doing here, or I can create groups for Office 365. So I want to have a dev group, I want to have a prod for production, so production group. So for membership type, we have three different options. Assigned lets you choose one or more users and add them to the group, basically performing it manually. Dynamic user is a value that lets you use dynamic group rules to automatically add and remove members, and then dynamic device allows you to use dynamic group rules to automatically add and remove devices. So for both the dynamic user and the dynamic device groups, any rules you associate with the group will be evaluated on an ongoing basis. So if a user or device is an attribute that matches a rule, that user or device will be added to the group. If some attribute changes and the user or device is no longer matching the criteria for group membership, then that entity will be taken out of that group. Keep in mind that you can generate a dynamic group for users or devices, but you can't have both at the same time. Also, you can't use user attributes in a device-based rule. That makes sense. So we're going to go ahead and stick with assigned. The owner of the group will be moi. We don't have any members yet, so we'll go ahead and create that. So I've got a production group, I've got a dev group. Let's add one more group, and we'll call this group test. All right, so we've got three groups we created here in the Azure portal. So now it's much more practical. As we add users, we've already got our groups set up, and we can simply place the users in those groups. And since they're security groups, we can obviously apply policies to those groups, and the users placed in those groups will inherit those policies. Just in case they ask you how to create a new user in PowerShell for the exam, I'm going to show you real quick how to do it. The first thing we have to do is specify this new user's password profile. So we're going to create a variable here called password profile, and we're going to use the new object commandlet. So let me put that in bold. The new object, and so it's a password profile. Then we're going to pass the actual initial password to the password profile. Then we'll create the new user with the new Azure AD user commandlet. We're going to go ahead and enable the account at the outset. The display name is Addie Lane, and then of course that's the password that's going to get passed to her. And then user principal name, we'll use the convention that I use: first initial of the first name, last initial of the first name, followed by the last name. So there's AE Lane, and then of course my domain. So here's the CLI to do this: AZ add user create. Then of course you have the display name, you have the password, and then you would supply the user principal name, and there's the example of the user principal name. Other commands we could do as well with the CLI. We could do AZ AD user delete, and you would follow that up with the object ID or principal name of the user for which to get information. All right, in the next sublesson, we'll look at managing device settings.
With device identity management in Azure AD, you can ensure that enterprise users are accessing resources from devices that meet the security and compliance standards of your organization. The Azure AD portal offers a central place to manage these device identities.
Well, to go a little bit deeper into device identity, I want you to notice here that this is actually a screenshot from Microsoft.com because it has a bunch of devices. I don't have all of these different endpoint devices in my testing environment. But as you can see, this is an area we've been to already. We just came here earlier, and this is the devices area and then all devices. We're actually managing our Azure AD. This is, of course, the Microsoft Contoso, and they've come in to manage, and they're in the all devices area. We also realized that we had a Premium 2 account, we'd have enterprise state roaming. We've already talked about that. But we're looking at all devices, and I want you to understand that there's really 3 options for getting a device into Azure Active Directory. And we can see we've got all 3 here. So if we look at the column that says join type, notice if you go down, let's say the third one down, the Android phone, that is an Azure AD registered type. So devices that are Azure AD registered are usually owned by a person, okay, or they're a mobile device, and they're signed into with a personal Microsoft account or maybe another local account. That would be things like Windows 10 systems, iPhone, iOS, the Androids, and Mac OS. Another type we see in the 4th row is the Azure AD joined. These are devices that are Azure AD joined and owned by an organization, and they're signed into with an Azure AD account belonging to that organization. So these only exist in the cloud. And this is going to be a Windows 10 operating system. The third type is the hybrid Azure AD joined. The first 2 fall into that join type, Server 1 and Server 2. These are devices that are hybrid Azure AD joined, owned by the organization, and they're signed into with an Azure AD account belonging to that organization. So they're hybrid, so they exist in the cloud and they exist on premises. So they're on-premises servers that have been joined to the cloud. This would be Windows 7 workstations, Windows 8.1 or Windows 10, or here we can see Windows servers. So basically Windows Server 2008 or newer. The first one, Server 1, is the Server 2016, and Server 2 is 2019. So you can see how important it is because of all the different types of devices, especially with the bring your own device phenomenon. And this identity of these different devices is kind of the foundation for providing the device-based conditional access. And I showed you that as one of the options in the earlier lessons. Now remember that devices in Azure AD can also be managed using MDM tools like Microsoft Intune. There's also System Center Configuration Manager. There's Group Policy, which is hybrid Azure AD join. There's Mobile Application Management, MAM tools, and there's third-party solutions. Now when it comes to device security, we have two categories. We have Azure AD registered devices, basically using an account managed by the end user, and this account's either a Microsoft account or another locally managed credential secured with a password, a PIN, a pattern, or Windows Hello. The other option besides Azure AD registered devices is the Azure AD joined or hybrid Azure AD joined devices. These are secured with a password or the Windows Hello for Business service. So we see all the devices, and the place, of course, to go manage devices is right below that with device settings. Okay, I'm back up in my account now in the devices device settings area. And remember, since earlier I have gone to the premium account, so I do have enterprise state roaming now. If I click on that, there's really just one setting here, right? Users may sync settings and app data across devices, right? All selected or none. If you choose selected, you would just go and you would choose a member, okay? So let's go back to devices and device settings. Okay, so we've got first, users may join devices to Azure AD, right? Selecting the users who can register their devices as Azure AD joined devices. So we choose selected and choose a member. We also have additional local administrators on Azure AD joined devices. So choosing the users who are granted local administrator rights on a device. Users that you add here are going to be added to the device administrator's role in Azure AD. Remember, global administrators in Azure AD like myself and device owners have local administrator rights by default. Next, we have users may register their devices with Azure AD. This is to allow Windows 10 Personal or iOS, Android, and Mac OS devices to be registered with Azure AD. If you choose none, devices are not allowed to register with Azure AD. If you want to enroll with Microsoft Intune or mobile device management for Office 365, you have to be able to register. Next, we have require multi-factor auth to join devices. We obviously know what that is already. The default is no. However, remember on the exam, Microsoft really recommends that you require multi-factor authentication when you register a device. Of course, you have to make sure that multi-factor authentication is configured for the users that register those devices. We've already talked about that. Then we have the maximum number of devices. Usually, people are going to choose 20. Okay, that's a very common option, but as you saw there, it was 50. And at the bottom, we have, again, the enterprise state roaming. We've already talked about that option. So I can save my settings or I can discard my settings. In the next sublesson, we're going to perform bulk user updates.
In this demonstration, I'll show you some PowerShell commands for performing different bulk user updates.
Now realize that on the exam, this is not something that you'll have to demonstrate your ability to configure, but you need to know about the processes, kind of the capabilities of performing bulk user updates. Realize the Azure portal isn't well suited for performing bulk updates or doing batch jobs. For example, making changes or creating new Active Directory groups, Active Directory users. On the exam, you need to know that PowerShell is the tool of choice for making bulk creation, updating of user or group properties, and removing of groups and users in batch jobs. And there are several modules and versions available that you'll have to download before you begin this process from PowerShell. You can get Azure AD v1, which is the MSOL commandlets, or more likely, you're going to get Azure AD v2, which is the Azure AD commandlets. These are also called Azure Active Directory PowerShell module version for Graph. Here's how you would get them. First, run the commandlet install-module Azure AD. Then, run the commandlet to import the module import-module Azure AD. Next, you'll want to store a username password credential and then define a password profile that you'll actually invoke in your PowerShell script. Now, I've already done that before previously in this course, but you can always go search docs.microsoft.com to remind yourself of the process to do that. So when you create a new user, for example, you'll use the new Azure AD user commandlet. And of course, you're going to have properties of that user. For example, the display name of the user's principal name. Is the account going to be enabled? If it is, you'll follow that up with $true. The department of the user, that's common property. Of course, the password profile, that'll be followed up by $password profile that you created in the third step. Now, the last thing I want you to remember for the exam is that you could go in and you could run the PowerShell script like this. However, what's most commonly done is to create these users and their properties in a CSV file. Okay, so for example, going into Excel and having all of your records representing each user, and then the columns would be the different properties: display name, user principal name, mail name, given name, surname, usage location, department, all those things in the Excel spreadsheet. Save it as a CSV file, and then basically you'll import that in with your PowerShell script.
You can use the Azure portal to invite business-to-business or B2B collaboration users. You can invite guest users to the directory, to a group, or to an application. The invited user's account is added to Azure AD with a user type of guest. Let's go check it out.
All right, let's go to the Azure menu over here and go to Azure Active Directory. And let's go up here to Users. And we're revisiting something I already talked about earlier, and that is the guest user. So if you have any of the limited administrator directory roles, and of course I'm the global administrator, so I have that ability as well, then you can use the portal and invite B2B, business-to-business collaboration users, and we do that by going up and clicking on Add New User. Now we can invite them to the directory, we could invite them to a group, or we could invite them to an application. Once you invite a user, using any of these methods, the invited user's account will be added to Azure Active Directory, and the type of user will be guest. Now, the guest user still has to go through the process to redeem their invitation before they can get access to resources. Now, after you add the guest user, you can send them a direct link to a shared app, like Azure Blob, or they could click the redemption URL in the invitation email. By the way, you can also send invitation emails when you're using PowerShell, and the commandlet would be new-Azure ADMS invitation. Now, when you send an email, if the guest doesn't have an AD account, then a Microsoft account, an MSA, or an email account in a federated organization, they're going to get prompted to create an MSA. Now, if you've enabled the one-time passcode feature, then they won't have to create the Microsoft account, the MSA, and then they'll go through a process. Now, an alternative to the invitation email is just to give them a direct link to your app or to your portal. Before they can do this, you have to add the guest user to your directory, like I'm showing you here, or add them in PowerShell. Now, as far as the customizable ways to deploy applications to users, that's really beyond the scope of this exam, because this is an admin exam, not a developer's exam. Realize, however, that when the guest signs in to access resources in that partner organization for the first time, they're going to go through several pages. For example, they'll see this. They'll have to look over the review permissions page that describes the inviting organization's privacy statement. The user must accept the use of their information in accordance to the organization's privacy policies in order to continue. If they've configured terms of use, then the guest will open and review the terms of use and then choose Select.
Then the guest is redirected to the Apps Access panel, which will list the applications they can access. Lesson 21. Implement and manage hybrid identities. We're going to install and configure Azure AD Connect. We're going to use AD Connect to configure federation. Then we'll manage password sync and password write back. Microsoft's identity solutions create a common user identity for authentication and authorization to all resources, regardless of location. This is called hybrid identity. You can use password hash synchronization, PHS. You can use pass-through authentication, PTA, or you can use federation, ADFS. Let's take a look at a diagram to explain hybrid identities. As I mentioned in the introduction, Azure AD Connect is the primary tool to integrate on-premises directories with Azure AD. Again, we define this as hybrid identity in the Microsoft Cloud. Something I didn't mention is that we typically just call this tool AAD Connect. And by using AAD Connect, we can use our on-premises identities with Azure AD and have a singular common identity for access to all of our resources, whether they're in the cloud or whether they're on premises. As you can see here, from identity stores, from LDAP directories like Open LDAP, and from Active Directory, we can have a singular synchronization plus sign-on through Azure AD Connect. We can still have other normal or common sign-on scenarios, but with Azure AD Connect, we have a single sign-on and access to custom applications, to SaaS apps like Box and Dropbox, Workday, Salesforce, and others, to Azure AD, of course, and Office 365. Now, before you install AAD Connect, there's a few things you have to do and certain requirements. So first of all, you want to make sure that the username suffix for your on-premises users has been added and verified as a custom domain in Azure AD. Now, earlier we've looked at how to add a custom domain. So for example, if your users log on to their devices with a username that ends in, let's say, contoso.com, which we know of course is Microsoft, you'll have to have contoso.com added as a custom domain in Azure AD, just like I added trainology.com earlier in this training. This way your users can synchronize from on-premises and keep the same username. Otherwise, they'll be created in Azure AD in that onmicrosoft.com namespace, which you probably don't want. The next thing you have to do is to verify how many objects you intend to synchronize to Azure AD. So when you verify your first domain, for example, trainology.com, that limit will be increased from 50,000 objects to 300,000 objects. Keep this in mind though. If you have to have more than 500,000 objects, then you need a license that goes beyond the free tier of Azure AD. Something else to be aware of that may come up on the exam is a tool called IDFix. IDFix is a Microsoft tool that lets you identify errors in your on-premises directory and helps you solve those problems. It can detect errors in some situations and automatically fix them. So, for example, if you have illegal characters like leading and trailing spaces in a mail address, or maybe illegal characters in user principal names, it'll find that out for you. So it's highly recommended that you use IDFix to prepare to fix errors before you connect to Azure Active Directory. Finally, there's some requirements for installing AAD Connect. It has to be installed on Windows Server Standard or higher, and it requires a server with a graphical user interface, so you can't use Windows Server Core. It can be installed in a domain controller. However, it's not recommended and you don't have to do that. Basically, AAD Connect must be installed on a domain member. You'll want to download Azure AD Connect. Again, I'm in Windows 10, so it's going to tell me that it's only supported on Windows Server operating systems. And you know what? I could spin up a Windows Server
into VMware Workstation, but it's not necessary. It's kind of overkill. Obviously, you know how to install a application, right? So knowing about this tool is going to be sufficient for the exam. Keep in mind, though, that I have to be a local administrator to install AAD Connect on Windows Server. I also have to have the global administrator credentials in the Azure AD tenant. And I have those things, so that'll allow me to create a synchronization relationship. To find a full and current list of prerequisites for Azure AD Connect, just go to this URL at docs.microsoft.com/Azure/Active Directory/hybrid/how to connect install prerequisites. As you can see here, I've gone to create a resource and typed in Azure AD Connect, and I can see Azure AD Connect Server 2016. So I can come in here and get a free trial. I can click on Create, and again, simply add your Active Directory details and begin syncing to Azure AD. Choose between Express or custom settings. So basically telling us that Azure AD Connect integrates our on-premises directory with Azure Active Directory, a common identity for your Office 365, Azure, and SaaS applications integrated with Azure AD. One last thing I want to talk about, when you go through the Express settings setup, when you click on the MSI file like I showed you on your Windows Server, you have to choose how users will sign in to Azure AD. So you want to know these options for the exam. The first radio button says password hash synchronization. This lets users sign in to Azure AD with the same username and password that they use on premises. This is also known as simple or same sign-on model. The next option, which is very popular, pass-through authentication, allows Azure AD to authenticate users using your on-premises identity infrastructure. The third option, federation with ADFS, lets users sign in with ADFS as a federated identity provider. With this option, after users in a federated domain have been resolved through home realm discovery in Azure AD, they'll be redirected to the target identity provider. And then we see federation with ping federate. This lets users sign in with the ping federate service. If you choose this option, after users in federated domains have been resolved through home realm discovery in Azure AD, they'll be redirected to the target identity provider. The final option, which says do not configure, lets you perform federated authentication with a federated identity provider which is not ADFS or ping federate, but it's in the Azure AD identity provider compatibility documentation, which you can find at microsoft.com/download. And then optionally, you can enable single sign-on for domain joined desktops without the use of ADFS. And then after that, you'll provide your global administrator credentials in your target Azure AD. You can connect to your local Active Directory forest and choose one or more domains for synchronization, with a few other options. And then you're going to start the synchronization process when the configuration completes.
Many businesses are fast becoming a mixture of on-premises and cloud applications. Users need access to those applications both on-premises and in the cloud. Managing users both on-premises and in the cloud poses some challenging scenarios. Let's go look at a diagram that shows a basic AD-FS topology.
Okay, for this complex topic, to understand this, I'm going to go to docs.microsoft.com. And we're going to look at an article called How to Connect Fed Azure ADFS. So what we see here is the topology they're going to recommend. Let's kind of look at this and talk about the components and be aware of these components for the exam. So the first thing is, notice our domain controller /ADFS servers. If you have less than 100 users, you can just install ADFS role on your domain controllers. However, you may not want that impact on the domain controllers. Or if you have more than 1,000 users, you're going to deploy ADFS on separate servers. Over to the right in subnet 2, which is our DMZ, we're going to have our web application proxy servers, our WAP servers. This is necessary you need users to be able to reach the ADFS when they're not on the company network. In addition, only TCP port 443 access is allowed between the DMZ and the internal subnet, subnet 1. To ensure high availability on the Active Directory Federation servers and the WAP servers, Microsoft recommends using an internal load balancer for the ADFS servers and the load balancer. To offer redundancy to the ADFS deployment, Microsoft recommends that you group 2 or more virtual machines in an availability set for similar workloads. Obviously, you're familiar with that, and load balancers from previous sub-lessons. It's also recommended that you have at least 2 storage accounts. You don't want a single point of failure. And of course, we can see between the enterprise, which they use contoso.com, we're going to be using ExpressRoute. Well, we mentioned we can either create 2 subnets in a virtual network, or we could create 2 completely different virtual networks, or VNets. For the exam, let's just focus on deploying a single VNet and divide it into 2 subnets, a DMZ and a private subnet. This is a lot easier. So as you can see here in the screenshot, we're creating a virtual network. It's called Contoso Network, and the subnet name is INT for internal. Here we can see we're adding another subnet, and that's going to be the DMZ subnet. Next, you'll create your network security groups. After you finish creating the NSG, there won't be any inbound or outbound rules, but once you install the roles on the servers and they're functional, then the inbound and outbound rules can be made according to your desired level of security. So here's the subnets panel with the internal and the DMZ subnets. Next, you need a connection to on-premises so you can deploy the domain controller in Azure. Remember, our 3 main options to connect our on-premises infrastructure to our Azure infrastructure is point-to-site, virtual network site-to-site, and ExpressRoute. For the exam, Microsoft recommends ExpressRoute. Here, you can see we're creating 2 storage accounts. We want to have high availability. We also don't want to depend on a single storage account. We're going to create availability sets for each role. Remember, the domain controller / ADFS role and the WAP role. We also have to remember how many fault domains we're going to have and how many update domains we're going to have. Remember, virtual machines in the same fault domain have the same power source and physical network switch, so a minimum of 2 fault domains are recommended. The default is 3, so we're just going to leave it at 3. As far as update domains goes, machines belonging to the same update domain are restarted together during an update. So you want to have a minimum of 2. The default is 5, so they're just leaving it at 5. Here we can see the 4 virtual machines that are being deployed. The first 2 are going to have the domain controller / ADFS role and be in the internal subnet. Each one will use a different storage account, and they'll both have static IP addresses. The other 2 have the WAP role. They're in the DMZ subnet. They each use 2 different storage accounts, and they both have static IP addresses. Notice that the first 2 are in the Contoso DC set availability set, and the second 2 are in the Contoso WAP set availability set. Next, you're going to create an internal load balancer, as we see here. You can see it's internal on the INT subnet with a static assignment. Of course, we'll create load balancing rules. Next, we create the public load balancer. The public IP address is going to be named fscontoso.com, and they're creating a new resource group in the West US. And of course, we'll have to have load balancing rules for that as well. Here we can see the security rules for the internal subnet. We're allowing the HTTPS communication from the DMZ inbound, but no access to the internet outbound. Here we're securing the DMZ subnet. We're allowing HTTPS from the internet to the DMZ, that's inbound, and anything except HTTPS to the internet is being blocked outbound. Finally, we'll test the ADFS sign-in, and if we're successful, we'll see this ADFS page. Having a cloud-based password reset utility is optimal, but many enterprises still have an on-premises directory where the users exist. Password writeback is a feature enabled with Azure AD Connect. Let's go take a look. Now, before we dive deeper into password sync and writeback, I want to return to that feature known as password hash synchronization, one of our options for user sign-in that we talked about earlier in this lesson. With PHS, AAD Connect can be used to synchronize user passwords to Azure AD so they can be leveraged for authentication. This is great where you want to allow users to sign into Azure AD with the same credentials they use on premises. But when you use PHS, the passwords that are synchronized to Azure AD aren't sent or stored in clear text. Instead, it's just a hash of the user's password from your on-premise Active Directory. So here we see that choice during the AAD connection installation wizard where you choose the user sign-in option. There's no additional configuration beyond this. It's a one-way synchronization from your on-premise directory to Azure AD. Now there will be a delay when a password is changed on-premise and when that change gets reflected in Azure AD, because a synchronization has to happen for the updated password to be written to the cloud. In situations where PHS is configured, the cloud passwords are set to never expire. So when you combine this with the delay scenario, there are situations where a user will be able to authenticate to a cloud app that uses Azure AD as their identity provider with their old password until the actual synchronization process is complete. Now there is a PowerShell commandlet that you can use to force a synchronization manually, but you won't need to know that for the exam, so I'm not going to add it to that long list of PowerShell commandlets. So that's where password writeback comes in. So we have optional features. This wasn't a panel we saw earlier during the installation of AD Connect. I didn't show it then because I knew I'd be showing it now. So you can see that we've chosen password synchronization and password writeback. Password writeback will let users change their password in the cloud and have that password written back to an on-premises directory, all the while following your enterprise's password policies and security controls. This is a user-friendly option, and it provides immediate feedback to users because it's a synchronous operation. Realize, however, for you to do this, if you're setting up your own environment, for example, testing out federation, you have to have at least an Azure AD Premium P1 license. Keep in mind, when you enable password writeback, administrators also have the ability to change user passwords through the Azure portal as well. Lesson 22, Implement Multi-Factor Authentication, MFA. We're going to configure user accounts for MFA. Then we'll enable MFA by bulk update. And finally, we'll configure various MFA settings. Let's talk about multi-factor authentication, or MFA. The security of two-step verification uses a layered security approach. So even if an attacker manages to get the user's password, it's useless without having possession of the additional authentication method. It requires two or more authentication methods. Something you know, which is typically a password. Something you have, which is a trusted device that is not easily duplicated, like a phone. And something you are, which is biometrics. Now, although I mentioned biometrics in the introduction I just did, the valid authentication methods for Azure multi-factor authentication are these. First, there's password. This is the password of the user in Azure AD. By the way, this is a required factor and it can't be disabled. So you're combining something with the password. You could call to phone. This way, a voice call is made through an automated calling service to the user's registered phone number. The user then answers the call and presses the pound sign for verification. There's also text message to phone. With this factor, an SMS is sent to the user's registered mobile phone number. The message contains a code that must be entered to authenticate to Azure AD. Notification through mobile app allows a user to register the Microsoft Authenticator app with Azure AD during registration and receive push notifications on their iOS or Android mobile device for every MFA-enforced authentication to Azure AD. The final option, verification code from mobile app, allows the users to use the Microsoft Authenticator app or some compatible third-party application to generate one-time PINs, what are called OTPs. The application generating the PIN is a software token that generates OAuth verification codes. The use of hardware tokens at the time of this recording, these are currently in preview. The best practice, according to Microsoft, especially for highly privileged users, is to consider configuring 2 or more authentication methods in addition to the password. One reason to have multiple options is that users may not have access to all of their methods at the point of authentication. So having more than one method available will give them some flexibility. For instance, if they're at their desk, they may not be able to get calls on their mobile device, but they do have access to the office phone. Now, this is a table that comes from Microsoft, and it shows the 3 user account states when using MFA. The first status is disabled. This is the default state for a new user who's not enrolled in Azure MFA. The second status is enabled. The user's been enrolled in Azure MFA, but they have not registered, so they receive a prompt to register the next time they sign in. Non-browser apps are not affected. They'll continue to work until the registration process is completed. However, browser apps are affected. After the session expires, Azure MFA registration is required. Is modern authentication affected? Yes. When it's enabled, after the access token expires, Azure MFA registration is required. The third status is enforced. The user's been enrolled, they've completed the registration process for Azure MFA. Everything's affected. Non-browser apps, browser apps, modern authentication, it will all require multi-factor authentication. Next, I want to talk about the ways to implement MFA. On the exam, I want you to remember that the recommended way and most flexible way to enable 2-step verification for your users is to use the conditional access policy. And that's where I'm at right now. Now, we've been here before, right? We've come in here and looked at this. You go to Azure Active Directory on the main menu, and then you'll choose conditional access, and then you can go in and create a new policy. And I'm down here at the access controls area, and you can see that we're granting access, but it requires multi-factor authentication. However, this works only for Azure MFA in the cloud. It's also a premium feature. So if you have a basic account, you're not going to be able to do this. The traditional method is enabled by changing the user state. And this works with both Azure MFA in the cloud and the Azure MFA server, which you may have on premises. If you do that option, the users have to perform a 2-step verification every time they sign in, and if you're using that, it overrides the conditional access policies. So let's go back out of here, get out of our area, back to the default directory. Let's go up here to Users and see Multi-Factor Authentication at the top. Choose that option, and I can now go in and I can select a user, Tom Jones. Notice, by the way, while I'm here, I could choose a ton of users and I could choose bulk update. So this is also one of the things to be aware of on the exam, that you can do a bulk update. So once you find the user, click on Enable, and you click on Enable Multi-Factor Auth. Okay, I'm going to cancel out of here. I'm not going to do that. While I'm here, PowerShell script that enables MFA for an individual user is the commandlet set-msol user, followed by the user principal name, for example, TM Jones at whatever, then dash strong authentication requirements, followed by $STA. And by the way, PowerShell is also a good option if you need to bulk enable users. Let me show you a script that loops through a list of users and enables MFA on their accounts. So here it is. I'm creating a users variable and then just putting in a list of users and then using for each and then you can see the actual code. You don't need to memorize this for the exam, but remember, it is the set-msol user commandlet, and you can do a bulk update either in PowerShell or, like I showed you earlier, in the Azure portal. In this lesson, we're going to configure various MFA settings. First, fraud alerts. Users can report fraudulent attempts to access their resources using the mobile app or through their phone. Bypass options. The one-time bypass feature allows a user to authenticate a single time without performing two-step verification. Then there's the trusted IP setting. This feature bypasses two-step verification for users who sign in from the company intranet. And then verification methods. You can choose the verification methods that are available for your users. For example, call or text to phone. Now, although I mentioned biometrics in the introduction I just did, the valid authentication methods for Azure multi-factor authentication are these. First, there's password. This is the password of the user in Azure AD. By the way, this is a required factor and it can't be disabled. So you're combining something with the password. You could call to phone. This way, a voice call is made through an automated calling service to the user's registered phone number. The user then answers the call and presses the pound sign for verification. There's also text message to phone. With this factor, an SMS is sent to the user's registered mobile phone number. The message contains a code that must be entered to authenticate to Azure AD. Notification through mobile app allows a user to register the Microsoft Authenticator app with Azure AD during registration and receive push notifications on their iOS or Android mobile device for every MFA-enforced authentication to Azure AD. The final option, verification code from mobile app, allows the users to use the Microsoft Authenticator app or some compatible third-party application to generate one-time PINs, what are called OTPs. The application generating the PIN is a software token that generates OAuth verification codes. The use of hardware tokens at the time of this recording, these are currently in preview. The best practice, according to Microsoft, especially for highly privileged users, is to consider configuring 2 or more authentication methods in addition to the password. One reason to have multiple options is that users may not have access to all of their methods at the point of authentication. So having more than one method available will give them some flexibility. For instance, if they're at their desk, they may not be able to get calls on their mobile device, but they do have access to the office phone. Now, this is a table that comes from Microsoft, and it shows the 3 user account states when using MFA. The first status is disabled. This is the default state for a new user who's not enrolled in Azure MFA. The second status is enabled. The user's been enrolled in Azure MFA, but they have not registered, so they receive a prompt to register the next time they sign in. Non-browser apps are not affected. They'll continue to work until the registration process is completed. However, browser apps are affected. After the session expires, Azure MFA registration is required. Is modern authentication affected? Yes. When it's enabled, after the access token expires, Azure MFA registration is required. The third status is enforced. The user's been enrolled, they've completed the registration process for Azure MFA. Everything's affected. Non-browser apps, browser apps, modern authentication, it will all require multi-factor authentication. Next, I want to talk about the ways to implement MFA. On the exam, I want you to remember that the recommended way and most flexible way to enable two-step verification for your users is to use the conditional access policy. And that's where I'm at right now. Now, we've been here before, right? We've come in here and looked at this. You go to Azure Active Directory on the main menu, and then you'll choose conditional access, and then you can go in and create a new policy. And I'm down here at the access controls area, and you can see that we're granting access, but it requires multi-factor authentication. However, This works only for Azure MFA in the cloud. It's also a premium feature. So if you have a basic account, you're not going to be able to do this. The traditional method is enabled by changing the user state. And this works with both Azure MFA in the cloud and the Azure MFA server, which you may have on premises. If you do that option, the users have to perform a two-step verification every time they sign in. And if you're using that, it overrides the conditional access policies. So let's go back out of here. Get out of our area, back to the default directory. Let's go up here to Users and see multi-factor authentication at the top. Choose that option, and I can now go in and I can select a user, Tom Jones. Notice, by the way, while I'm here, I could choose a ton of users and I could choose bulk update. So this is also one of the things to be aware of on the exam, that you can do a bulk update. So once you find the user, click on Enable, and you click on Enable Multi-Factor Auth. Okay, I'm going to cancel out of here. I'm not going to do that. While I'm here, PowerShell script that enables MFA for an individual user is the commandlet set-msol user, followed by the user principal name, for example, TM Jones at whatever, then dash strong authentication requirements, followed by $STA. And by the way, PowerShell is also a good option if you need to bulk enable users. Let me show you a script that loops through a list of users and enables MFA on their accounts. So here it is. I'm creating a users variable and then just putting in a list of users and then using for each. And then you can see the actual code. You don't need to memorize this for the exam, but remember, it is the set-msol user commandlet, and you can do a bulk update either in PowerShell or, like I showed you earlier, in the Azure portal. Well, congratulations on completing the Microsoft Certified Azure Administrator Associate Live Lessons video series from Pearson. In this course, you gained a ton of knowledge about foundational cloud concepts and core service configuration and administration on the Azure Cloud Platform. You're also well prepared for the exam, which will then be your launching point to other higher-level cloud-based certifications from Microsoft and other vendor-neutral certifying bodies. If this is your first time through the course, I recommend that you go through it again, at least the areas that you feel are not your strengths from an experience standpoint. Hopefully, you enjoyed watching this training as much as I enjoyed producing it. On behalf of the entire Pearson Live Lessons team, I want to wish you success with your technology journey, your cloud IT career, and life in general. Take care.